Good morning, everybody. I would like to invite the panel to start. The first part of the panel is dedicated to the memory of Professor Guido Biscontin of Ca' Foscari di Venezia, and the panel will be coordinated by his successor, Elisabetta Gentri, professore at the Ca' Foscari di Venezia al Dipartimento di Scienze Ambientali. She will moderate, and I have to invite Professor Stefano Della Torre from Politecnico di Milano, and Professor Noni Maravellaki from the Technical University of Crete School of Architecture. Please. I don't know if Professor Stelios Bakolas from the National Technical University is here. The second part of the panel, Dr. Vlachoulis is excused from the Ministry of Culture. He is very ill, unfortunately. We have Professor Emeritus Irini Efesiou from the School of Architecture, National Technical University of Athens, Vasiliki Eleftheriou from the Ministry of Culture, Acropolis Restoration Service, Miltiadou Fezans Androniki, Professor School of Architecture, National Technical University of Athens, Spathis Panagiotis, Professor from Aristotle University of Salonika, Vlatka Rajzic, she will be connected, Professor from the University of Zagreb, Sela Diviner from Bezalel Academy of Arts, and Smiris Georgios, he is the Dean of the School of Architecture from University of Ioannina. And of course I see my very good friend Elena Konstantinidou from the School of Architecture, National Technical University of Athens. The issue, and this issue is essentially connected to the dedication of this panel to Guido Biscontin, is preserving compatibility, the materiality and integrity of structures, and architectural authenticity. And that's the interdisciplinary content of the major guidelines for the preservation of monuments. You cannot dissociate architectural authenticity from structural integrity and from materials compatibility and performance. That's the issue, and that's what we are talking about. Can you please put on the video for Professor Biscontin?
honored to be here with my colleagues and friends, Professor Antonio Moropoulou, Professor Noni Maravelaki, and Professor Stefano Della Torre. Before starting with the discussion on authenticity and compatibility, I would like to briefly recall the professional figure of the professor, Guido Viscontin, who passed away last year. Professor Guido came from University of Padua to Ca' Foscari University in Venice in 1987 as a lecturer in chemistry for the restoration of cultural heritage. He became a full professor in 2003 and retired in 2012. Guido Viscontin had more than 50 years of experience and was one of Italy's leading experts in diagnosis and conservation of cultural heritage. He studied the behavior of materials in different environmental contexts and developed innovative technologies to preserve cultural heritage. He founded the School of Chemistry for Conservation at Ca' Foscari University and the first degree course in Italy in chemistry and technology for conservation and restoration. He published over than 200 articles in national and international journals. His studies include those on the Temple of Amenophis in Luxor, the wall of the City of Rhodes with Professor Moropoulou, the Chapel of Nativity in Nazareth, the Chapel of the Holy Shroud in Turin, Palazzo della Regione, the Municipal Theatre of Rio de Janeiro, and many other important buildings around the world. He was a great teacher to all of us. He taught us to approach conservation issues by considering materials and the environment as an unicum. Thanks to his experience restoring extraordinary cultural heritage, he was among the first to understand the value of interdisciplinarity. Starting from 1985, Guido Viscontin with other visionary colleagues, Stefano Della Torre, gave life to the annual meeting Scienza e Beni Culturali, which proposed and still does different topics related to the conservation of cultural heritage and always dealt with an interdisciplinary approach. In this framework, compatibility has evolved with the contribution of experts from the academy, superintendencies, public and private bodies, restorers, and producers. He was imaginative and able to solve critical situations thanks to an enormous knowledge of chemistry and the ability to identify the essence of the problem. We'll miss him, but his cultural and human legacy will always with us. Ciao, Guido. Okay. The presentation, please. Thank you. Okay. Next one. And the next one again. Thank you. The last. No. The last. Sorry. Oh, sorry. Okay, thank you.
No, it's okay. The big one.
Yeah. Yes. Okay. We can look at the photos again, but at the same time, I would say something about the teachings, the Guido Viscontin teachings in particular. I would like to show you, as a suggestions for the panel, photos after this presentation. A photo of the Great Mosque Yen in Ma. at the same time, I could also remind the definition of compatibility. Compatible means in harmony with. There is a need to find a mediation between the extremes or fully compatible or fully incompatible, and to be able to use this concept in every situation. Built heritage and archaeological sites are contexts where compatibility is put to the most demanding test. Authenticity is instead a condition that must be fulfilled to attribute value to something. This is very important. The discussion around authenticity is a significant source of debates and within the World Heritage System. So we have two very important concepts, compatibility and authenticity. And we have to make a link between these two concepts, two ideas. And in this context, I would to show you the photos of the mosque. Showing you the photo of people annually participating in plastering the Great Mosque of Jen in Mali. During plastering, the people work together to repair and rebuild a mosque, the largest mud brick structure in the world. The materials used by the people in the mosque restoration are compatible with the original ones. Despite the importance of this conservation action, the authenticity is probably compromised. So the question is and based on the teachings of Guido Viscontin, is compatibility enough, or we think we have to follow some authenticity criteria, and if so, can we suggest a way to mediate between compatibility and authenticity? And now I leave the floor to my colleagues. Stefano Della Torre, yes?
Thank you. I have got a presentation as well. Okay. Okay. First of all, I want to say that it's a great honor to be here in this in memoriam panel. I met Tonia Moropulo the first time in Bressanone, I think. And yes.
30 years ago.
Yeah, more or less. More or less. And okay, for me it's impossible to divide the memories. Okay, the memories about Guido as a scholar and so on, and Guido as a friend, with our long breakfasts in the Elefante Hotel, where he used to arrive first very early in the morning and to have breakfast with 2-3 companies, changing every morning before starting the conference. But we are here to speak about a point which is referring to Guido's legacy in terms of scientific research and so on. on, and I'm not so clever. Okay. Speaking of compatibility, I use to refer to a paper, a very old paper as well, by Piers Mars. Here the footnote is not written, but why or what do we mean when we speak of compatibility? We speak of compatibility when there are some differences. So there are 2, 3 materials who have to work together, to stay together. But these differences are not enough. There should be also a changing environment. Otherwise, it is not interesting to speak of compatibility if in a steady environment. The problems arise because there are changes in the environment, challenging the differences. Then there is also a threshold of permissible changes, permissible damages we go to accept. That is, we make a step from saying you can put together only what is perfectly equal to each other. Okay, thank you. To another condition where we speak of compatibility, not complete, not completely incompatible, not completely compatible, because there is something in between, and we can discuss what is acceptable. So, there are processes, and we have to understand which processes can be permissible and which are not permissible. This is a matter of our research, and it is simple in theory when we speak of new treatments, of conservation techniques. It is clear then, this is one of the slides I use with my students, when you add something, you should be sure that you don't add something which can foster processes which could provoke decays and so on. But there is also what we call the inbuilt incompatibility. We don't deal simply with something and we add and we have concerns about what we are adding, which is a good example of responsibility, of course. But we find in historic buildings materials which work together, but they should not. And this is an example. In a church, in a Baroque church, we are not in Mali, we are in northern Italy, near to the Swiss border. We find stucco statues, and they are in very different condition. One is almost perfect, or it was almost perfect. The other one has a very, very severe decay. But they were made by the same artist in the same time with the same materials. The problem is which were the materials used. Because the very good artist made the body of the statue with gypsum, and then he covered the statues with a very good lime mortar with magnesium and marble powder. So it is a very good fake marble statue. But the two mortars he used, seeking the best performance of each mortar, so the gypsum for the body to work very fast, and this kind of marble, fake marble coat to have a very good surface, very white, with a very good light and so on. Wonderful and definitely not compatible, or compatible until the environment is dry. But when water comes, it is like a bomb, which is epsomite. The name, it is epsomite. So more or less 5 times the volume when the salt forms. So there is a chemical incompatibility which is active or non-active depending on the condition we can ensure. This is a very important lesson to learn. In my opinion, I try again. Very good pictures, I think. I don't succeed. Okay. So, the lesson I learned, and it is something I told one time in Bressanone, so, okay, I'm repeating myself, but there is a reason. The lesson we learn is that, okay, no. Too much? Thank you. Okay, it's a matter of hand, okay. The lesson we learn is that even if there is incompatibility, you can manage the incompatibility if you can keep the system in the compatibility field. So the point is we can identify the compatibility field and we can conserve something which has an inbuilt incompatibility, and this is very often our task. We conserve systems which are very diverse. When we speak of churches or historic houses, we have many different materials, and if you had to follow the guidelines for preventive conservation in museums, it would be impossible to conserve a historic house because you have too many different materials in the same environment. You have to find a balance. And this is a matter of management, actually. So, okay. So, authenticity. I definitely endorse the definition given. Authenticity is a condition to value something. But authenticity nowadays is understood as a multi-dimensions issue. We have different approaches. We have, I think that today, one of my PhD students from China will speak of authenticity, discussing, because it is her task. She wants to introduce planet conservation in China. Yes, it is very interesting. We have to start from the different approaches, because in Italy, we started from conserving material authenticity, and prevention means to avoid substitutions. What about China? Can we discover, for example, a point when also in China there was a a maintenance to repair just in time and not simply to remake everything, because maybe everywhere in the world there is a matter of economy. Of course, if you build with mud, the only choice is to remake the mud surface every spring. But, okay, this is a matter of... We understand that authenticity is a different concept in different countries, in different cultures. Anyway, everywhere we work, we should have authenticity as the focus. Conservation without authenticity has no sense. So this is the point in my opinion. The next step is that, and this is the Italian framework law on preservation, conservation is not the product of a single activity, but of several activities which are made consistent, coordinated and planned. And you get conservation only if you are able to coordinate and to connect and to plan the different activities. Prevention, maintenance, what we call restauro. It is difficult to translate because there is always a false friend. Compatibility is a focus in any phase. Always thinking in terms of managing the differences we produce or we find in historic buildings. But this means that we manage the object and we manage the environment. And this means that we manage a whole system, and this is a highly multidisciplinary task. So, not to praise Tonia, but she deserves to be praised, of course, but what this conference, as the Bressanone conference used and does, is to put together scholars from several different disciplines and also practitioners to reason about the needs of the sector and to reason in a multidisciplinary, with a multidisciplinary attitude. This is the point, and that's why we can keep together the very micro level. We are discussing of salts and soluble salts and macroeconomy, as we were discussing yesterday about managing cities, historic cities, of course. We can have the same way of thinking in keeping together all these levels for the sake of keeping authenticity, managing incompatibility, which is more or less my conclusion. And okay, thank you.
Okay, now Professor Noni Meravellaki, please, the floor is yours.
Thank you, Elisabetta. Good morning, everyone. I'm very honored to be here. Thank you for this invitation and the possibility to have organized this conference, very important conference. First of all, I would like to speak about Professor Viscontin, who was the supervisor of my thesis. I may say that I'm a little bit emotional, and I'll try to express briefly what Guido Viscontin contributed in the science, and especially in my case also. Professor Viscontin was one of the leading Italian and international experts in the field of diagnostics and conservation of cultural heritage. He coordinated important research on the knowledge and preservation of Venetian international monumental architecture, and especially on the foundations poles of buildings in Venice. These researches have produced a remarkable scientific, operational, and experimental progress in the physical, chemical, and structural knowledge of the construction materials of monuments, little studied in the past in this substantial and interdisciplinary way. Windobis continued with more than 50 years of experience, applied these diagnostics in the field of conservation of cultural heritage, and was involved in the study and development of technologies, products, materials for the conservation and restoration of cultural heritage, and the study of the interaction between materials and specific environmental contexts. He was the founder of the School of Chemistry for Conservation at Ca' Foscari, and of the first degree course in Italy of Chemical Sciences and Technologies for Conservation and Restoration. He was a great teacher for all of us, and he taught us how to deal with the issues of conservation, considering materials and environment as a unique interactive system, as mentioned by Elisabetta also, in which the interface plays an important role. Thanks to his experience in the restoration of extraordinary works, he was among the first to understand the value of interdisciplinarity. He was an imaginative man. He managed to solve critical situations thanks to this knowledge of chemistry and the ability to identify the essence of the problem. And people who had been able to work with Guido were thankful to him for the enthusiasm and the passion he was able to transfer to many young colleagues. I was very fortunate to be my supervisor of my PhD thesis, and I learned a lot, and I fully recognize that my formation was shaped by Guido guidance. He led with clear vision, important reasons related to one of the most fascinating subjects in the world of restoration chemistry, this material-environment interaction, as I told. He early recognized before many others that this topic would be of the key topics regarding the built and cultural heritage. With his passion and scientific efforts, he earned the esteem of the entire international community and constituted for many years a recognized scientific reference in the field of conservation of monumental buildings. He was a simple person, but full of interest and capable of visioning. He formed an important school and left a legacy of quality students and collaborators. We who knew him certainly remember his affable character, his sociability, his smile and quick witticism, as well as his great professionalism and foresight in bridging chemistry and restoration, not only Venice, but elsewhere. We will miss him, and his cultural and human legacy is with us, and we feel very grateful for having been supervised and learned by him. Inspired by his example, we will continue his work to safeguard the cultural heritage, feeling accompanied by his great intelligence, competence, sensitivity, and availability. Ciao, Guido. Thank you. Regarding the terms of compatibility and authenticity, I would like to add some thoughts about that. I think that we have to rethink and reconsider the term of compatibility, since nowadays we have to face the sustainability and the longevity of the materials. And especially this sustainability and longevity in front of a completely changing environment. This means that if we have studied up to now the compatibility in terms of physical, chemical, and mechanical properties, and this compatibility was identified by the definition and measuring and calculation of these properties, nowadays we have to think that those properties have to be reconsidered and put something more, because we have extreme changes, and the term of durability should be also considered when we are talking about compatibility. Two materials could be compatible, as Stefano presented before, but when the environment changes, those materials could be behaved completely different. Therefore, we have to define new terms regarding how the compatibility could be referred and could be assessed, not only with the most common properties and methods that we have applied up to now, because we have this changing environment. We have to consider these life cycles of materials, the life cycles as existence of those materials, and therefore these terms like the durability of the materials and their possibility to be combined in this continuous way with the other means of the building could be presented in the future in a degradative way, and therefore we should to pass to new definitions and not to the properties that we have already studied. This is my opinion. We are in front of a new changing environment, and therefore what we have thought up to now about compatibility should be enriched, should be reinforced, and maybe we may have in that when we are speaking about compatibility, this is the first requirement of the sustainability and the longevity of the materials. But it is not enough. We have to think about it and to enrich it. Thank you.
Thank you, Nani, for your reflections and words. And I leave the floor to Professor Antonia Moropoulou, but about what was told. Since now, my fear is wishing to consider all the variables involved in compatibility and authenticity. We often suggest operating sequences that are too complex and only partially and rarely applicable. So what I want to suggest is something of really applicable in the real case studies. This is what we have also to suggest. But now I leave the floor to Antonia. Thank you.
Thank you, Beta. I was lucky as student to have the commemorated Professor Thodoros Koulikidis as my teacher at the National Technical University of Athens. But in my years of exercising the profession to rehabilitate, preserve, and restore monuments, it was Guido Viscontin, the person who taught me how to think. And if Thodoros Koulikidis was insisting that every monument is a unique case, and for every monument you need to make a case study, Guido Viscontin was implying something more, and I expressed it in this slide. Usually Marinos Ioannidis is following this statement. So I used to say that monuments talk, and we have to listen to them. And we have to follow what they have to teach us. This is the essence of teaching in this specific field, to listen to the monuments. And of course, in order to understand the building, for instance, an historic building, you cannot dissociate it from its environment. And that was an issue where Viscontin was highlighting his study on every monument. You have to read at the interfaces between environment and materials, between materials and structure, and how all this complex system of materials on the structural model, they are combined, because they do not exist out of the structural model. How do all this follows the lines of the architectural design, the authentic one, and how it reconstructs it when it is restored. That means studying the monuments together with Viscontin, and here in Knossos, we first established this concept of incompatible materials. And in a second stage, after discussing it in the international community, as Betta and Stefano said, at the Bressanone Forum with the Ephoriates of Antiquities in Italy, we developed the second step, which was the compatible materials. In Knossos, the reinforced concrete restoration of Evans at 1920 has actually corroded the initial authentic materials. Why? What is the meaning of incompatibility? The meaning of incompatibility, as was explained by my colleagues, concerns the performance of materials. And here is another teacher, a very alive teacher, Professor Tassios, who used to say, and he is still insisting, and I'm with him, I'm following him in that, because I understood that in practice, that the materials are performing on the structure and within the environment. So what's the compatible performance? First of all, from the physical and mechanical point of view, if you are having stronger materials, because the ideology, the current ideology was to use the cement concrete in order to go to higher stiffness and in order to shield the structure from the earthquake risk. That was the mentality of the initiation, the first years of the 20th century. And this led to distractions. Why? Because even during the earthquake, the frequencies were testing the materials in different ways. We had a different motivation of the materials when they were stiffer than the other ones. So they were the one against the other. And what we had fractures. We had distractions, we had failures. But it's not enough to speak only on the physical and mechanical level. On the physico-chemical level, what we understood was that the materials with different microstructures in the environment were performing in different way. Why? Because they were not breathing in the same way. A very dense microstructure with very small pore radii was not uptaking the water. And if not, and another material nearby was inducing water in higher rates and higher proportions, then that is an incompatible system. Incompatible because the one was under the pressure of evaporation and the other not. That was developing different internal energies, distracting the enthalpy equilibrium within the material system. And that was expressed on the macro level as fractures, distractions, and failures. So we had a mechanical result out of physico-chemical reactions of different materials with the environment. And that was the reason that we started our common work in the field of monuments preservation, not attacking to the cement concrete, because modern cement concrete structures are very good. But cement as a conservation material was not good. It was incompatible, and we changed this line. I have to say that, of course, our question was how could diagnosis act as an input to design the proper restoration mortars? That was another question that was developed, and that was the journey to the compatible mortars and compatible materials, which, to my opinion, had to be performing as well. So we were always speaking of performing and compatible materials. We could never dissociate mortars from their structural role within the structure. So it was compatibility and performance criteria, the ones we developed in order to work in structural systems. And that's why the reason of, I'm so sorry. That's why the reason that Professor Maravellaki said we have to renew our definitions was that we have to include always together compatibility and performance. And if you do consider these both all together, then you overcome the term of durability. You go to resilience. Because we don't need durable in general materials and structures. We need resilient materials and structures, resilient to the stresses that are exerted upon them, either from the environment or from the structure or from frequencies, like, for instance, earthquake frequencies. And that is what we need, but we need to know in depth what we are handling. That means how to develop acceptability limits for restoration mortars, for instance. They should be based not only on mechanical performance and durability, but on physico-chemical as well. And that was what we have done in depth with Guido Viscontin, and concerning this slide with Professor Asterios Bakolas as well. I'm sorry he's not with us. I hope he will come. Because we studied the microstructure of the mortars, and we based the acceptability limits upon these measurements. And of course, in order to design new materials which should be compatible, we had to respect the limits above which the materials were becoming incompatibles. And the tools and methodologies were mainly what I registered as reverse engineering under the stress to develop the restoration mortars for Hagia Sophia in order to perform against the earthquake risk of 7 Richter. And Viscontin was working with us as well, and we were working with the structural engineers, the Professor Chakmak from Princeton and Professor Erdik from Bogazici University, starting at NTUA with Professor Tassios, who permitted us to assess and evaluate the mechanical strength of these mortars. These compatible restoration mortars, which were based on the knowledge of historic mortars, were assessed and evaluated according to the classification of historic mortars second to their hydraulic features, which we studied through thermogravimetric and thermoanalytical techniques. And our studies, which were published together, are classical studies for this field. Of course, with Beta and Noni, we have together many publications on this issue because, you know, actually that was a school, a common school we developed. And according to them, we studied and we reproduced the mortars that were applied to Hagia Sophia, following the historic mortars, which Professor Tassios was calling Byzantine cement when he measured in his laboratory the strength of this mortar. I'm sorry. We studied that the first part in Venice with SEM-EDX and the second part in Princeton with transition electron microscope. And we understood that the character of these mortars was this semi-amorphous formation of the hydraulic faces, which was enabling them to absorb the energy disseminated through the earthquake in a way that they were better structured and not failing. So the mortars were better structured, and that was assessed and evaluated on structural level with finite element models in order to define the level of the requirement of the strength of the mortars to be applied, because they should be compatible, but they should be performing as well. And that was, I'm sorry, and that was something that had a practical value, because after our introduction and suggestion of these materials to the Council of Hagia Sophia Museum, they were applied for the earthquake protection of the monument in early June '99, and it was sufficient enough 3 months before the big earthquake in Turkey, in Istanbul, at the 17th August '99, which did not distract Hagia Sophia. And it was written in nature of this period, shaken but not stirred. From this experience, we passed on the development of new materials on industrial level, and we have to change this. We have to change this. I think we have to give as a donation to the Eugenides Foundation, which is kind enough to host us here. We have to give a new one, because it is terrible not to can pass from Hagia Sophia to Holy Sepulchre. Dimitrika, okay. Very good. So, passing to Holy Sepulchre, in order to study the historic mortars and characterize them in their variety, and in order to decide which should be the mortars for restoration, we had already produced on industrial level, first with Pazza Bartolo in Italy, and then other companies undertook this legacy of Visconti. And they produced sometimes some types of metakaolin lime mortars, which were presenting the highest possible strength, but with a compatible microstructure, compatible to the very high pressures of thermohydrate stresses that were exerted upon Holy Sepulchre. So when the custos of the Holy Land asked me, but my conservators say that you don't use proper mortars in the restoration of the Holy Sepulchre, I said, these are compatible and performing for this reason, but I will invite Professor Viscontin to explain this to you in your language. And Guido came, and it was accepted. Of course, my friend Gabriele Favero is laughing, but you know, we are Mediterraneans, and in Jerusalem we had to be together, Greeks, Italians, all together, and of course the Israeli antiquity authorities there. So I don't want to insist in details, and there is no reason, but I want to tell you that it was not only an academic school that we developed all together. It was an authentic learning, because we were working together, not only with industry, and we were producing new materials, and we were assessing and evaluating new materials, but at the same time, we were applying them, and we were assessing and evaluating these materials on the level of real structures, real monuments, real complexes like the medieval city of Rhodes. And today, engineers are still applying these materials, and they know why. I see my friend Vasily Zafiris here, who was with us at the work site, responsible there in the Holy Sepulchre, and who is now restoring the Catholicon of Varnakova with the same materials, because they seem to us that they are the required ones. So I don't know if I can go further. Yes, I can go. We always assess and evaluate these materials utilizing the finite element models and assessing mechanical performance on site and by basic measurements. And I would say that these materials are under evolution, because the question that Professor Maravellaki posed about longevity and sustainability has to do with not only with materials, but with the integrated, the interdisciplinary study, and how to pass from the coordinated study with the civil engineers to the study with the architects, and decide what to do. I'm sorry, I cannot. Okay. How to go from diagnosis to redesign, architectural redesign. That is a question on which we will discuss in the second part of this session with a major contribution of civil engineers and architects. And I would like to finish without tiring you anymore with a few words saying that what Viscontin developed in Venice, in Bressanone, in Greece, working together in 400 monuments all around Mediterranean, was not only a school, was not only a reality. it was a vision implemented, and here, through this conference, we promise to continue implementing this vision. Thank you very much.
Thank you, Professor Moropoulou. Okay. Now, or Professor Stefano Della Torre, would you add something?
Just that we will do.
Thank you.
Thank you, thank you. Okay, we go through the second part of this session.
Professor Marinos Ioannidis would like to add something.
Sorry. Yes, please.
Yes, I would like to add something, but previously I would like to ask Tonia if it's okay to show us the slide one with the famous one with the memories. The monuments are talking. Yes. And congratulations, yeah. It was a nice moment to recognize the memory of your colleague. Yes, that's, I think, the greatest challenge for this century. And I'm sure that on the time of the artificial intelligence revolution, it will be possible. And not only to tell their story or history or whatever they went through, or about those who contributed for the good or the bad situation, or the memory of the buildings. It is, I think, for the ICT at least, one of the greatest challenges, and and once when the time comes and this is achieved, then I will say that we started the momentum to say that we have a real digital documentation of the monuments, and that's very, very important. Very, very important. Imagine that you stand in front of this building. That's from Rhodes, isn't it?
Yes, indeed, it is Rhodes.
Yes. Imagine that you stand there in front of that building, and the building start talking to you, or you can communicate even with the building.
That was my childhood, and that's
Yeah,
why
that's
was
going to come.
concerned with
That's going to come.
monuments.
That's going to come. Just think how it was 50 years ago. The time with the technology in your laboratories, or even now, just only that. And how it is now with the communication with us or among us, yeah, with smart devices. The time will come. Yeah, thank you.
These are the common publications, some of them. Please, can you go on? 3 pages of common publications.
Okay. I tell to them that they have to be attuned at the vibration of the monument, because each monument has its own vibration, and you cannot feel, or you cannot work correctly if you are not tuned to this vibration.
Absolutely so. And when we opened the Tomb of Christ at the Holy Sepulchre, and I went out, I said through National Geographic to all humanity that this monument is alive and talks to humanity.
Okay, sorry. If I can add something to your observation, Professor. I partially agree with you, because I think that ICT can help us in collecting all the information, but the elaboration is in our mind. It's not an ICT.
Absolutely.
Sorry.
We all agree with you, Beth.
Yes, but
Yes. Yeah,
Κυριάκος,
please.
From what I understood, Professor Guido Biscontini was a pioneer of compatibility, and of course you, the STEAM panel. Do you think that from the discussion you had earlier that we are moving to the next step? I mean, we are moving from physicochemical and structural compatibility to compatibility of resilience and sustainability, because that's what Professor Maravelaki mentioned. Thank you.
Again, sorry, but again, we must simplify this problem, because at the moment we have many keywords that are linked with chemical, physical, mechanical characteristics, but also social issues. So we have to simplify this complex system. I think we can start here, but we have to think about this opportunity to simplify.
Could you please come, Professor Efeseu, Professor Miltiadou, Professor Constantinidou? No, you can still stay. Professor Efeseu, Professor Constantinidou, Professor Miltiadou, Professor Spathis. Δεν έπρεπε να φεύγουν, αλλά αφού φεύγουν, I don't know. Please, Adi, and we will be connected with Vlad Karaisic. Please, Beta, please. You still coordinate. So, Dr. Vlachoulis from the Ministry of Culture, Directorate of Restoration of Byzantine and Post-Byzantine Monuments, is excused, he is ill. And from the Ministry of Culture as well, Mrs. Eleftheriou, who is the head of the Acropolis Restoration Service, has sent her intervention in written way, but I think we can read it later on. And please, Beta, start with Professor Efeseu.
I'm honored to present you, to introduce you, Professor. Okay. I leave the
So, I'm an architect. So now you will have to listen to civil engineers and architects and another glance, another approach to
Integrated, I hope.
integrated, of course. And this is, I think it is something that we have won the last 20 years, that the protection of cultural heritage is something interdisciplinary, transdisciplinary, multidisciplinary, and this is a great achievement, I think. 20 years ago, we did parallel researches. We surveyed the monuments in parallel. The civil engineers had learned how to work with the architects, but all the others made parallel surveys that in the end could be very difficultly combined. Now, we all work together, and that is very important for the monuments. As I will have to leave at 11 o'clock, in the beginning, I just want to make a small parenthesis. I disagree with Professor Ioannidis. I think that we must listen to the monuments alive. We must touch the monuments. We must touch the materials. We must understand. Professor Tokmakidis, from another point of view, said that the engineers must be there. They must understand the monument in the surrounding. Of course, if we make a digital archive, it is something very, very important, but the person who makes the digital archive must have spent a lot of time in the monument, around the monument, studying the history of the monument in order to leave an archive which will be for the next generations, useful for the next generations. It's not a problem of images. It is a problem that even the design processes have solved, and they have different layers. They have historical layers, they have architectural layers, they have structural layers, and they have all chemical layers. They have all the information needed, and the person who tries to study the monument can combine the layers or study each layer differently. So I would like, unfortunately, I did not know Professor Viscontin, but I would like to add that he had a very human glance, a very human regard, as the French say, which is a very sensitive glance, and this is very important for the monuments and for the work of each person. And so when we have 5 words, 5 different definitions, 5 different qualities. These qualities, something which I believe is very important, is that they're not everlasting. They constantly change and get enriched through the years. And that is very important, because at the beginning we thought that, okay, we have the Venice Charter, 1964, finished. Everything was discovered. It's not like this. Every year, all these definitions get enriched. And I would like to propose, as this, I think that this discussion is very important, if we could write down all the approaches that we say today, and we make a catalog that can be enriched. Okay. And this could serve also for ICOMOS, for UNESCO, for our universities. It could be very, very useful to see all these definitions from the different ways that we see them, as we are the different kind of engineers. We can be historians, archaeologists. So I would like to add the tangible and the intangible approach to all these definitions, or to all these qualities, and the different cultural definition. If we have another culture, then, as you said, Chinese have a different view towards authenticity. So, and from our Erasmus courses, we see that the people in Turkey have a different approach than the people in France for their monuments. So I would like to add that we can see all these different qualities, seeing the tangible and the intangible heritage, and the symbolic and the metaphorical part of these qualities. Okay, we spoke about, I'm an architect and I used to teach construction, so I will add another point of view. I will not speak about, very much about materiality, because all the colleagues have spoken a lot about materials, but materials are not only their chemical point of view. They have a lot of other characteristics, and the architects have a lot to say about the materiality. Sometimes we even describe a building from the materiality. I think that my colleague Elena will say more about the materiality. Compatibility. The last years we speak about compatibility more if we speak about our computers. Is the system compatible with the other? But in construction, compatibility is something very, very important. With the civil engineers, we have studied very much the buildings during earthquakes. If one system is not compatible with the other, if we have renovated a building and repaired the building with a system, let's say reinforced concrete, which is incompatible with the pre-existing systems, then the building will fall down. So compatibility is something very, very important. The integrity of structures. The integrity, the cohesion is something very, very difficult. After the repair and of a building, and it's what we want to have to succeed, to have a real integrity of the structures. Also, it's not only the structure, it's not only the building, it is the integrity of a whole, it is the integrity of a village, it is the integrity of a complex. Professor Constantinidou will tell you more about this. And in the end, I would like to speak about architectural authenticity. It's a very difficult thing, very, very difficult thing. I think that Professor Moropoulou, who gave this very important title, TMM-CH, Transdisciplinary Multispectral Modeling and Cooperation for the Preservation of Cultural Heritage, has added recapturing the world in conflict through culture, promoting mutual understanding and peace. Well, I think that this very sensible title of the Congress, which is not only technological, as we're not speaking about all these from a technological point of view, has also the human part of it. Now, if we come to authenticity, it is a very, very complex thing. It is very important. Some architects say that authenticity is A to Z. We start and end with authenticity, but what is authenticity? Is authenticity the authenticity of materials, or is authenticity a larger point of view? Is it a symbolic approach to a monument? We have the example of the Mostar Bridge, who has gained the higher award, and it was totally reconstructed. Some years ago, it could not be thought as authentic, but we can understand, and if we read what all these wise men from UNESCO have written down, the symbolism of a monument created with the same materials and for the same reason, a bridge of friendship reconstructed can be authentic. So I think that Professor Maravelek said that perhaps we could put sustainability in the catalog of all these characteristics. I think that it was very important that you opened this discussion. It will be very important to have them all written down, and perhaps in another Congress we can even yes. So thank you very much.
Thank you, thank you. I would like to leave the floor to Rajčić Vlatka, professor of the University of Zagreb. online? I don't know.
Yes,
Yes.
civil engineer.
Civil engineer.
Can you connect, please?
Can't hear you.
We don't hear.
Prepared one presentation, if it is possible to present. I don't know if I can share.
Yes.
You can share.
Yes, yes, of course.
Do you see anything?
Yes, yes.
So I will just tell you something about our experience after the two quite high earthquake for our country. That really this problem with the compatibility and knowledge of the material was very low over the in this process of restoration of the cultural heritage. So this presentation by Professor Moropoulos was very, very great and should be disseminated in all the countries regarding the compatibility of the materials. I think a very large gap in this field is in all the countries as far as I could understand, and I traveled and been on the lots of projects. What I would try to introduce is more to use the bio-based materials, not only in the new buildings, but you can see here in Denmark how they somehow their cultural heritage. It is the dog houses, which are very old, and they turn it into offices using the same type of structure, which is totally without any glue or any other. It's a totally bio-based materials with capillary joints. So my idea is also to use some materials that are not very much being used up to now because I'm a structure engineer, into the structures, and I think they are very compatible and they are very efficient. So we can see it is possibility is of course to save some very important cultural heritage characteristic of the building, like facade, but inside, for instance, lots of hospitals, lots of schools, lots of museums, and some other type of buildings in which the function inside in some old buildings are totally with the new instruments, with the new systems, with the new installation. It is very hard to work in the old buildings, which were designed for another purpose, and this whole system is not compatible. So in the recent time, there is a lots of direction, not only into bio-based because it's breathed, it's much better materials, but also to somehow put inside, if it is possible, of course, if it is total protected, it is not possible. But in some cases, if it is a regular building, like we had a building stock, which is old, it is not so, very unique and very characteristic. We can, for instance, save like here in some industrial heritage, we can save facades or some important elements, but we can also combine with new materials. These are the materials wood-based. It is not the solid wood, of course. It's either laminated timber, cross-laminated timber, laminated veneer lumbers. You know that there is a lots of very good solution inside either the floors, which are timber-based, or either the roof structure, in which we had lots of very, very good solution in the recent time using wood and with the help of the new connectors, which are great. For instance, this is a classical retrofitting of the old floors with, as I prefer, lightweight concrete, not the concrete, and also there is a type of concrete, lightweight concrete, which is based on the kaolin, as what already said, so not a cement based. It's more natural. So inside some retrofitting, which is mostly in recent time oriented to the seismic retrofitting, we don't have to put everywhere concrete. For instance, as a structural additional elements which retrofit and put much higher seismic resistance. These are, for instance, CLT cross-laminated wall with dampers which are at the level of the foundation, and connecting with the existing masonry wall, it works very well. So it was tested. You don't change anything. You don't put concrete. You don't put chemistry. You don't have this problematic chemistry between mortars. Also, it's very questionable use of reinforced plastics meshes, which are very much used all around the world because of the compatibility with the mortars. We saw in very much of the PhD, which took long-term effects of FRP or any other plastic reinforced meshes. They are just dissolved after the certain amount of time. So regarding the durability, it's just after 20, 30 years, it's like putting nothing into the reinforcement of the structure. As we know, also some very, very significant monuments also took that direction, and for instance, Notre Dame took this part, that path, that retrofitting, and the whole works on the Notre Dame was also oriented as much as possible to the natural-based materials. For instance, we can see that the wood, laminated wood trusses and the arches are very much used all around the Notre Dame. I think it was very, very smart way to go. Also, for instance, preparation is also glass. I think it's also very good idea. We can use the panels, glass panels, but also we can use glass bricks. Glass bricks, very high stiffness, very good bearing capacity of these elements, totally transparent. We know that, of course, the roofs are usually, for instance, interconnection into all parts of the city. We already use, and it was, we have a very good experience with the glass. Also, we can see some restoration of very important objects where we also use where the architects use the glass. So we can see on the left side, I usually prefer avoiding any kind of concrete. So for me, the right side is much better solution regarding the aesthetic value. If we have a brick walls, and you see the restoration with the cast iron facade is very, very nice. So regarding the roofs, you see how could you some domes and type of roof which are curved. It's very easy to solve in the wood and very beautiful. So for me, in lots of the cases we can use the new materials inside a very important or less important object, but of course it must be studied, as already said, interdisciplinary with the conservators, and everything should be in the same spirit. The main part and the main thing which should be stayed in the object is the spirit of the building. And again, one example with the glass structure, one example with the glass bricks, and we can also make glass columns. So glass is a very, very good material, very, very large capacity. It's a new, we have also new Eurocodes for the structural glass. So the glass, we can use the beams, columns, as well as in any other buildings. Also here we have a very nice introduction of the glass, as well as Apple Covent Garden, where they use it not only for the stairs, but also for some structural elements while they retrofit the building. So it was just one of examples, because some of the other people will talk about something else, but I wanted to share something that is my way, my approach, how to introduce a little bit more bio-based materials which are natural, which I think more compatible with the old materials.
Thank you, Professor, for your contribution. Thank you again. So there are probably many levels of compatibility in relation to the actual needs of the monument or building. This is another issue. I would like to leave the floor to Konstantini, to Elena. Elena. Okay. Thank you.
Hello, everybody. Thank you for the invitation to join this interesting panel. I'm Elena Konstantinidou. I am an associate professor at the School of Architecture. Great. Okay. Where is the difficult, strange thing? Okay. So, I am here as a representative of the interdisciplinary postgraduate program of the NTUA, the Protection of Monuments. It is a program that is organized from the School of Architecture with the cooperation of the School of Chemical Engineering, the School of Civil Engineering, and the School of Rural Surveying and Geoinformatics Engineering. So interdisciplinarity is the main characteristic of this program, which involves teachers and professors from different disciplines in a creative cooperation. The purpose of the program is a deepening and specialization of qualified scientists in the methods and techniques of an integrated interdisciplinary approach, research, cooperation, and dealing with the multidimensional problems of the protection of monuments. And it offers two distinct directions, the first of the School of Architecture and the second of the School of Chemical Engineering, focusing on the conservation of building materials. So I will try to approach the issues discussed in this panel from the point of teaching, mainly from the side of architects within an interdisciplinary environment. Could you please make it smaller, because I see, yes, sorry, because it was I could see my picture. Okay, so starting from the theoretical core courses, that involve these concepts and their evolution over time through doctrinal texts, international charters, guidelines, declarations, recommendations, and conventions. Let's take, for example, the concept of authenticity. Initially, in relation to the tangible aspects of heritage, from the Venice Charter, you already heard about this, in 1964, as the concept of historicity, up to the 4 criteria for the assessment of the authenticity of heritage structures, the design, the materials, the workmanship, the setting, and later, authenticity is related to the intangible aspects of heritage, while in very recent documents has moved beyond the physical aspect of heritage to the social and intellectual structure, as a constant correlation, not solely to the initial structural and material quality of the architectural formations, but moreover to their initial cultural and political correlations considered within the cultural context to which it belongs. Besides this theoretical framework, the concepts we are discussing today are included in the lessons in various and multiple ways, depending on the specialty and approach in a broad context from the monument to the site. The concepts are dynamically involved, from courses related to the analysis, documentation, evaluation, to the conservation, restoration, protection, promotion, design of historical buildings, monuments, and sites. And of course, the field words and the final dissertation demonstrates in practice the field of knowledge application produced in this postgraduate program. In particular, at the level of proposal formulation, strategies, methodologies, and techniques, as well as the planning of interventions in historic structures or entities, the issues we discuss come into play. Compatibility of the moment in its new life, of the new use in the historic structure, of the new architecture in the historic environment, the capability to be consistent, in harmony with itself and its surroundings, in strong relation to the issues of integration from the architect's point of view. And the value of architectural heritage is not only, as we all know, in its appearance, but also in the integrity of all its components as a unique product of the specific building techniques of its time. Not only the architectural elements, the materials, the color, the quality of the original building construction, but the inner balance, the wholeness, and intactness of cultural heritage and its attributes. Materiality, I'm not going to say a lot, Ms. Efesiou, because all of these people are experts in materiality. So I will only say 2 words, because we know that it's an important issue that each specialty approaches and studies in a different way, and it forms an important role in architectural practice, defining critical aspects as applied use of various materials or substances, but also as a concept that recently emerged as an important element due to advances in digital fabrication and digital science. So, concluding, I would say that there is a universal consensus on the importance of the concepts discussed in the conservation process of heritage. These concepts are related and interact, although sometimes confused, due to a lack of clarity to the ways that can be defined and evaluated, also to the ways that they are applied to live alive environments as a dynamic phenomenon that can change over time, evolves, constantly revised and expanded, and in any case, these concepts are a vital part of education involved in teaching dynamically and continuously in different ways and perspectives with constant renewal and addition of new trends and ideas related to technology, to new philosophical views, to new materials, and in an environment of globalization with new values and new structures and according to the premises of ongoing development and sustainability, with a view to heritage, not as a reminiscence, nor fixation to the past, on the past, yet as a living collective knowledge. Thank you.
Another keywords, new keywords, or more than other keywords about education, formation, very important. It's another very important issue. I would like to invite Miltiadou Fedzans Androniki, okay, Associate Professor at the National Technical University of Athens, School of Architecture. Please, Professor.
Thank you very much. In the reality, now another discipline is going to enter in the discussion, the civil engineers. I'm professor in, as you said, but in the reality, I have worked for 35 years in the Hellenic Ministry of Culture, so I'm a practitioner as well. So I will offer you the simplicity, as you said, the problems we have every day, and in my opinion, how we face them. I would like first of all to make some comments regarding the discussion we had before. I'm very happy that Professor De La Torre started saying that the terms of authenticity and compatibility are not, we cannot exactly define them. They are moving in each case. So they are, we have to discuss on them, and then in each case to try to understand what we're going to do and what does they mean. And this has been, for many years discussed. We know all about NARA conference and all the texts, and I remember Professor Lemaire saying how difficult it is to give a definition. This was discussed a lot with Professor Tassios as well, and Professor Tassios makes a reference on this on a book he's written about the principles and the values of the monuments, saying that it is not really easy to define. That is why we must not stay general speaking. I will not do this or that because it has an impact on the authenticity. We must be more precise. And this means that in each case study, as we said before, and you very well said about Guido as well, that every monument is unique, the multidisciplinary team that it is indispensable and everyone now recognizes that it has to exist, one of the tasks that he has to do is to discuss specifically for this monument and try to understand the values of the monument. Instead of something very vague, which is authenticity, let's try to see what are the values, the historic and symbolic values, the form and aesthetic values, the technical values, speaking about materials, way for construction, the intangible values that it is in the monument, because the way that the Byzantines used to make the mortars, which is the way the technicians worked, not the analysis, not the chemical analysis, but how they worked to make these extremely of high aesthetic values Byzantine mortars, it is an intangible value. So I think that it is very important in each case to try to understand these values, and then when we will arrive to the therapy, and I'm going to speak for that from the civil engineering point of view, when we will arrive to the therapy, we are asked to make some interventions. First of all, we must be honest. Every work we are doing in a monument is going to have a certain impact on the monument. There is not intervention that it is without impact. What we're trying to do is to select or to make a proposal with the minimum necessary interventions. And I add the word necessary because with my Italian friends, a lot of times we discuss, they say, just minimum intervention. I think this is not enough because especially speaking in our countries where we have earthquakes, what is minimum intervention means? If I make some plastering and then beneath there are cracks, is this a good intervention? Everything looks like very well. So I need to make an intervention that is going, on one hand, give the necessary safety to protect the integrity of the monument. Otherwise, if you lose a part of the monument, then you don't have integrity. So and on the other hand, you must make the minimum necessary, which is going to have the less possible impact on the values. And this is a debate we have in the ISCARSAC committee. ISCARSAC committee is an international scientific committee regarding the structural point of view of ICOMOS. It was founded in 1997. I had the honor to be member with Professor Croci in Italy and other colleagues, Kumban Balen from Belgium and the Center of Le Maire, as well as, of course, Professor Macchi, Professor Bid, a lot of very important colleagues. And the discussion there is how, from the point of view of safety, because this is a very important matter, how we may approach this subject and arrive to solutions that may, on one hand, give safety, protect the integrity, and on the other hand, has a minimum impact. So in this discussion, of course, the multidisciplinarity is evident, and this is a base, and we say that the studies have to be, in a way, at least the proposals, be signed from everybody. The disciplines, at least architect engineers, chemical engineers, and materials, have to work from the very beginning together, have a common understanding and osmosis. We cannot say that there is a group that is making the surveys, and then he gives the surveys to another group, and the group is going to work on the surveys. It's what Professor Fessiu said before. If you don't touch the monument, if you are not there to understand, then you may lose a lot of information, a lot of understanding, because we are, as the doctors, in our first inspection, we have to observe in details what is happening. And then on the basis of this first inspection, which is our first visit to the doctor, we must make a research program, an investigation program, because the monument is speaking to us, but if we don't use as well the technology, if we don't use all the laboratory and in situ possibilities we have today in order to better document, understand, then we cannot reach in depth this feeling of the monument and make a good understanding, not only from the visible parts, but as well from the hidden parts, the interior of the monument. So the first thing is documentation, anamnesis, as we say in this committee of ISCARSAC. And then we come to diagnosis and assessment. Diagnosis, try to understand what has happened, but only on the basis of quantitative approach, which was used in the past by the civil engineers. Now things have changed, even not only for the monuments, but for the buildings as well, regarding their repair. So we need, first of all, a qualitative approach with all the information gathered from the monument and maybe from other similar monuments, and then the quantitative approach from what the civil engineer used to do, the models, etc. But every time having in mind that these models have to be calibrated. This means that not all the models say the truth. The truth, only the monuments say the truth. So we must try every time to have the information, calibrate our approach, and to arrive to have a certain model that we may trust to use it for discussing our intervention scheme. Because for the future, we must be based somewhere how it is going to work in the future under certain earthquakes. As civil engineers, we have the instruction, we have the knowledge to do and to work with models. But in this case of the existing structures, our models have to be calibrated, either by, and I was glad to hear about dynamic characteristics, so we need, for important monuments, to have as well information about the dynamic characteristics, the real, by monitoring in situ if possible, or other methods we can do. And then we have to assess on this basis if the monument as it is able to resist for future loads, including, of course, earthquakes, but as well maybe a new use. It is not evident that in all the buildings we can reuse them for certain uses. If you want to transform a building into a library, let's say, where you have very heavy loads, or if you want to transform it in a theater with a lot of people, sometimes, or in a museum, sometimes this is not possible, because the impact on the values may be very, very important. So these phases of diagnosis and assessment is very important, and there you are going to decide if the use can be really introduced, or you must not accept it, because it is not. It is very important not to adapt the monument to the use, but the use to the monument. Otherwise, the impact on the values, or in other words, the authenticity, but I'm trying to see to make it more clear, is very, very high. And then the therapy comes. Which therapy now we have to do with various schemes of intervention. And these schemes of intervention cannot be unique. Normally, we must try to have alternatives, and every alternative judge it in relation again to their impact on the values. So from this procedure, this is an optimization methodology, of course, we arrive to the minimum necessary interventions. And this is something really very, very important. And then the interventions have as well to be judged, taking into account compatibility, reversibility versus retreatability, because to tell the truth, nothing is more or less reversible. Now we're discussing in this committee, instead of reversibility, to put the word removability. I am able to take it away, but of course some damage will be there, and we must be honest, not to use general words. And to judge now our intervention scheme, you have reversibility versus retreatability. Okay, I cannot, I can remove it or I cannot remove it, but at least I have taken into account the fact that I did all the necessary chemical, mechanical, whatever investigation and test to ensure for future retreatability. The future generations must be able to intervene again, to re-intervene. Otherwise, for instance, if you make grouting in a building that has gypsum mortar, and even if you use, let's say, hydraulic lime, and this is a case in France, you have a risk, because only the water is the basic problem, which is going to produce extensive salts, and you lose the building. So in each case, we must try to be precise in our case, to identify our case, and not have general words, like saying some mortars that are used in one case are de facto good for another case. No, we must try to examine what has happened, or grouts, for instance. That's why, as I'm considered as the grouting lady, I'm always saying, no, we don't have recipes ready for every work. At least we must examine what is happening, and then probably we are going to use the same composition or the same grout. But we must be sure that this was controlled, checked regarding this existing situation in the specific case. And then we must as well think that this intervention has to be durable. I agree totally with Noni. And Professor Tassio, speaking about performance, as Professor Moropoulos said, always in his book, it is clearly written, it is really very important, he has written a small book on this, all of these matters, says that durability is a more general work, because if there is a certain incompatibility, we are going to see destruction. We are going to see not durability with the meaning that only the one material to be durable. No, because then, okay, titanium, stainless steel, they are durable, but this is not the case. durability in this general context, that the whole structure is going to be there without any problem. And of course, now sustainability and the other matters, but the word of durability, I think it is very, very important. And we are fighting, we had a lot of discussions, Professor Tassios. It would be very nice if we could have him here today, because he's always saying that compatibility is, let's say, one matter that it is very important and we must take it into account. Again, general, because Elena told about aesthetic compatibility, mechanical compatibility, chemical, there is a lot of. So again, it's a general term, but the final objective is the durability, because even mechanical incompatibilities are going to see them. We're going to see that we have, for instance, deformation incompatibilities when we add concrete or whatever. What are the problem, finally? Destruction of the monument. So the structure is not going to be durable. And then, of course, we must think about other matters, feasibility. Okay, we are saying that we are going to do this or that intervention, but in that small village of Italy or of Greece, impossible to have the possibility to intervene. So we must be realistic and try to, in this procedure of optimization, to take into account all the matters. And finally, we must never forget, after the therapy, we spoke about anamnesis, diagnosis, assessment, therapy, and then control. A lot of times we intervene and then we forget to make maintenance, or we don't care about the quality of materials and intervention in the work site. Okay, we did a very good study. And what about the materials they are going to give at work in situ? So quality control, and generally the word control, during the works and after the works with a maintenance plan is really very, very important. So thank you very much. I tried to give another another facade of the whole problem, which is common, because all this, as you said and Professor Moropoulou said, are linked together. There is a combination of all this matter, and the most important thing is to try to collaborate. Collaborate, Ministry of Culture, the universities, and try to learn from this collaboration. That is why, with my initiative, we have now a Directory of Research in the Hellenic Ministry of Culture, with laboratories and equipment, and this is really very, very important, because universities are doing research, but you need a research department in the ministries, so to make the link. And what is more important, it is not to have the results of every research hidden somewhere. We must put them in a kind of depository. I mean, to have, and this is very, very important. Where not only the initial studies, but as well what happened during the work and what is the maintenance. In the archaeological law of Greece, we have the obligation to make a visit to the monuments every 5 years. What to do if you don't know, if you don't have the file of the initial investigations, the initial study, what has happened, and then how it has reacted? Because how we are going to learn from our mistakes if we don't have this information somewhere? And the best way, of course, it is to have it in digital form, and this is the best way as well to educate, to come to the problem of the education, because I'm teaching as well in this postgraduate school department. Professor Konstantinidou said, how to educate. Every case study is unique, so we need to give this information, to disseminate this information in our young generation, so they are going to learn, not trying every time to discover things that they are well known. That is why, Professor Moropoulou, it is very good, this kind of conferences that brings us together, and so common views are discussed, and it helps a lot for an integrated, let's say, for an approach that it is not from one point of view. Thank you very much.
Thank you, Professor. you for your very interesting intervention. We had some other keywords: durability, retractability, reuse, maintenance. Probably durability is not the durability of the specific material, but of the system, durability of the whole intervention. And now I would like to give the floor to Professor Panagiotis, Professor Spathis Panagiotis, Professor at the Aristotle University of Thessaloniki. Please, Professor.
Thank you very much. I really am very glad to be here with all of you, hearing very important scientific thoughts, works, remarks, and results. So just a few words from me in this discussion. About authenticity. I think that although we are in the year 23, we cannot discuss without taking in account forgetting two very important documents that were the basis of the evolution of conservation science, of the preservation of cultural heritage. And of course I mean about Venice Charter and about NARA document on authenticity. NARA document authenticity were the first organized effort to test, to define the test of authenticity in design, material, and workmanship. Of course, all these years we make all the community many things, many efforts, but these documents remain the basis. And when I say to my students at the university, I present this charter, they tell me surprised how many things, problems, thoughts of these documents are alive, still in present. Of course, we are not in the same situation. We solve many problems. We try to find better solutions in others. But these documents are still alive. Okay, many problems described there. We try, and at this moment, to find a better solution. Some very small and short examples of these kinds of problem. Conservation of a monument implies preserving a setting which is not out of scale. Wherever the traditional setting exists, it must be kept. No new construction, demolition, or modification which would alter the relation of mass and color must be allowed. The conservation of monuments is always facilitated by making use of them for some socially useful purpose. Such use is therefore desirable, but must not change the layout or decoration of the building. It is within these limits only that modification demanded by a change of action should be envisaged and may be permitted. Another one. The valid contribution of all periods must be respected. Items of sculpture, painting, or decoration which form an integral part of a monumental may only be removed in it if this is the sole means of ensuring their preservation. These are a few examples. We can give all of us a lot more, but our problem that, and today we have not found the better solution for such problems. And about compatibility, thoughts, compatibility, we discuss about conservation, cleaning, that means cleaning, consolidation, protection. The fundamental roles as tasks, not roles, of reversibility or, and better, physicochemical compatibility. Here, of course, we must do, as already was said, the minimum intervention. For example, about cleaning. Cleaning is a strictly irreversible process. Once a foreign material has been removed, it could be absolutely impossible to go back to reconstruct partially or completely what is removed. So, in the case of cleaning, what must be the rule, the task? Controllability, selectivity, that we can do. Maybe retroactability implies the concept of physicochemical compatibility and durability with the development of new materials and techniques. What we can say, trying to explain what means physicochemical compatibility in cultural heritage conservation. The chemical nature of the substrate, the work of art, should be the driving factor in selecting and formulating new materials. I think this is the guide, what we said, and other colleagues here. And with this guide, we must continue the effort to find the best solution in the authenticity and the compatibility. Thank you very much.
Thank you, Professor. So you add other issues, different compatibility descriptors in relation to different operational actions, like cleaning, consolidation, protection, and so on. Yeah, okay. Aiuto, help. Okay. Now, Professor Sela Vider Adi, Architect Lecturer at the Bezalel Academy of Art and Design in Jerusalem School of Architecture. Please, Professor, thank you for your participation.
Thank you, Professor Zandri and Professor Moropoulos. I assume I'm the last one to speak in the panel, so I'll try to keep the time frame. I know. And first of all, I would like to react to and relate to, I think, the process that you're leading here in this panel discussion. Professor Irene was suggesting to collect words, but it's more than that. It's collecting terms, and it's collecting concepts. And I think that this thinking process now will have some very interesting results by the end of the panel. And by collecting those concepts, I would suggest also to go back to some of the concepts that we may forget because they were raising through the discussion both on materials, materiality, compatibility, and authenticity during the years. And we somehow didn't develop it, and I will just mention one. If you remember in the 1980s when they were talking about historic cities, there was a concept of progressive authenticity. It was never continued to develop. It is very challenging, and we may need to revisit it because we're talking all the time about change and progressive and innovation. That was starting already yesterday. So I think the process has a lot of advantages in our discourse. And relating to some of the issues that were already raised. So we were talking about the significance of materials and materiality and authenticity in the scale of materials and architectural structures. And I would like to go one step further into the urban context, the urban design, an issue if we were mentioning authenticity, architectural authenticity, to ask, is there urban authenticity? What is urban integrity? And I think because I'm the last one, I will start to raise some questions in the general aspects, but also in the case study of Jerusalem. And I will again take another comment that was already made here, that materiality of a structure, and I think yesterday in the discussion when we saw the slide of the cathedral in Milan, this issue was already starting to be put on the table, that materials and materiality has not just the tangible significance, but the intangible. You mentioned that also. The intangible aspects, even if we don't know strongly to connect that to materiality, but we feel these issues. So I think it's very, very important. So I will ask that when we reach to the field of urban design, and we in Betzalel has the master degree in urban design and a special track in historic preservation that was recently open. So when we reach the field of urban design, can we really tap from the mentioned fields of architecture, materials, engineering, and to be still in the discourse of cultural heritage preservation and conservation, and say that the significance of materials in a macro scale is really significant, not just for the authenticity of the urban fabric, but also to its integrity, and I would add cultural identity. What is cultural identity? And should we start and asking what is the meaning of materials and materiality in the 21st century cities? Or what is a city materiality? Can we do this combination of a city materiality? Can we say that? We know that there is a lot of stone cities, also with World Heritage Sites. What is the compatibility of these materialities in a city or of a city? And is it a compatibility to the natural feature, or today in the 21st century we cannot talk about compatibility to the natural feature of a place, but it's to the historic fabric of a place. This is the new compatibility. And what happened, and I will embrace the term that was suggesting managing incompatibility. This is the issue, Professor Stefano. Managing incompatibility, I'm gonna be challenged by this suggestion. So, do we have or need to preserve traditional and long-appearing materiality of a city in an era of new technologies and new materials, and how do we do so? And then I will move to the case study of Jerusalem. We're coming from Jerusalem. You're all familiar with Jerusalem into depth with all the understanding. So the image of Jerusalem is of a stone city, and this is serving both the tangible materiality and intangible of the city, character of the city. And from the early days, the city was built with very strong connection to the natural feature, to the environment, to the resources, and as I can say, the nexus between geology, architecture, and urbanism. And later on, and I will go to 1918, when the British set the stone ordinance in Jerusalem, they prohibited the using light materials in the city, and consequently, Jerusalem is a city built with stone. And today, when new intervention within the historic city of Jerusalem are being made, we must keep on using stone as a building materials. So I would like to add to my general question, and with this I will close my comments, is in the first half of the 21st century, preserving compatibility is of necessity or relevancy in the city of Jerusalem, and you can tap for to other cities as well. and is the uniqueness and significance of the city of Jerusalem is obligating the continuance of materiality in order to keep and maintain its integrity and a sense of authenticity and a sense of place. And with all the list of the questions that I was adding to the discussion, I would just like to quote from the poem of Yehuda Halevi, To Jerusalem. It's a poem that he was writing to Jerusalem. יפה נוף משוש תבל, קריה למלך רם, O fair view, words joy, great monarch's home, for you from earth's far end, my spirit yearns. And this is the character that materiality has a strong, I think, influence on that. Thank you very much.
Thank you, Professor Salavideradi, for your words. And I think that we can start from this last intervention to involve also you in this discussion. And we want to hear something from you, but yes, sorry, Antonio. Sorry. But Nani Maravelaki, that she has a written contribution from Professor.
From Dr. Vasiliki Eleftheriou, the Director of the Acropolis Restoration Service, Ministry of Culture, and he sent her contribution. Mr. President, good morning. I would like to thank the organizers and especially the President of the International Committee of the TMM-CH, Professor Moropoulou, for the invitation to participate in today's discussion. Unfortunately, due to an emergency, I cannot be with you today. The protection of a monument is intertwined with the respect of its morphological and structural characteristics. And if for the morphological characteristics there may be a possibility for differentiations between the original and the newer elements, for the structural there is not much room for differentiation. The construction must have a unified behavior and the materials must help in this direction. Therefore, the compatibility of the new materials and elements that will be deemed necessary in the restoration of a monument is out of question for its durability over time. Transferring my experience from the restoration project of the Acropolis monuments, I will confirm that, as elsewhere, the most serious problems occurred in areas that had been restored in the past with inappropriate materials and methods. Of course, the most usual damages in the monuments classified as mechanical, chemical, and biological. Mechanical damages caused by physical disasters such as earthquakes or by human actions such as changes in the building function through the centuries or the effects of previous restorations. On the Acropolis, the previous restorations are not only responsible for using inappropriate materials, namely cemented iron, but also for the unscientific restoration of collapsed areas of the monuments. The main aim of the current interventions is to face problems related to the structural stability of the monuments. Thus, the areas chosen for restoration are these that have suffered the most serious damages. In this framework, serious displacements of authentic architectural members in previously restored areas are also treated. All the restoration interventions on the Acropolis follow the internationally accepted theoretical framework of the Charter of Venice from a very early age. In this respect, effort is placed mainly on restricted the interventions to those that absolutely necessary, respecting the original material, the structural autonomy of the architectural members, and their original structural function, using materials that are compatible with those used in the original construction of the monuments, documenting all interventions in the systematic way. Additional principles have been also established for monuments following the structural system of the ancient Greek architecture, such as the principle of reversibility of the interventions. Regarding the materials and methods of the interventions, we can say that, first, the interventions are restricted only to those parts of the monuments that have been damaged because earlier restorations or present structural deficiencies. Second, in cases of severe damage, the affected area of the monument is dismantled. To make thus possible the removal of the metal elements that have been incorporated into the structure, the safe conservation of the fragmented members in the laboratory, and the restoration of the deformations, mainly in the upper courses of the structure. Third, the dismantling process includes the removal of rusted reinforcements and filling material. Fourth, architectural blocks, after being cleared from additional materials, are structurally restored in the laboratory. Fifth, new pedelic marble is used when a supplement is necessary. Sixth, titanium reinforcements are used either for the structural restoration or fragmented architectural members, or for the joining supplements to ancient marbles. Titanium also used for the construction of clamps and dowels that join the architectural members after reset in their original positions. It is very important every architectural member to have its original position, so we have to document every detail that help in this direction, and except the dismantled architectural blocks, identified scattered ancient fragments for the monuments are also placed in their original position or a corresponding one. In some cases, the explanation of the restored section is considered to strengthen the construction against earthquakes, such as the addition of the north column on the east side of the erection and the overlying architrave block. After the restoration, the causes of damage have been confronted and the deformation of the structure has been largely restored. Apart from the removal of the rusted iron reinforcements, the interventions contribute to the strengthening of the restored areas of the monument against earthquakes by repairing the open cracks, resetting the architectural members closer to their initial position, and lessening the range of deformation. In the 45 years that the works on the Acropolis last, the projects of the Erection, the Temple of Athena Nike, and the Propylea have been completed, and the most serious problems in the Parthenon have been faced. Although no failures have been observed, we are trying to improve the materials, especially the mortars, and that is why a part of the research continues with the aim of further improvement. At the same time, the research continues for the interventions on the circuit wall, where both the materials and the way of structure are different from that of the monuments of classical antiquity. Thank you very much. A nice intervention.
Thank you, Nani, for reading the intervention of Ministry of Lakulis Themistocles, Ministry of Culture and Sport of the Hellenic Republic. I would like to...
It was Eleftheriou from Acropolis restoration.
Eleftherios, from Acropolis.
Lakoulis is very ill, that's why he's not.
Sorry. Okay. I I also would like to remember that many years ago, Professor Guido Viscontin proposed to discuss on the restoration of the restorations. Yeah, to learn from the past experiences. But I would like to know if some of you want to add something after this first round.
I would like to say something.
Or
May
Stefano?
I add
Stefano, Professor Stefano
something?
Della Torre.
Just again about that slide about listening, because materials talk, monuments talk, and we have to listen. Some years ago, we reflected about the difference between listening and seeing. So the approach of a visual approach or a listening approach, because listening has a different attitude in front of time. When I see, it's an instant, it's a moment. But when I listen, I have to listen for a while, because there is a flow of music and so on. This, in my opinion, this makes the difference in terms of our approach to compatibility, because it's a matter of how the materials will behave through time, and maybe also in terms of authenticity, if authenticity is a complex thing. So the Mostar Bridge has been quoted, and I remember the speech by Christina Cameron about this kind of authenticity, where the symbolic authenticity takes the command above all the other criteria. I am afraid that the symbolic authenticity will be challenged by the time. So I'm reading something about Mostar where, okay, it's true, it's politically correct, but in front of changing things, there is a matter of resilience and a matter of social sustainability, which is something different. My last remark is, again, remembering Guido, that we all are a community of researchers. And to research means to be skeptical, in a sense. So we have always to put into doubt what we know, and to try to learn something else. And this is what is important, that the main legacy of a person like Guido, who made a lot for us, searching new things and new horizons.
Thank you, Stefano. Thank you again. Yes? Yes.
On what Stefano said, but probably another word, feeling the monument, because you have all the senses. I mean, not only listen or see, but feel probably.
I accept
you accept
the correction.
Thank you.
Okay, now I leave the floor to Antonia Moropoulou, Professor, to close this session, this panel.
We've heard that we have accumulated a lot of words today. So I would like to start with this. All these words are actually terms referring to concepts that are introduced into our contemporary life through the various approaches developed at several levels. For instance, sustainability. That was a term introduced by a lot of radical intellectuals during the first years of the 80s. I was among them, concerning in generally the development of the world, the socioeconomic and actual development. This was transferred to the cultural heritage, and it got the concept and the meaning of preservation of cultural heritage. When we started with compatibility with Professor Viscontin and others, we actually changed the Venice Charter, and that was a common acceptance of the scientific community, instead of reversibility, to speak of compatibility. Perhaps there might be some other approaches like removability and other things, but what was important for compatibility was the semantic of it, referring to a deep understanding of the performance of materials in environment and in structure. And that is the actual way we have to approach the terms. What is their semantic value, their reference to knowledge in depth about how materials, structures, architecture, identity are functioning in certain dimensions. So it's not to accumulate terms. We have to understand behavior, performance, identity in all dimensions, and to integrate them, because a monument is unique. Whether you are a civil engineer, a chemical engineer, an architect, an ICT engineer, an archaeologist, all of you have to integrate your knowledge in the study and in the reuse, perhaps, in the preservation of the monument. So that means we should not miss the target. The target is to cooperate, to speak a common language, to exchange what each one might perceive from its own educational, cultural, professional background, to offer to the common task, which is to preserve our cultural heritage, and which is not dissociated to our emotions, to our soul as well, because that's the cultural identity we have. When I went to Jerusalem, I fall in love with Jerusalem because I have been born in the medieval city of Rhodes. And I said, what a stone, lime calcareous porous stone of the same color, because they are reflecting the light in the same way. And because the sun is the sun of Mediterranean basin. So that was the reason that I added from my own personal point of view to the studies, the physico-chemical studies of materials performance, the dimension of the microstructure. Professor Koulkidis was studying marble as a compact material. And I dare to add to his approach the microstructure. And I worked with Professor Viscontin and Professor Bacolas on studying the microstructure. And there was the open laboratory in all cultural heritage to understand how materials are behaving in environment, are inducing environment, are breathing, etc., etc. So that means we have to go on, and as Professor Gentry said, to simplify things, because simple goes in depth. So don't be missed with terminology. We don't accumulate terms. We are living in a world that is developing new approaches, but we have to be integral, intact, to go in depth, and mainly, not only to manage, but to govern the future perspective of our identity. Thank you very much, all of you. And this was dedicated to Professor Guido Viscontini, who did not only doubt it, he posed questions. You have to pose questions, but you have to resolve them, not to stay in doubt. Thank you very much.
Yes, I think we can start this panel discussion. Good morning, or well, good afternoon. It's after 12, everyone. And this panel discussion will be earthquake protection and structural rehabilitation. And I think there will be a lot of different point of views into this hot topic. So, and I'd like to be happy to understand and to comment on the different point of view. My name is Marco Corradi, and I am a structural engineer. So my point of view will be, of course, the point of view of a structural engineer, but the panel is made by other people, and Professor Spirakos that probably will join us, and also Christos Stefanos, yes, that is a professor emeritus of University of Patras, again, I think as an engineer, yes. Moutsakis Harris is an associate professor, is here? Yep. And Oliver Daniel, I know from Portugal, I don't see him. Corina, I don't see Corina here. Maybe we'll come later. Georgios Panelis, yes. It's me. Yes, and he's a professor emeritus of Thessaloniki, the School of Civil Engineering. Good afternoon. And Georgios, okay, yes, and Antonella Saisi, we all know her, again, is from Polytechnic of Milan, Department of Architecture. And Georgios Stavroulakis, yes, good afternoon, is a professor at the Technical University of Crete and the School of Production Engineering and Management. So, to introduce the topic of structural rehabilitation, I think the thing is many mistakes has been done in the past from both sides. From the point of view, here we need both sides when I say the point of view of conservation, of let's say integral full conservation, and the point of view of say demolition that is on the other side of conservation, that there are some advantages on both sides, because of course demolition means also to reconstruct with the modern methods, to safeguarding the safety of people with the new constructions, but of course a loss of cultural heritage. Okay, so for example, in Italy, what happened after the 1976 earthquake in Friuli, you know, there were the beginning of a different approach after many years of demolition. So the people were convinced that we need to demolish existing construction to have new construction made of reinforced concrete. After 1976 earthquake in Friuli, in Italy, there was a different understanding, basically also made of modern, the beginning of analysis of the mechanics of masonry structures. It became 1976, when engineers start to approach masonry, because for a long period of time, structural engineers did not consider masonry a modern material. So in 1976, they start to consider, and also the contribution from the Slovenian researchers that were important in design of concrete structure. So, but still now there are two approaches. I give you an example of what happened in Italy in 2016 after the Central Italy earthquake. There were many medieval churches in Italy in 2016 that were restored the day before the earthquake, and the conservation body of Italy spent millions of euros to restore the frescoes, to restore the monuments, to restore the artifacts inside this building. And after the earthquake, everything was lost, okay? Because maybe it was wrong to put money on the architectural side before doing the structural interventions. So we need to discuss I understand that there are different point of view, but maybe it's better to do a structural intervention before the architectural interventions, because it doesn't make sense to spend millions of euros on a frescoes or on a statue if after the earthquake this fresco or this statue is lost forever. So anyway, I'd like to open a discussion about this, and I'd like to invite, I'd like to start with the people in the panel. So maybe Stefanos, if you want to say your experience, and then we open. Yes, please.
Can I have the PowerPoint, please? Okay. How I can change the slides? Όχι, πες το.
Από εδώ μπροστά και από εδώ πίσω.
Έγινε. Ωραία, ωραία. Όχι, πήγε πίσω. Εντάξει. Ladies and gentlemen, this is an honor for me to participate in this panel. So, the subject that I want to discuss with you is the authenticity versus the structural integrity, the seismic integrity actually. I want to share with you some views that is expressed from various distinguished, let's say, experts and engineers on monumental structures. It is not only me. So the general accepted rules in all or the procedures that are going to look and assess a structure, a monumental structure, is the minimum interventions, non-invasive techniques, the compatible materials and techniques, and traditional materials and techniques. This is that it would be a good way in order to keep the authenticity of the structure and to return the structure in its original condition. So, to return the structure in its original condition, should it be the top goal in our intervention? If we do the same things, why we may expect different results? In any way, any intervention will modify the original structure. So, return the structure in its original condition. Should it be the only goal? Shall we abandon human lives as the top value of our actions? We remember a lot of people died in the Lisbon earthquake when the monumental churches destroyed. So we have to keep the general rule. The general rule in any of our decisions, in our life decisions, to judge, to balance between losses and benefit. So, but we have to account any kind of losses, any benefit. We have to take into account the human lives. We have to take into account the building value, the historical, the architectural, the artistic, of course, authenticity, the structural seismic integrity. Just to remind you the terms robustness and resilience, of course, the economic cost, etc., some others. But when we're speaking for minimum intervention, that is, of course, a great value for our decision. That means maximum understanding. This is equal to reliable assessment. So we need high knowledge and confidence level for our data. We have the as-built data as the materials, the foundation, the details, the diagnosis of damage, the decay. We need possibly, from the point of view of a structural engineer, we need a sensitivity analysis to draw the protocol of in situ interventions to identify the main parameters that influence our assessment. Not all the parameters may be equally important. After this, we have to calibrate the partial confidence factors for more reliable models. And of course, the parameter with the high sensitivity needs high level of knowledge and confidence. The analysis before the decision for the intervention should have, as most of you know, 3 types of analysis. We need the historical analysis, what occurred in the past, the qualitative analysis, that is the comparison between the similar structures and also between different structures, how they behave in the past. And of course, we have the structural analysis and test, but just take in mind, from my view, we need the most modern analytical models and tools and suitable analytical models. Different models, structural models, are suitable for different structural types. Sometimes more than one models are needed. We can find in the project of the Perpetual in Italy, some crucial types that is mentioned when different structural tools are needed. For example, a different structural model is needed when we have to assess a box type structure. Then different when the structure is with wide spaces, without intermediate floors. Also, another model may be more suitable for slender structures, another for arched or vaulted, for massive masonry structures, for dry block structures, as it is the archaeological ruins, and of course for the aggregated buildings that is in historical centers when the interaction or the connection among adjacent buildings is there. Of course, there are many possible decisions. Maybe after the assessment, there will be no need for any intervention. Maybe the design, we need to design a rehabilitation intervention, but also maybe to revise the safety requirements. Maybe there will be a need to monitor and upgrade the structural analytical models. And of course, maybe a decision to repair and retrofit after an earthquake. This is the views that I have collected, various views that have been presented in different forums. So it will be nice to have a discussion and to share your views about this matter. Thank you for your attention.
Yes. I'd like to, open a small discussion after each intervention because it's more near the presentation. So any comment about this, please? Do we need a microphone, maybe? So I have a comment, and then, it's historical analysis. This is something important, but historical analysis, what happened in some cases in buildings that were 700 years old, and they remain safe for 700 years, and then they totally collapse. So sometimes the historical analysis doesn't mean we need to consider degradation of materials. So when we assess a building, one of the comments that we hear, why should we make an intervention if the building has been more or less standing for a long period of time without damage? So a lot of people say, oh, this building has resisted tens of earthquakes. But it doesn't mean that in the future the building will have problems. So one of the issues is climate change, for example. So let's think about the rain, the temperature change. So all these things, we may have an important effect on historic buildings. So historic analysis is important, but it's also important to look what we face for the future, I think. Yeah. Any other comment?
I would like also to make a comment on your comment. Usually, the historical buildings are not intact, completely intact after 500 years, 1,000 years, or 2,000 years of life. They have symptoms of what has happened in the past. From fire, from earthquake, from war, from various things. This information is very important for what we are going to do next. Personally, I was involved in many monuments. I have not seen any one of them all over the world, in Greece, in Romania, in Turkey, in Egypt. I have not seen any of them to be completely intact and to decide to make an intervention. The intervention is decided when we have symptoms from the past or from the near past, from the far past or from the near past due to an earthquake that happened recently. Then we see cracks, we see deviations from the vertical, we see cracks due to settlements. The cracks are different from the thrusts of the domes and those from the settlement of the soil, of the ground. So we have to make a very detailed research of what has happened in the past and what this past has left to us and what we have to do in order to stop this or to prolong this. We cannot always stop things.
Yes, more questions? So Antonella, please.
Thank you. I don't agree with you. For me, historical research is one of the fundament of structural assessing. But what is a structure? What is a structure? What is also historical investigation? It is part of the recognizing of all the change, as he just said, occurred in the time, including the update to the modern standards, including the local change, for example, for the installation, for the heating that produce a lot of damage, the hydraulic works, every type of local change that can be related, maybe not to an historical document, but you can read in the changes of the measuring text, for example. You can recognize in the change of the materials. You can recognize in the in the local repair. That is a part, probably a wider investigation. I can see here young young architects, and probably they follow the so-called.
Compared to Penellis.
Sorry?
Young compared to Penellis.
Oh yeah, so sorry. And they carried out in your career the laboratory of architectural restoration. That means an accurate survey of all the modification occurred to the building, including the present state of preservation. That means means the mapping of the decade that take in account, for example, how the past building technique was transformed, particularly in some elements like the wooden structures that are very frequent, for example, in the Greek traditional architecture with some strengthening with the wooden element. So, in my opinion, what we have to consider is not just the historical, I would say, investigation as a traditional research of documents of events, but the historical evolution of the building, and we have to compare what happens with a deep visual inspection. So a comparison what is the information that we can obtain from documents, but also what we can see in the building itself, that is self-explaining what happened in the past. Even if we, in some case, we have not written documents, but the building is itself a document of this transformation.
Yes, more comments, please.
Another parameter that we have to take into account is the return period of the earthquakes. We have to mention that there are areas in Greece where in the past we had strong earthquakes 700 years ago. And there are cities, whole cities, where they were built after that period. That means that we need, if we'll analyze these structures with the data we have nowadays, even with the earthquake of, with a return period of 470 years, you will find that these structures cannot suffer the earthquakes. Therefore, for that case, there is a need to say which is the earthquake for which we have to strengthen or repair the structure. If we'll not know this, then the best thing I think we have to do is in order to deliver the monument to the next generation, to support the structure and give it to the next generation. You know that within the next 40 years, materials will be different than the ones we have nowadays, as the materials we had 40 years ago. And I think that if we'll not manage to the structures to suffer the strong earthquakes, the best thing is to support this.
I have a comment on the comment of Professor Ritsos related to the priorities. You mentioned sometimes money spent to preserve the frescoes but not the structure, and then if something happens, you lose everything. Nowadays, people are spending money to create nice animations or nice applications for the smartphone just to attract tourists, and it's a similar case.
Do we want to move to there's any other presentation? Yes, from...
Yes, Penelis.
Okay.
Is it, oh no, it's not, that's the next.
The next is Haris Moutzakis. Yes, do you have a presentation? No, I haven't. Okay.
My name is Penelis.
Okay, so go on. You can go with your presentation, so okay. We may have a different point of view and then we discuss.
Hello everybody.
First, I would like to thank Professor Moropoulou for her kind invitation to participate in this panel. My short intervention has to do with some milestones in structural restoration. According to my opinion, the basic principles of restoration are the following two. One, in the whole procedure of preservation, conservation, and restoration, authenticity is considered the most important parameter. However, equally important is the life safety of the users, and in this respect, structural interventions must be considered equally important. On the other hand, structural restoration may be considered an undesirable action since it applies to interventions of a large scale that might harm the authenticity of the culturally protected building. In this respect, authenticity and safety are two concepts contradicting each other as they are supported by professionals of different origin and philosophy, namely archaeology and architecture on one side, and science and technology on the other. In case of a structural restoration, these professions are asked to find a common topos of existence so that the results of the restoration would satisfy both concepts, authenticity and safety. The above thoughts are presented in this simple scheme. There are three disciplines: the architectural, the historical and archaeological requirements on one side, the restoration architectural requirements, and the structural safety requirements. The existence of a common place, everybody in these areas believes that his positions and his requirements are the most important. If they don't, they have to move one close to the other and find a common topos, a common place. Otherwise, the restoration cannot happen. And what happens if it does not happen? The building, the monument stays short with shores for a long time until other responsible people find the common place in order to make the restoration. There is a need of thorough knowledge of materials, forms, and techniques of construction used in the past. This is necessary for the suitable choice of present-day techniques and materials, and for the decision-making on which of them should apply irreversible or reversible techniques together with compatibility and durability of the intervention materials. The assessment of the bearing capacity in relation with the expected effects of calamitous events, e.g. earthquake, hurricane, etc., cannot rely only on analytical procedures, despite of the tremendous developments of the computer science. In fact, the low reliability of material properties of the past, existing cracks, splits, and drifts from the past, and finally, uncertainties of the effects of the calamitous events, seismic actions, and so on, in the future, influence seriously the reliability of the results of the analysis. Therefore, the basic guide for the structural assessment should be the historical documentation of damages and the present condition of the structure, that is, cracks, splits, drifts, all what we call diagnosis. This information is a basic indication for the reliability of the results of analysis. The above thoughts are presented in this small flowchart for the assessment of a monument. We have on one side the diagnosis. A lot of material of diagnosis is used in the quantitative safety evaluation, the analysis, and the results of the analysis must be compatible to the symptoms in the monument with diagnosis. If they are compatible, for example, the deviations from the vertical, the cracks, the load paths that we find through the analysis. If all these are compatible or mostly compatible, they are never all compatible. If they are mostly compatible with the diagnosis, then we continue to the choice of the intervention scheme, which is another problem. If not, then we have to reconsider both diagnosis and quantitative safety, and we must try to find solutions that both are compatible. And finally, there is a need for close cooperation, mainly between architects and archaeologists on one side, and structural engineers, chemical engineers, science, let's say, on the other, in the frame of restoration activities. Having a vast experience in research and in design of structural restoration of prominent monumental buildings in the last 45 years, I'm sure that the collaboration between the above professionals may be more effective and fruitful if each of them shows understanding to the other aims, needs, and needs. Now, and I will give 3 characteristics. Buildings. This is Galerios Rotonda in Thessaloniki during the restoration. This is St. George in Cairo, a monument of 2 centuries based on a Roman tower, which is built above a Roman tower of 1st century CE, and the old National Library of Greece. In these 3 characteristic buildings, we cooperated all scientific disciplines, and we made some steps one to the other so that we can proceed to the final results. Thank you for your attention.
Yes, indeed, extremely interesting. And I have a comment.
Yes.
And, you know, as a structural engineer,
yes,
so we talk a lot about numerical simulations,
yes,
right? So I think we need, also because we are in a team of people that should do high-level numerical simulation, but when we go on professional projects, I think there's an abuse of numerical simulations. So the question here is, what are the reliability of numerical simulation in monuments? Because I give you an example. I've been working for 25 years in a structural laboratory where we did both testing on site and we did also numerical simulations. And especially when we do dynamic analysis, because of course we cannot do very often destructive testing. So we do dynamic analysis with frequencies, and what happened always, that when we do the numerical simulation before the test, and then after we do the test and we compare, the results are completely different. So we think that numerical simulation give reliable results, but in many situations, these results are not reliable at all. And I think we have a duty as people working in this subject to say where we can arrive with the numerical simulations. What kind of monument? Maybe a monument that is isolated, a monument like a single church, maybe constructed at once, where we can assume a kind of elastic behavior. We can assume, because nothing is elastic here. Nothing is elastic.
And nothing homogeneous.
And nothing homogeneous.
Also.
And nothing is isotropic. So I think we have a duty to alert a scientific, not the scientific community, the professionals working in masonry about the limitations on numerical simulations. Because too many times, I've seen elastic analysis of buildings constructed over a period of time of 1,000 years with different material, with cracks. How do you model a crack?
Oh, well, I will answer you.
So there are so many things that I think we cannot hide. So how important is the survey? How is the diagnosis? So we need to stress on these things: survey, diagnosis, historic analysis. Okay, so these are terrible important things, I believe. Sorry to comment on this. Yep.
I think that your comments were very, very interesting and to the point. Of course, that's why I stayed so long in the two issues, diagnosis on one side and computational analysis on the other, and I said that if the computational analysis does not comply with the results of diagnosis, because diagnosis is a deductive activity, the analysis is an abductive activity. If analysis does not comply with diagnosis, then you have to reconsider the analysis. You have not to reconsider the diagnosis, because diagnosis is what you meant, what you have found there on site, and you have to do the analysis again. Okay, how can you asked before how you can simulate the crack? No, you don't simulate the crack. You find the areas, especially using modern analytical systems, the areas where the cracks could appear before the cracks. And if these areas coincide with the areas which you have, you see the cracks, then you say it's okay. For example, in Rotonda, we had in the two main piers, it has 8 piers, big piers, 6 by 6 meters, and there was a diagonal cross due to shear compression. Clear for an engineer who has been also in the laboratory, it was clear shear compression failure. You know, what kind of analysis could I do in 1978, in 1920, in 1980, before having analytical instruments? Okay, I used the Prager criterion of up and down limit analysis, and I found the crack analytically to be at about 72 degrees, and we have measured the crack there that it was 77, something like that. Very near. Okay, we found the crack analytically, but you have
to act not according the codes. And this is the reason I always say that it is not possible to codify the intervention in monuments. You have to activate all your knowledge and your initiative in order to find results. And I used that, and then what did I do there in order to support the system? Let's say, I nailed the way with nails the crack from one side to the other, stressed nails in order to keep it inside. And of course, all other, and we had to put also rings and so on, but analysis on one side, but site investigation on one side and analysis on the other are the two pylons with which we arrive to the result. And perhaps it would be interesting to answer to our colleague, for what earthquake are you going to design a monument that has survived 17 centuries? The same question I had also in Cairo, in St. George. The church of St. George is a new one, of 1 century, 1.5 century. But the Roman tower is a monument of 21 centuries. What earthquake? The earthquake for which we design the modern buildings, which is 10% yes, for 10% probability, yes, yes, for 50 years, this or not. Okay, well, I'll tell you what we have done in both of them. I try to find.
So the numerical simulation is good. So we can say we should go on with
of
numerical.
Course, or to use it only as an instrument in parallel to the site investigation.
Yeah. Stefano, any comment from you, please?
Thank you very much. It is usual that many engineers rely on the results of the structural analysis, but it's not the correct way. This is the reason we have to calibrate our models. Our structure, we cannot use any model.
And the question could be, how complex should be the numerical? That's another, sorry.
That's another question. Yes. But maybe there are some simple models that may be more suitable in specific cases. So we have to try to find the suitable tool and the suitable for this specific one. The other thing is that we cannot rely on the structural analysis. This is the reason that we have the historical analysis, this is they have the qualitative analysis comparing between buildings with the same type, something like this. So it is necessary to use all these ways to compare and to make a final decision.
Antonella, what is your opinion?
So, well, I have another comment that is not only for the point of view of the structural engineer. We can have a very good structural engineer that can produce also very good calibrated models and maybe some reliable project for the intervention. But we have to think about also the intervention itself. There are techniques that may be compatible, maybe also carried out and maybe studied in a very deep way with laboratory works and so on. However, we have to take in account when it is applied, mistake can occur. We've seen also how it's in the recent earthquake in Turkey, how it is delicate also the evaluation how of the building itself even recently is reconstructed. So there will collapse for probably some mistakes during the only during the intervention. So, for example, one very common practice in repair the historical building is a local dismantling of the masonry and the rebuilding. But who is the worker that knows exactly how to work, how to do it? It is not an easy way to do. Even if the engineer maybe consider that the repair was locally carried out in a good state, and maybe you consider that the building has again the so-called homogeneity of the masonry or the box-like behavior. But how to consider this? Even in my opinion, even after the intervention, a survey, a local survey, a local control of the intervention must be carried out, particularly for say monumental buildings, because we have to take care of them. So it is not only the diagnosis of that support the intervention, but the diagnosis that take in account how the intervention was carried out, but also if it is compatible, it is successful. For example, grout injection, that is something that is widely applied, but my experience that, okay, it is not so long, but we have a frequent lack of the diffusion, and in many cases the intervention is not successful. It is able to, for example, fill the gaps, close the injector, but not to reinforce really the mass. So we have to pay attention also to this when we carried out on also general control of that. Okay.
Yes, Professor. Yes.
Yes. Well, speaking about the reliability of the analysis, I would like to read a small paragraph of a book that I have published 2 years ago for restoration. However, any future development of the analysis must be approached with serious concerns, since the reliability of outcome depends on a great degree to the reliability of the input data. As the perplexity of a method in use increases, more input data are required, the values of which are of limited reliability as their number increases. Therefore, it should not be forgotten that the analysis refers to a model of the construction and its materials, and in this respect includes many uncertainties which we must approach, as my friend Croce says, with much prudence.
Yeah, very true.
This means that I agree completely with what you said in the beginning. Okay.
Yeah. Professor Ritsos, you want to add? Oh, you add. Oh, sorry. Oh, Stavroulakis. Sorry. Yes. Mousakis. Yes. Please.
What Professor Penelis mentioned as diagnosis for earthquakes, I have to say that we can use health monitoring systems that can record the response of the structure by using accelerometers measuring relative displacements and other parameters that can be used to verify the results we analyzed during the design of the structure. And if we have some differences from our numerical models, then what we have to do is to calibrate the numerical models to give us results similar to the ones we recorded. Therefore, I propose for significant monuments monitoring systems to exist not only for earthquake purposes, but also for other parameters to record like moisture or other significant parameters in order to verify our models when we decided to strengthen a structure.
Yes, please. Yes, of course.
I totally agree with you. In fact, for example, we are at the moment involved on a research consultant, maybe for the Cathedral of Milan, that at the moment has the wider, I think, system structural health monitoring system that involves a lot of parameters because it is really important to evaluate the onset of something that is changing. And for example, also for not structure, I would say not seismic problems, luckily Milan is not the most seismic area of Italy, luckily, at least at the moment. So, but for example, we had the opportunity also to observe a critical onset of damages of one of the ancient tiles of the cathedral. And then this was the starting point of an intervention aimed to substitute that tile. And of course, this was possible because of the wider system that monitor each change, the behavior of each element of the cathedral. So a wide monument of the resources are available, but we have also to think about smaller system for elements that are historical churches, historical sites that maybe had a lower possibility for the say monitoring for the resource, economical resource. Thank you.
Yes.
Okay, first of all, I would like to say that I'm very pleased to be here and discuss with my teacher, Professor Penellis. I would like to mention here what we mean under the definition of an analytical model, of a numerical model. Usually what is available in a commercial software we have access. I would like to mention here that for several decades we used to use, even now, we use frame models. Nowadays it's not acceptable to model a wall or a big massive structure. We use two-dimensional, three-dimensional models. That means the techniques are better, are being involved, more complicated. On the other side, several things are based on different level of reliability. For example, fracture mechanics, initiated from nuclear engineering, small components where they know even the defects in the metal alloy coming from the furnace, coming from the production process. Okay, this is not the case in our materials. I would say there is a challenge, and there is a question from this community to the computational mechanics community to develop and make available more simple tools for estimating the reliability of results. For example, stochastic finite elements, interval analysis with finite elements, fuzzy techniques, and so on.
Thank you. And moving to another, do we have another presentation? Does anyone has a presentation? No? So I'd like to open a small discussion now of something that is not only structural engineering, otherwise we can stay within. So it's about how do we give priority to a monument compared to another. So when we have a monument, we have not only the damage, we have the social value, So let's say the Parthenon here in Athens is probably the most important monument of Greece. So the social values is unbelievable. But also, let's talk about even economic tourism value. And the artifacts inside the monument is another important aspect. And the safety of people working in the monument. And of course, the risk of collapse in case of an earthquake. So one of the solutions that were introduced in central Italy, and I would like to understand your opinion, is to make overlapping risk maps. So a risk map of an earthquake, a risk map of the social value of a monument, so each monument has a different social value. Each monument has a different also heritage value. So if we overlap these maps, we may have, let's say, a list of priorities of monuments where intervention are more urgent. The question is this a way to follow or not?
Very, very difficult.
Yeah. Yes, Daniel, Daniel, can you hear us?
Hello.
Oh, okay. Oh, sorry. Yes, okay. Daniel Oliver is an associate professor at Migno University, is a structural engineer, is also an expert in deterioration, aging of structural materials in upgrading and structural analysis of monuments. Yes, can you, going back to the reliability of structural numerical methods, what is your opinion, Daniel?
Okay, thank
and
you.
then
thank
we
you,
go
Marco.
back to
it's great to meet you by video conference. I would like to be there with you, but unfortunately it was not possible this time. I would like just to comment that regarding the experiments and numerical models, if you do 10 experimental tests in the lab, you will get 10 different results. So it doesn't make sense to calibrate one numerical model to fit one experiment. This is not fair, neither for the experiment nor for the model. So in fact, if we have a building, we cannot have 10 similar buildings and test them. This is not possible. So in this sense, I think we should ask the model to give a good estimation of the result, as was said by Professor Panelis. So in this sense, we cannot ask a perfect result. This perfect result does not exist in my view. So the models, of course, can be very complex. We will have supercomputing in the coming days. We already have, in fact, in practice. So we can go for very complex models. It will be possible to run them. But if you go in this direction, you need much more experimental information to fit the models, as it was said by the colleagues. I fully agree with this. And this will require more and more expertise and more money. Of course, in some cases, this will be nice, it will be necessary. But in most of the cases, I think we should not follow in this direction. Sometimes a simpler model is enough. It gives us an overview, so an estimation of the results, and it gives us confidence to proceed. So it has to be perfect. It's not have to provide the same result as we observed in the experiment, because in my view, this is not possible. So in this sense, I trust in the models. I think they are very important. We can speed up the process. We can save money and time, but we must have some confidence. Of course, they have to be fed from experiments. It was mentioned, and I will talk later in my intervention, that social health monitoring, this is really fundamental. You need this information to be confident with your model. The minimum, I would say, is dynamic identification. Your model should fit the reality in terms of dynamic properties. This is the minimum we should ask that as a starting point. So just to finish this part, I would like to conclude that numerical models are very important. They can help us a lot, but they will not give you the truth, the so-called truth. This does not exist. So if you expect that, forget. You should not use numerical models.
Thank you, Daniel. I see also Corina is here. Corina Papanicolaou, an associate professor at University of Patras, and I know very well Corina. Corina, what is your opinion about reliability of numerical methods and how complex should be this method in design or in design of intervention, in your opinion? Because also the complexity should be an important aspect to address.
Ciao Marco, ciao Antonella, ciao hola Daniel, my dear colleagues from Greece. It's a great pleasure for me to be here today. Unfortunately, I couldn't travel today because of a very nasty back pain. I couldn't drive myself to Athens.
The volume, yes.
Actually, I wouldn't say that strong cup of tea is, numerical analysis, but when it comes to reliability, I also think about the future. Let's say, how reliable are our results when we compare them with when we use them as a means of identifying whether a mortar is suitable for strengthening interventions. Let me give you an example. And of course, in the back of my head, I always have the inorganic matrix composites that we have been using lately for strengthening interventions. So what we do is this: we rely on prisms and on other types of specimens that are much larger than the final application of the mortar on the substrate, to assess their properties. Might there be mechanical or physical or chemical or chemical or whatever the case might be. And at the end of the day, we make a decision. We say that we're going to design for the common space between ability, whatever that means, and performance requirements, other performance requirements. Really strengthen the formability, but also durability. And how certain what is the reliability level that the material that's going to be placed there as mortar, as render, as externally bonded material, it's going to behave like the materials in our prisms behave or in our labs behave. I can tell you that it will behave completely different in a not so distant future. There is an interaction, a dialectic relationship between the substrate and the overlay, that it is also time dependent, which means that the substrate, if the panelists can close their mics because there is a feedback, there is an echo, so I keep hearing my voice back. So I'm saying the substrate is going to influence the render, and the render is somehow going to interact with the substrate. At the end of the day, the material we have placed by T0 is certainly not going to be the same as the material in place 1 year, 10 years, 20 years on the structure. So what I'm saying is that also the reliability when it comes to future projections, subject to a lot of ambiguity. In my perception, I think we have to say that we know very little. To give you an example, we only found out lately that Roman concrete is not exactly what we thought it was. And it took us so many years to find out this. It took us so many years to find that probably hot mixing was taking place, so that chunks of hydrated lime was in there, and this also acted as a self-healing mechanism for the mentioned on concrete, which is mind-blowing. And what I'm saying is that materials will always surprise you. And there is an amalgamation between the substrate and the render. And then another transformation happens. We use reinforcement in the render, which means that we are introducing new forms of moisture paths, of ingress mechanisms, of CO2 pathways into the materials, which means that the mortar itself doesn't say much. We have to take into consideration the composite. And the composite doesn't say much. We have to take into consideration the composite over the composite. And this doesn't say much. We have to take into consideration the composite over the numbers of years to come. And this makes it very difficult for the practitioner, for the everyday engineer, when he comes or she comes to figure out what type of materials they should use for their intervention. There is no easy answer, and there is no deterministic roadmap to provide and help him out with this decision. And this is why I think the experience gained by all these generations of engineers going out there on site is invaluable. This is what I'm thinking as a university professor now, as a teacher. This is what is needed to be taught from, and this is not something that can be predicted with reliability functions or with numerical modeling. The human factor, the experience gained by all these generations of engineers are not modeled. And this is something AI will never take away from us. You know, our intuition, our imagination capacity, and our capacity to pass on this information from generation to generation. You cannot teach an AI these type of things. So I don't want to take up your time, and that was my intervention.
No, thank you, Karina. Okay, any comment going back about how to give priority to a monument compared to another? So, is this risk maps that several countries are preparing something that we should follow or not? Each monument should be looked like a single monument without comparing with another, or we should maybe go into a multi and comparing the priorities of one monument to another to make some decision in one direction compared to another direction. So what is the opinion? And I'd like to,
I have a comment.
Yes, please.
Well, in order to be able to make a reliable decision on priorities, you have to be in position to quantify the parameters. For the time being, these parameters cannot be quantified. For example, we do this in buildings and in areas due to earthquake, which is, let's say, there is an objectivity. In monuments, there is not an objectivity. In monuments, there is, let's say, it is the personal feeling. And I would dare to say something that what comes first is the result of the war between the archaeologists. The stronger oblige all the other to put the money to this direction. And when I say the stronger, I don't say the best archaeologist. The fellow who has the best connections with the government, with who has the money and so on. It's not an easy task to quantify all parameters and to say, okay, this must be the first, this is the second, and so on. I think that this is done in USA for the buildings, and it began to be done also in Italy. For regions, which region to get more money for, not for the monuments, but for the infrastructure and so on. And I know that there is even there they falsify the input to have as first what the government wants to be first for the region.
So it's a more political decision.
Yes, yes, it is a political decision. Exactly.
Any comment?
Yes, I think that of course we can go in the direction to have priorities. What should be the parameters that maybe influence the priorities? One should be the importance of the structure. Maybe we have a structure that it is have an international influence. Another may be a local influence. Also, maybe we have to consider life safety if there is a monument that is in use. So we do this in convenient structures. When we make an assessment of a number of buildings, we put priorities in order that the political decision should be according to that priorities. We have a first level assessment that is a visual assessment in normal everyday buildings. We have a second level assessment, more accurate. And this second level assessment is coming to assess the most vulnerable buildings that is in the first level. So we have to go through these ways to put these priorities, take into account this, we have to classify actually the monuments according to their importance, vulnerability, and I say life safety.
Antonella. Oh yes, please. We need someone, not a structure engineer. We need. Yes, yes.
I would first like to comment on your first question concerning the modeling, the numerical modeling, and its reliability. I would like to speak out of two major experiences, the Hagia Sophia earthquake protection and the Holy Sepulchre structural integrity rehabilitation. Yes, okay. Concerning Hagia Sophia, at the early 90s, there was an interlinking between the response of the monument registered through the system that was established of sensors by Candeli Observatory and the Princeton civil engineering that Professor Chakmak, who developed the numerical model, to which I made a critique in the Bath conference at 92, because they were considering from bibliography the mechanical strength of the mortars, theoretical and homogeneous, which was not. So after we succeeded, after a common agreement between NTUA, Princeton, and Bogazici to work together, and we were able to sample. Professor Penellis was working with NTUA with us as well at that time. So when we were capable to measure the actual mechanical strength and to register decayed or weakened mortars at critical structural modes of the and posts of the structure, then Professor Chakmak said, we have an absolutely different idea on the modal shapes of the monument. And that was a more realistic estimation that means that numerical modeling has to consider both and the response of the structure to the actual frequencies, and this is the intervention of Professor Mouzakis, as well as the actual materials characteristics from the critical parts of the structure. And my second experience in the Holy Sepulchre could comment on both. I mean, when Professor Spirakos studied the numerical modeling of the Holy Sepulchre, he wouldn't be reliable if not adjusted by the sensors put by Professor Mouzakis, who estimated the response of the structure to various frequencies, because there we had not the actual earthquakes to establish a monitoring system, a permanent monitoring system. But we had to estimate the frequencies response of the monument. And second point is the indicative character of the use of the numerical modeling. I mean, I was expecting the results of Professor Spirakos' model when I gave him two possible scenarios of restoration mortars and injections that we would use in order to decide what would be the threshold of structural integrity in order to go on with the synthesis of the materials. That was indicative. And only afterwards, when we used for first time a layered model, because we were capable to make a 3D reconstruction of all the surfaces after intervention for every layer, then the model gave us a very realistic appreciation and evaluation of what we were doing. So it depends on the level. For your second question, I would like to comment that, of course, the power game is everywhere. But for us as scientists, and not only as active civil persons as well, I think it is very important to promote scientific support to policies. This is something that European bureaucracy promoted since 23 years, but it's not a fact yet. So what Professor Dritsos suggested might be a very objective procedure. However, we know that politics are not objective, and it is important to recall the common opinion for the importance of monuments from time to time. And it would be great if we could support this common opinion, which is actually screening the values of the monuments and granting a priority according to it. And we could support it through many technical weapons. For instance, in Constantinople, the mega city approach, which was to zone the earthquake risk, and according to it, to estimate priorities for retrofitting. So, yes, that was the mega city for buildings.
For buildings.
Indeed,
They are
I told you.
to this direction.
I told you, but for monuments is the common sense, the common opinion. It's people that could value for the value of the monuments. Thank you.
Please go. Introduce yourself.
Yeah, my name is Kyriakos Themistokleos. I'm from Cyprus. Just leaving the priorities to the politicians. Really dangerous proposition. And I would like to parallelize this, if you have a hospital with sick people, can you prioritize who's going to live and who's going to die? Or even leave this to the politicians to decide who's going to live and die. This is really dangerous. The thing that we have to talk here is prioritize how to save people, do preventing medicine, not wait until the patient dies. And this is something that Marinos talks about documentation. Why do we do documentation? We need to do, because after the patient dies, after a building is collapsed, a monument is already gone, it's really difficult to go back if we don't have the documentation, if we don't have the prognosis of what was the problem, you know, and even within the documentation, and that's why we do the multi-layering and we provide all the information about materials and so on, in order to do an initial prognosis what's wrong with the monument in order to fix it before it's too late. Because if we wait until the monument is collapsed and we wait from the politicians to decide if this monument needs to be repaired or not, then it's too late. The monument is already gone because an earthquake is going to come, some natural event and so on, and that would be too late for us to go and save the monument.
One comment is that as engineers, maybe we are able to give a priority in terms of structural safety. But even if we don't go to politicians, but we go to people working in heritage, very often the response I receive is that for them, the value of a monument is the same of the value of another, because each monument is important for something. Yes, so even within the scientific community, there is people that don't want to give priorities, to be honest. So this could be something we should agree on, a method to follow, because we cannot accept that all the monuments are the same risk against collapse, against loss of cultural heritage. So maybe we should try to find a way that should not only engineers, but also historians, architects, policymakers, all these people maybe should find an agreement and to present a method to politicians. Sorry to, please go on.
Thank you. My name is Marinos Ioannidis. I'm coming also from Cyprus. If I may ask something, let's say there is a monument somewhere, like the case now with Hagia Sophia, as you mentioned, Tonia. Who keeps a record on a national level? Who, when, what, why, how, with whom did something interfere with the monument? Is there any repository, any international standardized, let's say, list of items that you record so that there is a patient or a medical record or a digital medical record or whatever for the monument, so that even and in case an international team has to interfere to understand the complexity behind and make an estimation for the time, for the cost, for whatever it is needed, if and in case they have to interfere. So, and I'm coming back to this, what it has been discussed at the beginning of the conference, very briefly, a monument ID. You know, we are, most of us here, Europeans. our ID, whatever number we have on our ID, is unique. And these IDs are readable in all the member states of the European Union. And everybody has access to our records, criminal or not. Yeah? So they know everything about us, and there is no problem about the GDPR. Why not for the monuments? You mentioned the historians, the politicians, the whoever other specialists or users, I will say, multidisciplinary users, have to sit and decide. Isn't it the engineers or us, let's say, who have to advise them what to do? I mean, the minister was sitting yesterday next to Tonya. I'm sure he has no idea about all this, whatever is happening here. But if he gets an idea, because he's young and very motivated, at least that was my impression, he will do something, especially for Greece, or let's say Greece and Italy, or why not Cyprus also, yeah. But because I'm not under the Department of Antiquities, but Italy and Greece have something to say so far as culture concerned worldwide. So therefore, why not to start such an initiative with a monument ID, and under this monument ID, an international number like our IBAN, International Bank account number, and travel at whatever place of the world you want, from America to Europe to Australia. They will find out what is going on with your account if it's needed. So why not? No, okay.
That's why they don't create.
Okay, but I can tell you something. Erase from the culture or from the history, the whatever contribution came from your grandfathers in Italy, Roman Empire, civilization, and the Greeks also, the Hellenistic. You know what they will do? They will bring you to the court. Yeah, this is what's happening now in Ukraine. Yeah, and the UNESCO is saying it's a war crime. The destruction of what? World Heritage Sites. It is a very important issue, and we have to take that into account. So it's just only to convince the politicians on a pan-European level that they have to take that into account and do the job. And once when they do the job, you know what they will do next? They will go out to the media and say, oh, big success story. We did it. United in diversity and stronger together. And that's because of the culture. That's the third article in the Charter for the establishment of the European Union. That's culture. That's why it's very important. Thank you.
Thank you. Professor Mouzakis, would you like to add something? Yes. Professor.
Thank you.
No, not you.
Okay, thank you. I think that you have described a very nice multi-criteria optimization decision-making problem. But you need data. You need all this information either in electronic format or in classical papers, okay? Provided you have this data and you can quantify
that's an issue.
this data, aesthetic, historic, religious, whatever, then you could put these tools in work and give not one, they give you not one solution, but a number of alternatives. And then, of course, you need some politicians to distribute the restricted amount of money to put the priorities. It's a long way.
Daniel and Corina that are online, would you like to add something? I don't know if Corina.
Yes, Marco. I can just provide a very fast comment. When the resources are limited, you need to define priorities. I think this is clear. Then you can do it by yourself, I mean, the technical community, or leave it to the politicians, because someone will do it. I think we, as scientists, as engineers, we have this responsibility to do it and not to pass it to the politicians. So once we agree on this, then we have to define criteria. I think the criteria are very difficult. It's very difficult to quantify, but maybe in a first approach, we should go for qualitative criteria. Even a very simple way, the simplest method is better than nothing. It's better than pass it on to the politicians. So this is my view. I'm not expert on this topic, but I think this is my view, and it's difficult to do better at a starting point. Let's do it qualitatively, and then we go for an incremental improvement of the process. But the decision or the information at least stays on our side, on the technical side, and it will be a technical-based information and not a political-based information.
Thank you, Daniel. Corina.
Yes, if I may, if one takes a look at the scientific landscape that has been forming during the last 5 to 6 years, you will see technologies such as digital twins emerging for heritage, cultural heritage preservation, which is, I would say, spearheading technique and way to go. But these data-driven mechanisms are very time-consuming. The reliability issue is always there. But this is what future brings. The triangle, see, think, act. So the sensors will be sophisticated algorithm will think, and they will not actually act, but different ways of intervening to our monument while there is still time. It is a multidisciplinary approach. We need IoT engineers, we need archaeologists, we need engineers, we need all kinds of different disciplines. But this is where future will come. Together with human experience, as I said before, we shouldn't rule this out. But if one takes a look at what is up to date, digital twins and the so-called identity or IBAN for each and every monument, perhaps it will be an everyday solution for 50 years from now.
Thank you, Corina. And let's open another topic that, you know, I have been directed a structural laboratory for 20 years in Umbria, where we have a strong earthquake in 1998. And I am a fan, and I am a person who likes to do tests on site, tests in the laboratory. But I think also here we need to be honest when we do tests, because I see people doing tests on the single hard stone. They take a stone to the laboratory, they make a cube, and they make a test of the stone, and they found, I don't know, incredible strength. So it does make sense. Or I see people doing flat jack testing on site, on buildings that are 6 meters high or 8 meters high. They will never have problems in compression, never. So sometimes we push engineer professional to do on-site testing, but these tests sometimes are completely non-useful. So, and also here I think we need to be honest, we need to say what is important. So I think it's important is to do a good survey, unbelievable good survey. So we need to to look at the connections in masonry. We need to look at the cracks, okay? And then we can go on some types of on-site testing, like maybe a little bit shear test, but already shear start to be a little bit invasive. Dynamic is good, but how elastic is a behavior of a structure? Because when we do a dynamic test, we assume that the structure is elastic. Otherwise, we cannot measure the frequency of vibration of the structure if it's not elastic. So we need to find also here maybe an agreement, what should be the test that we should a little bit push? So survey, yes. What more? Dynamic analysis. When? For which structure? So this is another thing I'd like to discuss about on-site testing. For example, chemical analysis of mortars. What kind of information we get from chemical analysis of mortars? That's another, yes, please, Professor Penelis.
Usually, even in small monuments, we extract part of the mortar and we make tests in the laboratory for the chemical analysis. Yes. Of course, in small part of mortar, we cannot do reliable analysis for the test for the strength.
Of course.
We do what we can every time.
Yeah.
And for example, 1 year ago, we had to test the pre-stressed gables in the dome of Rotunda. How can you test an existing pre-stressed cable?
Yes.
Yeah. To see what part of the pre-stressing that was put 40 years ago continues to exist there. Okay. We did it, but we had to develop initiatives in order to do things like this. We had an extra load outside. It was an external pre-stress with not injected rings outside. We put vertical load. We measured the various loads, and from that we found out with the second order analysis the pre-stress of the existing pre-stress in the cable. But this is not codified.
Yeah.
You have every time to think of what you are going to do.
Is going to decide this. Because in Italy, you know what has been done? When they gave government support, economic support for reconstruction, they gave money also for testing on site. And if you do testing, the economic support was much higher. So a lot of people start to doing tests without understanding what they
are testing.
Yes. So yeah, that's something I think we should have a direction also in this regard. But Professor Stefanos, yeah.
It's very usual that when the engineer starts to make an assessment in a building and a monument, he needs some very crucial data. One of the crucial data should be the strength. And he has to take some data about that. However, what is important is that in monumental structures, there are more crucial other data than the strength, as it is the connections between the different parts, as it is also the specific conditions that may be found in the foundations. Normally we have settlements and it is not evident that what exactly happens. So of course we need the data from the materials. We need some crucial ones, but I think
also the single material. So
exactly.
also the bricks, the stone, and the mortar separated.
Exactly. Yes, we have to know something about the whole wall, but of course there is not many. I don't know any other ways to go through and find a reliable value for the whole element. So but if you ignore, for example, the connections, how exactly is the connection, then you lose more than from the accuracy of the materials.
Antonella.
Marco, this is a long story that I have to remind you. So we were young scholars when we have the opportunity to be involved in the post-seismic activities and survey in 1998. So a long history, but we have to remind it. So there was a problem that after the earthquake that several damage occurred on repaired buildings. So it was unexpected. Do you remember? So the civil agency, Italian civil agency, support the wide investigation in order to understand where the reason of these wide damages and diffuse damages. And it was point out that in several cases the intervention occurred on building, but they didn't know how was the building itself. The masonry, the stone masonry was multiple leaf masonry. The intervention were applied without knowing it. A lot of intervention rules in reinforcing concrete according to the time reuse to the code suggestions. But the post-seismic damage show the lack of compatibility with this criterion. A lot of intervention with carried out considering the building as a box, but it wasn't a box, and this was a problem because the corners were very weak. There were not a connection between the buildings evolved in different time, or maybe there were also I would say damage related to not a structural intervention. The problems related to, for example, the hydraulic installations according to the heating or other type of intervention. For example, the contours of the electricity that were placed in some place. The wiring, or also for example, the chimney flues. So a lot of damage occurred, and we were after that. I think that the code evolves, starting from Umbria, from your region, giving emphasis to the diagnosis, the knowledge process, and in 2005, at the end, we were the first code that was issued not from the Public Work Ministry, but from the Civil Protection Agency, that found that all the suggested intervention till that period were not successful. And then from that time, a sort of reconsidering of the activity related to historical building started. And we had the new national code in 2008 that received all the topics issued in the previous 2005 code. Giving emphasis to the diagnosis, the knowledge of the business, including the materials. And this information is very important, in my opinion, of course, to also design a correct intervention. For example, you mentioned mortars, but mortars characteristics are very important to design the future intervention. The mortar must be compatible. The stone, the strength, but also the porosity of the stone is important to design a mortar that is compatible with that stone, that you know how it is difficult to have a good adhesion between mortar and stones. So these information are really important in my opinion, including double flash jack test that gives you elastic modulus. We are discussing about structural modeling in the elastic field, but at least an idea of what is the elastic modulus of such measure. You need a starting point. You know all the problems related to reliability of the double flash jack test. However, is a starting point that you can calibrate, but otherwise you are working without any information at all. I remind you another thing that the code starting from 2005 define different levels of the behavior factor related to this knowledge process, divided 3 levels: a good level of wide knowledge, a medium level, and no knowledge at all. And having no information about the building is a very critical issue, because in this case at least Italian code produce a sort of penalty about your project that is quite invasive. And furthermore, this I think is another problem of that. So if you do not know anything about the building, including the diffuse building, because for the Italian point of view, okay, we have the monuments. For the Cathedral of Milan, we have research. We have research for the Tower Pisa. Why not? It's one of the symbols of Italy. But we have to think about the diffuse historical centers that are very important, also from touristic point of view. Touristic point of view means economy. Diffuse economy, your Umbria region is very rich from this point of view. So the code is also aimed to protect this heritage that is quite important for us. I would like just to conclude this idea about the tradition and our code. So it is a fruit of ongoing research. So I saw after so many years how is also the point of view of the professional people. So when the 2005 code was issued, we were really very happy. I found it as successful, because at the end someone wrote that we have to know the building, how it is, the building technique, transformation, because each transformation is a solution of continuity, is a weakening of the one part. We could have a lack of connection, the core and so on. But what happens now? So, at the time, there were a lot of courses for continuing education courses for professional people, and I remember that I was involved. I said, "Oh, you must take in account the characteristics of building. Each building is different from another. You must check exactly what are." How is, from the point of view of the characteristics, the weaknesses, and you must work to minimize the weakness, and including so an attention to the problem, the compatibility of the new intervention with the historical buildings. However, time has passed, and at the time I was very enthusiastic about this, and so started recently to do a sort of investigation. How is now the situation? Well, it's very sad because in many cases, particularly starting from the area that were not recently damaged by any earthquake, the memory of the earthquake is lost. And many cases, the engineer and the architects are working considering that, one building is equal to another, so they prefer to have a sort of penalty from the point of view also of the, I would say, the behavior factor, rather than carried out an investigation. In my opinion, this is a loss, I would say, occasion to do something from real important for if you are doing a design also for the project. So without knowing the characteristics of the material, you are creating a problem, compatibility of mortars, a lot of problems related to sulfate. You can inject material that are not compatible with the characteristic of the stone. If you have some limestone rich in sulfate, this can be a very dangerous issue. Or I repeat, you can repoint a mortar that are not compatible with the stone. So this maybe for an engineering point of view, maybe it's a waste of resource, but is very crucial for a correct intervention for the future building. So, thank you.
Yes, Professor Mouzakis, on-site and laboratory testing for professionals.
Yes.
It's something we can accept or not.
I think that is a thing that we cannot do without it. We cannot do any analysis without knowing crucial parameters of the monument. For example, we have to know modulus of elasticity and all these things and other parameters to find the normal modes of the structure. Even we know the normal modes and compare with the results of periods and the normal modes, it's needed to know the damping. What damping are we going to use for the analysis? That's why before I mentioned the need of a health monitoring system. We have to know the damping in order to do any analysis. If we'll say that I have to tell you my experience with the monastery of Daphne Monastery. We started at the beginning with a damping of 8%. Then, after a year, they did some ejections in the monument. After 6 months, the damping was 3%. And a far earthquake happened in Greece from a distance 200 kilometers at Kythira at that time. And after that earthquake, we measured again the monument with a monitoring system. And we found that the damping was changed again to 7%. You understand that these changes are very important for the analysis we are going to do. Maybe the changes in the natural frequencies were not so significant, but the changes in damping were significant. Therefore, that's why I insist that it's needed to have a lot of data before doing the analysis. And we have to record things in situ. For example, you mentioned the flakjack test. I understand that we don't need, it is needed to know the compression strength, but it's more important to know the modulus of elasticity. With flat jack test, we can start to determine the modulus of elasticity at various construction phases of the monument. I understand that is not, it's a little, you cause some problems as you are cutting the monument, but it's important to know these parameters, and you haven't other data to estimate these things. Therefore, I think that it's needed to do tests. Thank you.
Professor Stavroulakis.
It's needed to do a test, but the question is, do we fulfill the criteria of quality control? Do we have an ISO approved laboratory, certified equipment, trained personnel, and so on? Do our laboratories in the university fulfill these requirements?
And from online, Daniel. Daniel, I know you have a big lab, so.
You need experimental information. So you need to start with mass and stiffness in this, because you need to calibrate your model. Although the stiffness will change a long time, it's okay, but you have to start from zero, from a point. So in this case, dynamic identification is really necessary. So you can obtain this together with the mass from geometrical observation. Then the next step is nonlinear behavior. You know that linear analysis does not make sense for analysis of historical buildings. Nonlinear behavior will start very, very soon. So you need to describe these laws, and for this you need tests. Of course, you can go to the lab or you can go to in situ. In situ, you have the issue of the scattering. In the lab, it's very nice because the walls will behave more or less in the same way. So they are built by the same mason under an environmental control situation. So you should not expect many differences. And this is important, of course. But there is one point I'd like also to highlight that when you do the strengthening of these models in the lab, you test them after 1 month, maybe 2 months. So everything is perfect. And then if you apply the same reinforcement in the structure, so in situ, this will be tested after 10 or 20 years, especially if it is a seismic reinforcement. So in this sense, we have to be very careful with the lab tests. Of course, they are very nice. They are not so expensive compared to in situ ones. You have everything under control. The scattering is controlled, and I think we should proceed in this way. But we cannot ignore the in situ tests. In spite of all the scattering, all this, each wall is a wall different from the other. But I think we have to also to continue with in situ tests. And finally, I mean, you have a fantastic table of nonlinear properties in the Italian code, and we don't have this in Portugal. So this comes from a lot of in situ tests as well. So at the end, it is worth to do it.
Thank you, Daniel. Corina, more Greek experience also, please.
Yes, I think one has to think as a forensic engineer. So he has to adapt an attitude of forensics on site. So there is a crime that was underwent, and you have to solve it. So you have to do all tests necessary, and sometimes you don't even know what you're looking for, and many different tests combined together is going to give you the whole image, and this is important. So I think of it as spheres. You start from the materials level, which is a very important level, and you do as much tests as possible. This is not very easy. think it is easy, but it is not. It's also very multidisciplinary. I mean, we have had problems in the past with identifying the experts necessary to read a petrographic image correctly. There are recent pieces of information that might be missing or misinterpreted, and they can lead you a different direction. So it's very important to apply the correct experimental means and ways, and to find people who know what they're doing. So at the core of this, here are materials. Probably have to reverse engineer or so as to come down to a compatible solution when it comes to new mortars. And then you have the scale. At this, I completely agree with that. What lab will give is a comparative analysis between different solutions. So you keep your specimen the same. Nominally, it is the same as the one outside, which is never the case. It can give you a comparative interpretation of the capacity of different to augment the strength or the deformation ability. On-site testing on the components level is very, very important. And I keep getting in my memory, it's a very nice publication, Italian group, so actually performing a diagonal compression test a masonry on-site, which is very, very important and very useful, always very useful. And then you have the structures level, and then it is whatever Antonella said about the structures level, and then you have another level which encompasses all. This is the interaction level, the level of interaction of this surroundings. Are there any surroundings? Are there any pounding effects? How does this model interact with the environment and logical conditions? So there are levels of different areas that you have to investigate as a forensic engineer, actually, and then combine all and make an engineer judgment on what you're going to opt as a strengthening intervention. So each and every piece of this chain of events is very of course, if you want to do a thorough work, it's very costly, very time effective, but you have to be aware of the and then pick out the key ones in order to form a picture. And if there is a piece missing, then you should opt for the one and for the next one. It's a form of art, actually. It's a good believe, or a combination of both.
Yes, yes. From audience, please, Professor.
Tomorrow in the afternoon at 5 o'clock, there is a roundtable discussion, a panel, concerning in situ non-destructive testing and evaluation, and structural strength monitoring, of course. However, I have to say that the in situ test without validation in the lab is not reliable. We have to know what we are measuring and what we are assessing. And furthermore, we need to know that even if we have standardized with ISO the measurements in our labs, there are not ISO yet concerning the non-destructive and in situ testing. And it is only the validation with the in-lab measurements that we can provide. That means there are journeys to be made in order to arrive to some standardization. But this is not diminishing the value of in situ testing and non-destructive testing, because these are the tools we are having today. Thank you.
Any other comment? Okay, so if it's no comment, I think we can go for lunch. And I'd like to thank you everyone, and thank you for attending.
Could you hear me? Okay. We have to start, and all the presenters have 10 minutes, exactly 10 minutes. We must be in time, so we will advise you 1 minute before the end, and then we have to stop you at the finish of the 10 minutes per person, per presentation. So let me introduce the first presentation. The presentation is done by Dimitrios Nikolaos Kapiris. So Okay, so there's a change in the order of the presentation. So the first one will be Laura Medeghini. She comes from Sapienza University of Rome, and she presents Nympha, microalgae, polysaccharides for cultural heritage preservation.
Good afternoon. I'm here to present you the Nympha project, where Nympha stands for Natural Polysaccharides from Microalgae for the protection of cultural heritage. The project involved Sapienza University of Rome, the National Research Council in Italy, and different other institutions for the graphics, and thank you, and for the restoration that are part of the Ministry of Culture in Italy. So the Nympha project aims at produce innovative green materials for restoration, starting from microalgae, and it is focused on 3 different parts. So in the growth of the microalgae to improve and improve the growth and the accumulation of sugar in the microalgae. The procedure for extract the polysaccharides from the microalgae and characterize the polysaccharide composition and the polysaccharide mixture obtained. And finally, to test the possible application on different substrates for restoration and consolidation purpose. So the starting point was the fact that algal polysaccharides have been proved to have antioxidant, antifungal, cosmeceutical, and nutraceutical activities, and are applied in the different fields, medical, agri-food, and also cosmetic fields, but no application has been never tested in cultural heritage. So there's a video, I hope, yeah. So we have the first step, that is the algal growth. We have microalgae cell which grow in a controlled environment, and the algae cells are treated with hot water to extract the sugar content. The algae are the Chlamydomonas type. The obtained solution is centrifugate, and the precipitated is removed. And then here the precipitate, and then it is precipitate by adding cold ethanol to allow the precipitation of sugars. So after that, we need to dry the mixture and to obtain the final product to be then applied and tested on different substrates to evaluate the properties and the possibility to apply this product in the restoration field. Obvious and important aspect is also the characterization of the polysaccharide mixture, and so different chemical methods are applied, and instrumental analysis are applied to evaluate both the percentage of polysaccharides extracted from these algae, and also the monosaccharides composition. So the third work package was focused on the characterization of our polysaccharide mixture, and it is possible to evaluate again the percentage and the monosaccharide composition. And then the fourth and the fifth work packages were focused on the application of the product on organic substrates and inorganic substrate. For the first case, so on organic substrate, the first step was the characterization of the substrate. So we decided to try with pure papers. That was a filter paper with a high range of alpha cellulose, and industrial paper that was composed by cellulose and additive, and the composition was obtained using scanning electron microscopy and FTIR to define the morphological and the chemical features. And at the end of the characterization, we decided to use and to focus on the pure paper. But another important part was the comparison, the chemical comparison with two other products, Funori and Jun Funori, that are also in this case polysaccharides extracted from macroalgae that are widely applied in the field of restoration but are expensive. So we try to find a solution for this. So the extract was applied on Wattmann paper, so pure cellulose, and chemical analysis were performed was performed before and after aging, and the results show no chromatic variation, and the product was also applied on pictorial decohase layer to evaluate also the cohesive properties of this mixture, and also in this case a discrete cohesion was observed on pictorial decohase layer, and this aspect is going to be analyzed in detail in the next step of the project. Then we have the fifth work package based on the application on inorganic substrates. So again, we had the characterization of the substrate by chemical and mineral cryptographic analysis on the white marble that was the base of our test. Then we applied three different methods for the application: the drop, brushing, and spray, and the colorimetric analysis, the UV imaging, and the evaluation of physical properties suggest that the best method was the brushing method for the application, because no colorimetric variation were observed, and also the physical property were maintained before and after the treatment with the product. But concerning the inorganic substrate, the work in progress concerns the fact that the Nympha product was mixed and tested as an additive in the production of mortar for restoration, and it was compared with the primal B68, that is the additive widely used in the production of mortar for restoration. And as we did for the paper, we try to evaluate also the cohesive properties of the material, trying to evaluate the possibility to save the pictorial layer on marble substrate. So we are testing the cohesive property to define if with different substrate the cohesion is maintained. So here all the team of Nympha project, and thank you very much for the attention.
Thank you for the nice presentation. We have time for only one very short question. Yes, please.
Micro.
Thank you for your very nice presentation. If you know it, how do you store this material for if you don't apply it immediately after extraction? How do you store it?
Yeah, the biologists ask us to maintain only at dark and in a dried place, but no other problems are suggested for the storage of this material.
So just one more. So you do it keep it in water? I mean,
no, it's dried.
Afterward, yes, it's dried, and then you keep it dried. Okay, thank you.
Yeah, it is dried because it's the only way to maintain it. And so, okay, you're welcome.
Okay, thank you, Laura. I invite the next presenter, Dimitrios Nikolaos Kapiris, for using synthetic biology and biotechnology methods for the preservation of the marble monuments.
Good day to all. At first, I would like to thank the Third International Conference Organization of Transdisciplinary Multispectral Modeling and Cooperation for the Preservation of Cultural Heritage for the opportunity to present my team's project in the conference. So, my name is Dimitrios Nikolaos Kapiris. I study biology in University of Patras, and I am team leader of Patras Biology IGEM team. Our principal investigator is Dr. Ioannis Vasilopoulos, Assistant Professor of Genetics. Today I'm going to present you our project using synthetic biology and biotechnology methods for the preservation of the marble monuments. But before this, let me explain you what is IGEM. So, IGEM began in January 2003 as an independent study course at the Massachusetts Institute of Technology, where students develop devices to make cells blink. Nowadays, it is the biggest synthetic biology all over the world, and it takes place in Paris. Our team exists since November 2021, and its first name was Patras Uni Hellas. Trying to find the project matching to the slogan of the competition, local people solving local problems, we decided to deal with the preservation of our cultural heritage. Greece is a country with very important and long-lived history, and monuments since the ancient times until modern age reveal the advance of the Greek civilization throughout the centuries, consisting the trademark of our cultural heritage. A lot of monuments are made with marble, a product with a material with a high production in Greece, which quality and exterior can be unfortunately abased by biotic and abiotic factors. Impressive marble monuments exist not only in Greece and in the Mediterranean basin, but also all over the world. So the limitation of their erosion is of high importance. So bioerosion is a phenomenon caused by biotic factors, and it is defined as the decomposition of the materials of an object by microorganisms which either nest and develop or feed on it. The classification of the microorganisms on the marble is based on their localization and distribution over the substrate, and thus we have epilithobionts which live on the marble and olithobionts which thrive into the marble, and they are divided to chasmolithic microorganisms which thrive in pre-existing cracks, euendolithic microorganisms which enter the substrate, and cryptoendolithic which live under the surface of the marble. Until today, the most important techniques against bioerosion are the chemical biocides, which may be effective against the microorganisms living on the marble, but they have a number of disadvantages. In particular, their application should be done during the spring months when tourism flourishes, so not only conservators but also many tourists come in contact with the chemical compounds. In addition to the human factor, these chemical compounds can be dangerous for the environment and for the marble itself. Thus, our research team came up with the idea of creating Mercure, a marble erosion cure, a biological biocide, which major component will be the antimicrobial peptide dihiplesin, using the methods of synthetic biology and biotechnology. Let's see what are the antimicrobial peptides. They are molecules produced by many tissues and cell types in a variety of invertebrate, plant, and animal species. The composition of their amino acids and their size allows them to enter the membrane and thus killing the microorganisms. Dihiplesin is such a protein produced by the Japanese crab Dihipleus rhodotanthus, which have a very widely antimicrobial action against many gram-positive and negative bacteria, fungi, and viruses. Apart from the topic discussed, I will now present you our experimental procedure. At first, we selected a plasmid with ampicillin resistance gene, so our E. coli cells being resistant to ampicillin after their transformation. Then we designed the insert sequence with the dihiplesin gene, and we recombined the plasmid with the insert sequence. The next step was the transformation of competent E. coli bacteria in order to produce dihiplesin. Then we cultured them in LB agar with ampicillin, and the other day we found out that the culture was blurry, so we know that these bacteria are transformed. Our next steps include the isolation of dihiplesin, the assessment of its antimicrobial action, the appreciation of any effects that it might have on the marble, and then we will try to create our final product. As far as the project safety is considered, because of the hemolytic action that dihiplesin has, we used its analogues I11S and Y8S, which have very limited hemolytic action. But in any case, we will establish appropriate dress code for the conservators so they will be safe while using the biocide. The antimicrobial peptide will be isolated from the bacteria so the mutated microorganisms will not come in contact with the environment. This project was presented at the IGEM 2022 competition, and it received very positive feedback from the IGEM community, so we decided to recruit our team and rename it to Patras Biology IGEM. And now we are preparing our participation in IGEM 2023 competition, trying to evolve our project as much as possible. Here you can see our social media, our bibliography. Thank you for your attention.
Thank you. We have time for one short question. Please.
My question is if you have applied the solution on real archaeological material.
No, last year due to financial, due to paperwork delays, we didn't have enough time to do our experiment. So we are in the phase of recombination. But now we have the archaeological marbles, and when we will have the tachyplecin isolated, we will try to apply it on the marble and see the results.
So thank you. And the next presenter is Chiara Genova from Sapienza University, and she presents a novel approach to control the biodeterioration of wooden-made materials based on chitosan nanoparticles loaded by R+ polygon.
Thank you very much, and I'm very happy of being here to present my work. As the presentation before, we tried to develop a system for the conservation of biodeteriorated artifacts, but in this case the support is different because we focused on wooden materials. In fact, wood, since the very beginning of human history, represent one of the most employed material for the construction of building and other tools. That, since its organic composition is very subjected to biodeterioration and faster than the one that happens for other inorganic materials. Biodeterioration of wood is mainly induced by fungi, and between them the one from Aspergillus species are responsible of different deterioration phenomena, included the phenomena of the soft rot, which is irreversible, and for this reason a lot of strategies have been employed during the time to reduce this problem of fungal growth on wooden materials. However, different drawbacks concerning the chemical methods employed since now have been highlighted, and recently the scientific community is moving towards the development of alternative methods that implied the employment of natural substances having biocidal efficacy. In this sense, one of the most employed substances are essential oils that are natural compounds extracted from plants and plant materials with assessed biocidal activities against a lot of microbiological species, including fungi. And it's well known that they are very heterogeneous substances with a very heterogeneous chemical composition, but the presence of one or two main active components is responsible of their biocidal activities. For this reason, a possible alternative to essential oils can be represented by their main active components themselves, and a lot of advantages can be related to the employment of the active principles, since it will be possible to obtain biocidal compounds especially conceived for targeted microorganisms at certain concentrations, and reducing the high production cost related to the extraction of essential oils. For this work, we decided to employ R+ pulegone, which is the main component of the essential oil of Clinopodium nepeta, which is a plant commonly found in the Mediterranean area. And also we decided to develop a system to encapsulate the biocidal substances, since the non-encapsulation has several advantages, reducing, for example, the high volatility of the substances here employed. And to obtain nanoparticle systems, we decided to use chitosan, which is a natural polysaccharide deriving from the deacetylation of chitin, able to form nanoparticle systems with a harmless and eco-friendly synthesis procedure, which is called ionic gelation, where chitosan, for its cationic nature, interact with an anionic crosslinker, which is tripolyphosphate, and forms nanoparticles nanoparticles where the drugs or the other substances, as in the case of pulegone, can be entrapped. In this study, we decided to use 4 different concentration of pulegone inside the nanoparticles at different molar ratios. And the experimental design provided, the experimental setup provided the synthesis and the realization of the nanoparticles, their characterization throughout DLS, dynamic light scattering, and FTER spectroscopy, the evaluation of the biocidal properties of the single substances against Aspergillus niger in vitro, and then the application of the nanoparticles on in biodeteriorated samples where the biodeterioration was induced. In fact, we decided to employ 3 different types of wooden samples that they will be for a part buried, and it was created a natural biocolonization, and for another part inoculated in laboratory with Aspergillus niger, and then they were treated with our nanoparticle treatments. Concerning the results, this is the preliminary phase of the project, and from the first characterization throughout the FTR spectroscopy, it can be said that the loading of pulegone inside chitosan nanoparticles occurred, since it's possible to observe characteristic peaks of pulegone inside the nanoparticles loaded with these substances that they were not present inside the one without the presence of pulegone. For how concerns the synthesis and the efficacy, we are in the preliminary phase, but we obtained encouraging results for how concerns the nanoparticle loaded with a molar ratio between chitosan and pulegone 1 to 0.5, that they demonstrated to have small dimensions and a low polydispersity index. And we decided to employ this system for the future application, also because we obtained encouraging results for how concerns the biological activity against Aspergillus niger, where the chitosan loaded with pulegone at 0.25 was the most effective in terms of quantity of product presence and reducing of the growth of the fungus. The first application provided the inoculation with Aspergillus niger, and we obtained controversial results because, as you can observe in these circumstances, the presence of the nanoparticles seems not to reduce the growth of Aspergillus niger on these samples that they were Albies alba and Quercus petrea. But different results have been obtained in the case of Fagus sylvatica, where the presence of the treatment seems to reduce visible the growth of Aspergillus niger. Furthermore, the buried samples also showed a variation after the application of the treatments, and the possible reduction of the biomass was also established throughout colorimetric measurements, where we represented the differences between the first the burial and after the burial, and then after the application of the treatments. In fact, we can observe a decrease of the colorimetric differences after the application of the treatments, except for 2 cases, and this is an aspect that we have to investigate in deep, but we can observe, we can relate the colorimetric differences and the reduction of the delta A to a possible reduction of the biomass. In conclusion, the ionic gelation of chitosan demonstrated an efficient method for the non-encapsulation of drugs and other substances, as in the case of this biocide. The activity of the substances have been demonstrated in vitro, Furthermore, something that I have not underlined, but the presence of pulegone increase the biocidal activity of chitosan, which is present but not so high. And these systems can be employed for future application on cultural heritage, but we will want to investigate in deep more other aspects. For example, the synthesis of smaller dimension nanoparticles, the characterization of these nanoparticles with other analytical tools, and the effects of these systems in a long-term period on the samples. Thank you.
So we have time for one short question. So, okay, we can move to the next presentation. Thank you, Chiara.
So, for the impact of environment on cultural relics, Hongshu Pu. I invite Hongshu Pu. Maybe it's the pronunciation? No. So, okay, we can move to the next one. So, 54, approaching climate resilience in Greek cultural heritage using geodata and geoinformatic tools, by Athanasios Dimou.
Hello, do you hear me?
Yep.
Okay, I think you... Okay, good evening to all. Everything is okay? Do you see me? Do you...
We can hear you, and also I think that everything is everything works.
Okay, thank you very much. My name is Athanasios Dimou. I am a geoinformatic and surveyor engineer. I am a PhD candidate at the University of the Aegean, and also I am an employee of the Greek Ministry of Culture. Our title for today with Christos Anagnosopoulos is Approaching Climate Resilience in Greek Cultural Heritage Using Geodata and Geoinformatic Tools. The scientific community and policymakers recognize that adaptation and resilience measures and strategies are needed to minimize the impacts of climate change. Since spatial information is a key factor for any aspect of resilience to climate change, and in order to enhance the resilience of cultural assets, it is necessary to adopt a multidimensional approach centered around geospatial information. The modern tools of geoinformatics, such as GIS, satellite remote sensing, photogrammetry, spatial analysis, etc., are a solution and utility in modern societies for the development of these systems. The definition of climate change is directly or indirectly caused by human activity and alters the composition of the global atmosphere in addition to the natural climate variability observed over comparable time periods. From the 80s, governments realized the magnitude of the problem, and from then we had many summits, protocols, agreements like Rio Summit in 92, Kyoto Protocol in 97, Paris Agreement in 2015, and the goal is to balance the temperature of the planet below 2 degrees. Sentai framework, who therefore first time recognized cultural property as a key factor in disaster risk reduction and states that heritage must be protected in order to improve resilience. And nowadays we have the agenda of the UN and the UN goals. Resilience defined as the ability of a social ecological system to respond to climate change, to adapt and improve the sustainability of the system to better prepare for future impacts of climate change. Based on a large number of research articles and reviews categorized and explained the key components of climate resilience, such as evaluation and monitoring, the scale, learning and innovation, information and transparency, environment, network system and agency, and many more, as you can see. Climate impacts on cultural heritage include rainfalls, floods, coastal flooding and storms, temperature, humidity, table water, and chemistry. Some impacts of climate change by country had been recorded, and from 2000 we had the wettest autumn in England and Wales. In 2003 we had the hottest summer in Europe. In 2007 we had the hottest summer in Greece, and many more till today. Some impacts for Greece: forest fires in the area of ancient Libya due to the high temperature at the 2007, as I said before. The medieval city of Rhodes was threatened by a complex combination of natural factors of decay, artificial factors, the sensitivity of local building materials, and an inefficient city development planning system. And the archaeological site of Vilos, with its location near the sea in the middle of the Aegean, is exposed to threats and dangers to the ruins. All ancient structures or outdoor sculptures are exposed to various environmental factors such as winds, rising sea and groundwater levels, and many others. We have some others too, but this is some that I want to present to you. So, what is geoinformatics and GIS? Some definitions of these two. Geoinformatics referred to as the kind of working with geodata to better understand and interpret human interaction with Earth's surface. And GIS is an integrated system of collecting, storing, managing, analyzing, and displaying information related to issues of geographical nature. Geodata, according to the literature, which are suitable for the calculation of resilience and climate change. Some of them are the data of boundaries, topographical data, urban planning data, spatial data, demographic data, environmental data, climatic data, of course, and satellite data that can be used. The tool that I used to collect and to create some of this geodata that I will show you next is the QGIS, the open source software for geographical information system. The study area is the volcanic arc of Greece. The specific volcanic arc shows intense volcanic activity and was created due to the convergence of the two lithospheric plates in the Aegean region. The area includes the volcanoes at Soussaki, Methana, Santorini, Milos, and Nisiros. Three of them are active with past eruptions. Along the arc, there are important cultural and archaeological sites that need protection and attention, mainly because they are exposed to island complexes and coastal areas of particular natural beauty and area. Some of data I have created is the coastline of the area. I used some base maps of ortho maps with good resolution, and I created the coastline of the study area. As you can see, the first map. I take the digital elevation model from the official Copernicus site of the Europe, with good resolution also, and I created the slope data and aspect data, also contours and hillsides, and all this can help us for better understanding the surface of the study of the area, as you can see in the maps. Also, I used road and river networks, and I created some categories of these two networks. As we can see in the right image, in the right map, we don't have big rivers in the study area, in the volcanic arc. The roads, of course, we have many. I used download from the archaeological cadastral of the Ministry of Culture, of the Greek Ministry of Culture, the archaeological sites and the monuments, also the marine sites. In the left image map, we can see with polygons the archaeological sites in the study of area, and in the right image, we can see with points, with spots, the places where we have the monuments in our study area. Now, I used the weather stations, the data of weather stations of specific 55 stations of the study area for a decade, from 2010 till today, and I create an average temperature of the study of area used kriging and interpolation method. As you can see in the left map, with the bright red is the pixels, okay, the regions, the places that we have the high value of temperatures in our study of area. And also, in the right map, we can see the average temperature for the sea bottom for the last 5 years.
1 minute, Anastasio.
What?
Minute.
Yeah, thank you. I took from the last 5 years satellite data from the average temperature of the sea bottom. Finally, I combined, this is all geodata. It was a big scale, the area of volcanic arc, and we can spot that many islands have high values, and especially in volcano arc, our area. Islands of Milos, Paros, Santorini, Delos, and Nisiros, they need more caution and more research in smaller scale. In conclusion, resilience is approached in the global literature mainly theoretically. The use of innovative tools of geoinformatics science and precision geodatas of the region are modern tools for a different approach to climate change for our country with a rich cultural heritage. The creation, use, and processing of appropriate geodata in combination with appropriate quantitative and qualitative characteristics of each area understanding and maps and combines geodata as a result, it becomes a tool for making important decisions and political decisions for the protection of our cultural heritage. Thank you for your attention.
Thank you. We have the time for one short question.
I have one. No, please, you first.
I would like to ask Anastasios if he's satisfied with the time scale, the data they use are for the last 2 decades. Is it enough for your studies, or are you
for the big scale I used for this study area? I think it's good enough. But our next steps is to go in the smaller scale, so we try to have measures field. So I think it's good.
Okay, thank you so much. So we move to the next presentation by Antula Consta. Antula, sorry for the bad pronunciation. The concept of risk and its measurement in the field of the built heritage conservation. Sorry, you have to turn on the microphone.
Okay. My name is Antula Consta. I'm an architect, and I finished my PhD at Politecnico di Milano in the course of Built Heritage Conservation. The co-author of this paper is Professor Della Torre, who was the supervisor of my PhD thesis. The subject of my research concerns the assessment and the management of risks for historic buildings. The presentation of today is related to the concept of risk and its measurement for the built heritage conservation. The presentation follows this scheme. We're going to start with the scope of the study and the method deployed, then the results, and finally the general conclusions reached. The term risk has been defined in different ways in the various fields. As a result, a certain confusion is created around the meaning and the use of the term risk. The scope of this study is to understand better the variety of approaches to the concept of risk and consequently its measurement. In particular, the aim is to highlight the various aspects of the concept of risk that built heritage conservation developed and how these aspects have led to the use of different methods of assessment and evaluation of risks. In order to achieve this, 3 representative studies have been considered. Firstly, the overview of different risk perspectives made by Ortwen Ren and his proposal for their integration. Secondly, the overview provided by Douglas Hubert and his insistence on the importance of a scientific approach to risk management. And thirdly, the distinction between the qualitative and quantitative definitions of risk approved by the Society of Risk Analysis. The first study carried out by Ren distinguishes 7 approaches to the conception and assessment of risk. As Ren underlines, the diversity of these concepts depends on the selection of the base unit, the choice of methodologies, the complexity of measures against the risk, and the instrumental and social function of the risk perspective. According to the author, the first 3 approaches can be grouped together as technical risk analysis, with the aim of risk reduction. The other perspectives on risk broaden the concept of risk by focusing on the evaluation of the risk context and the associations between the risk and social or cultural artifacts. Thus, Ren suggests the integration of the different perspectives and not their replacement. That is to say, cultural and social considerations cannot supersede technical and economic considerations, but should incorporate them in order to offer a frame that assigns each perspective an appropriate place and function. The second study made by Hubert proposes a division into four general groups. The taxonomy, as the table shows, takes into consideration the types of problems they focus on and the methods they use. The author's scope is to analyze the problems faced by these diverse schools of thought and to propose methods to fix them. Criticism has focused, on the one hand, on the most popular newer methods that do not work properly, and on the other hand, on the fact that the risk managers do not employ effectual methods and techniques that have been developed in the course of time. The third source taken into account is the document Risk Analysis Foundations and the glossary proposed by the Society for Risk Analysis. The work is based on the idea that although there are difficulties to agree on one unified set of definitions, it is possible to provide well-defined and universally understood terms and concepts that allow for different perspectives on basic concepts and distinguishes between qualitative and quantitative definitions and their definitions. The definition of risk, that is the degree to which loss is likely to occur, as a combination of 2 principal components, hazard and vulnerability, present, as we can see among the quantitative definitions of this table, is widely acceptable in the field of built heritage at an international level. The former term regards the probability that a threat of a given intensity will occur in a particular place, whereas the latter concerns the degree of loss associated with a particular hazard and related to the exposed system and its propensity to be damaged. In regard to the 3 frameworks of risk perspectives discussed before, the following aspects emerge. The approach to risk, developed in the field of built heritage, shares the same point of view with engineers, who model systems of components and their interactions. The vulnerability studies concerning historic buildings draw attention on the complex interaction of different elements, materials, and boundary conditions. The second aspect regards the twofold character of the built heritage conservation. On the one hand, the safeguarding of the cultural values associated to the building materials and techniques, and on the other hand, the guaranteeing of the necessary level of its technical performance. In order to balance these 2 aspects and to determine compatible solutions, it is required to define the possible alternatives, to identify and analyze their consequences, and then to select the most acceptable option. Under this perspective, the acceptable risk is the risk associated with the most acceptable alternative in a decision problem. Concerning the measurement of risk, among the various approaches stand the common methods of experts audit, stratification methods, weighted scores, calculus of preferences, and probabilistic models. For example, the Monument and Wacht inspection approach to the evaluation of damages and priorities is based on the experience of the inspectors. The Italian risk map, like all stratification methods, make use of 2 or 3 ordinal scales, which are multiplied together in order to get an aggregate score. Another example of scoring method is the risk index elaborated for the advanced diagnostic protocols, used as a part of a documentation system and organized as a control procedure addressed to support decision-making. During the last years, the multi-criteria decision analysis has been applied in the field of cultural heritage. The European standard is a practical application of multi-criteria decision analysis. And finally, the probabilistic models, a representative example, is the new environmental risk assessment methodology for cultural heritage protection based on the concept of the systems theory and of the probability. In short, starting from the definition of risk in different scientific areas, the paper highlighted the 2 aspects of the concept of risk that built heritage conservation adopted and developed. The engineering approach, based on the modeling of systems of components and their interactions within the environment, and the concept of compatibility, based on the notion of the acceptable risk and its evaluation. In regard to the different approaches to the assessment, though the presence of limits and critical aspects of the methods, such as the difficulties in comparing and aggregating diverse risk, as well as the difficulties in integrating cultural and technical issues, what gains importance is the continuous effort to set up more formal procedures for the measurement of risk. Thank you very much.
Thank you. As usual, we have time for 1 question. Yes, please. Could you use the microphone, please? I don't know if you have one. Yeah, that's one.
So what kind of risk are we considering here? It could be extreme weather risk, it could be an earthquake, or what is the risk that you're trying to measure?
Yes, here the question is open. It covers all the risks.
Did you apply it anywhere? It's a very nice holistic mapping of all the different measures of risk, but did you apply it in one case study? Let's say in your PhD, did you apply one of the risk measurements?
This work has to do with the creation of a framework in order to understand better the different approaches and the different aspects that are relevant to the built heritage conservation. Here we show some of methods of risk assessment that cover different risks. For example,
it's okay. You can just tell me. So yes.
Yes, the risks where the built heritage is exposed, the picture is very, very big. But it is important to put together the different analyses and try to
cover all different elements that are connected with the culture.
Consideration all the different analyses. This wasn't a presentation of a new methodology, neither of a new definition, but only to highlight some important aspects that have to be considered.
Did you try to integrate different risk measurements?
I have to ask you to... Sorry.
Methodological approach in order to consider all the risks of built heritage.
So, thank you. And now Arturo Cruz with Planning to Live Longer, a model for the maintenance-focused heritage building conservation.
Good afternoon, everyone. My name is Arturo Cruz, and I'm here to talk to you about the output of my research, which was completed in the midst of pandemic when everybody is not doing anything. The title of my research is Planning to Live Longer. It's about developing a model for a maintenance-focused conservation management system, and it's done in Australia. But before that, I just want to know if you know the difference between the heritage building in Australia and as compared to the heritage building here in ancient city like Greece. Australia being a young country, our heritage building is considered to be less durable or have shorter expiration date because during the early colonization, Australia took advantage of this minimalist approach, which you use minimal materials to obtain maximum height, maximum span, and of course maximum profits. And in addition to that, we use, during the early colonization, the use of synthetic materials like reinforced concrete, vinyl, plywood, silicone, to name a few. And over the years of using these synthetic materials and minimalist approach, the most common problem that we have in our modern heritage buildings are the phenomenon commonly called now as the concrete cancer, corrosion, delignification, and so many problems with modern heritage. So back to my research. I did 3 comparative analyses of the modern heritage building in Australia, namely the Sydney Opera House, the Brisbane City Hall, and the Royal Exhibition Building in Melbourne. Did comparative analysis and archived so many records that only available on site. Did interviews of 17 experts around the globe, and to validate my theory or my model, it was validated by another 7 international experts in a focus group discussion, which was done in the conference in Belgium some time ago. So using this approach, I developed this model to make the modern heritage building with us longer. But according to my interviews, there are so many parameters outside the building codes and outside the heritage charters that have to incorporate in our charters and codes to make this model work. And I will discuss that later. But in Australia, and I think anywhere, there's one item of conservation that's undoubtedly the favorite approach in conservation, which is repairs. And I just want to identify repairs in maintenance. Repairs are the things that you do when failures occur, or when failures happen, you do repairs. But then maintenance is the thing that you do for the failure not to occur as much as possible. So while this is the case, you cannot just stop the practice, otherwise it might get worse. But in this model, I develop a system to spin it towards this model of a maintenance-focused conservation management system. One of my case study, the Brisbane City Hall, this is a prime example that maintenance is the main, this is what triggers repairs and maintenance, repairs and restoration. Lack of maintenance is what happened. In my case study of the Brisbane City Hall, it was found out that the building was sinking on its foundation, and it cost them $215 million just to repair and restore the building, only to find out that the problem was just a result of the failure of waterproofing in the roof that just created another problem. So what they did is, they did tremendous repairs and restoration, putting concrete on top of the other, which you call concrete overlay. And so what happened when you put concrete on top of the building? engineers here know that when you added weight on top of the building or any structures, you will also add force that will act on it laterally. So, so what they did is during the event, like the weekly line dancing in the third floor hallway, when you do that, you will increase the resonance, and according to building code, you cannot exceed that amount of resonance. So what happened is they just prohibited the line dancing that used to be on the third floor, and now you can only do it on the lower ground floor. So what was the lesson learned here? So in conservation, tools and technology is very critical because there's so many items that's not available. Oh, you cannot see it with your naked eye. So luckily, there's so many tools and technology that's available today in the market, like the structural health monitoring and the beam information modeling, where you can store all the data that you need, the lesson learned, the pathologies, the plans, that you can store it anywhere on site or even in the clouds. So if you integrate tools and technology, I think that my model will work. In one of my case study, the Sydney Opera House, they are just completed beaming their system. And I just want to mention that the Sydney Opera House is a high-profile building that they can afford this technology, but generally it's not available widely in so many heritage buildings in Australia. The other factors is training and licensing. So in Australia, there are so many people who, although expert in conservation philosophy, but they are not expert in repairs and maintenance or conservation. And likewise, there's so many people who are like myself. I actually in the repairs and maintenance, I'm on the other side of the fence. But before this research, I don't know anything about the philosophy of conservation. So training and licensing can bring it up to the standards. So the Dutch has what they call the Momentum Watch. Well, they started with the support of the government, and now they're working independently as private group. And in Australia, we have a professional body like the building surveyors and building inspector that used to work with the local government. But there are people who actually work in the new development and they don't want to touch the repairs and maintenance. With a bit of training, I think you can spin off those people who can engage in heritage conservation. My research reveals that currently there's a lack of maintenance in heritage conservation because maintenance is considered to be time-consuming, and because of that, it's perceived to be expensive, and that's for the owners. And for the operators, they find it that it's actually an unglamorous job. They find it that it's a low-key job. Nobody wants to be called maintenance architect or engage in maintenance-only conservation. They would rather do repairs, restoration, adaptive reuse, and those things. And as a result, the favorite form of conservation are major repairs, adaptive reuse, and repairs and restoration. So that's basically what's happening in Australia. So I think that's where the market creations come in. That is probably because there's no culture of dispose and replace in this age of abundance, and there's no market existing in maintenance. So I think that's where you need to create the market for those people to be to engage in conservation, and that is the frame of market creation. It can be kickstart in the form of government initiative and incentives. So there are two types of incentive. Either the owner will get paid or the owner will not pay. So in the UK, the government gives funding and incentives in the form of grants, especially in the maintenance conservation. And in the US, they give incentives in the form of tax break. And if this will happen to Australia, these grants should be balanced more towards the maintenance-only conservation rather than the one-off capital repair-only conservation. So in Australia, we introduced this conservation management plan to be introduced in in any accessible development. But if that's not accessible, it's only maintenance. There's no requirements for conservation management plan. And I think we need to revise the culture. So we have this, what you call the Barra Charter, that it was a leap of the Venice Charter, it was also a leap of the Athens Charter, so everybody knows. And this is actually my deliverables. We have to have a conservation management plan that's actually prioritize maintenance, that introduce this conservation management plan that will take advantage of the tools, technology, market creation, and the government that will support the introduction of maintenance in the conservation management plan. And that's my research in a nutshell. Thank you very much.
Thank you. Is there any question? Okay. Thank you.
So the next presenter is online, is Mernaz Rajabi, and the presentation is toward regenerative role of cultural heritage and climate resilience, the case of Indian water infrastructure heritage.
Good afternoon. Could you hear me and see the presentation?
Yes, we can hear you.
Okay, thank you. Good afternoon to all. My name is Mernaz Rajabi, and I'm going to present my paper, which is actually is developed and is written based on my PhD dissertation, which around 5 months ago I concluded under the supervision of Professor Stefano Della Torre at Politecnico di Milano, and here I'm going to present a small section of a small part of my PhD dissertation. My presentation outline will start with with the objective and introduction, and going through the presenting some proactive program regarding Indian revitalization of water management, with a specific case of Indian staples and its conservation and development programs, and also giving you some issues and recommendations regarding climate change and heritage synergies, and concluding with some reflection. The main objective of this research is to present and highlight culture and cultural heritage complex interrelationship with climate change at the international and Indian level. And as we all know, the heritage field and the climate science field warned us about the threat of climate change to our communities, safety, ecosystem, our cultural heritage and natural heritage, also their value attributes, integrity and authenticity. However, despite great effort of all United Nations post-agenda for development, the current policies on climate change and disaster risk reduction have not yet been centrally positioned in respective plans for heritage, and cultural heritage still does not have a central role in policies regarding climate change and disaster risk reduction. Recently, the United Nations Intergovernmental Panel on Climate Change stated an increase in the multiple climate-related risk across sectors and regions, especially in India. And in specific, the impact of climate change on water resources is very vital and is very evident, and that urge all of us to think about the contemporary role of Indian well-rooted and culturally feasible pre-industrial water infrastructures. In that regard, some proactive programs in India started at the national level. For instance, the National Action Plan on Climate Change, which contained 8 missions to address climate change concern, and in a specific, the National Water Mission, which aimed at implementing National River Conservation Plan for cleaning the rivers and employing traditional techniques for rainwater harvesting. And at a comprehensive level, World Monument Funds started the projects with the aim to comprehensively create a repository of information on traditional water system in India, with the aim to create knowledge for further steps such as feasibility study, survey, and analysis. And also, I can tell you about the ICOMOS India, the Water Heritage Working Group, which aimed at leveraging potential of traditional knowledge and management of water management systems in India. At the state and local level, the Gujarat and Rajasthan states and also Ahmedabad, Gandhinagar regions are very active in that regard because of their governmental concentration of activities and programs, as well as the intensity of the presence of water infrastructure heritage due to their harsh climatic condition. And at a local level, for instance, at the Heritage Department of Ahmedabad Municipal Corporation, started the project for the revitalization of traditional water resources. And generally speaking about the water infrastructure heritage, specifically Indian staples, they were structured actually that for collecting water, and nowadays they are drastically, most of them neglected, abandoned, and only one of them is the World Heritage Site, and some of them are protected. For instance, the Rudabai staple at Adalaj village, which is located near Ahmedabad city, and here you can see is a protected boundary of the staple by Archaeological Survey of India, which is responsible for the protection and management of national monuments in India. And this is the historical village. And here we can see the tourist facility which constructed around 2008. And you can see here the transformation of the surrounding area was the staple in between 2003 and 2023 due to separate development plans, tourism promotion, regional smart development plans. And we can see the transformation of agricultural field to residential and also business sector. And here we can see the tourist facility, it's better to say underused tourist facility, and its degradation due to insufficient interrelationship between Indian organization from national to local levels. And by analyzing the main acts of the development plan with dominant policies in the surrounding area was April. I should tell you the acts mostly have physical manifestation. They are top-down centralized and also financed mostly by central governments, and there is no proper coordination and community involvement. And in my PhD dissertation, I classified those issues in 6 categories of the categories, and I'm going to present here only climate change and environment. And these issues also is categorized in institutional, technical, socio-cultural, and financial issues. Regarding institutional issues, for instance, the integration of cultural heritage in national adaptation plans, we face this the inclusion, and only Italy, France, United Kingdom, and Ireland have included cultural heritage in their respective plan. And also we face lack of recognition of cultural dimension of climate change, and also cultural understanding of risk on resources, specifically by policymakers, scientists, and economists. Also, on the other hand, we face lack of integration of climate action concern into heritage management processes, policies, decision making. But these issues is not related only to India, but also related to all international level, and this is due to the fact that we face a lack of dialogue and collaboration between the two fields. And briefly regarding technical issue, we face lack of information and analysis on the correct and projected impact of climate change on heritage, lack of effective data collection mechanism, and risk and losses data. Regarding I'm giving you some recommendation that I classified in two categories of vision and commitment, collaboration and actions, and the second is bridging knowledge gaps. The first one, we should integrate culture and cultural heritage as separate sector into national adaptation plan to climate change. That national adaptation plan to sectoral plan of Italy and Ireland are inspiring plan in that regard. And as we have we face lack of collaboration, the very recent and first ever collaboration of heritage and climate science field also are inspiring initiative of government of Greece with UNESCO and World Meteorological Organization to support cultural and natural heritage protection from the impact of climate change also are inspiring. Regarding water infrastructure heritage,
excuse me, 1 minute left.
Research, accurate data of the current and projected potential impact of climate change. We should promote, mobilize, and establish research for investigating cost-effective strategies for research, risk reduction, and collecting reliable and accurate scientific data information. And also we should develop pilot projects at different level and in a multidisciplinary approach and with several actors. Regarding bridging knowledge gaps, also we should assess the impact of climate change on heritage, and in that regard European projects were very successful, use the combination of climate modeling and building simulation tools, and also the developing new technologies in that regard.
Could you hear me?
The very recent European strategy on adaptation to climate change is inspiring.
Could you hear me?
Strategy aim at making adaptation smarter, more systemic and swifter. But I would like to emphasize that
can you hear me? I'm talking. I don't know if you can hear me. Could you hear me?
Sorry?
Yeah, you finish your time. Could you conclude your talk, please?
I'm finishing that. Only with reflections. I can.
Yes, because you finish your time. So please move to the conclusion, please. Okay.
Okay, this is the conclusion.
Thank you.
Thank you. Sorry. And I'm going to conclude with that the water infrastructure heritage should be considered as climate change observatory and source of resilience. And I would like to emphasize on the notion and definition of sustainability, because the decision making in India is more still refer to profit-oriented tourism destination management models with tendency to guard traditional interpretation of sustainability. So we should consider an appropriate equitable balance among conservation, sustainability and development. But this is not the point. This is the point that we are dealing with in long time, and at a global level, the insufficient recognition of these systemic synergies calls for critically thinking about the already theorized sustainability principle. And I would like to finish with that critical point that I developed and mentioned in my PhD dissertation regarding the definition of sustainability, considering the cultural heritage as a system, and that such sustainability should deal with the dynamic process in which the system co-evolve, regenerate, and self-perpetuate toward local resilience. This is the main important point that we should consider in conservation and valorization of cultural heritage.
Thank you. Thank
you. That is. I try to finish as much as possible.
Yes, sorry, but all of you has 10 minutes, so it is important to take the time for the others. So we have no time for question. We can move to the next one.
So, George Alexandrakis for environmental and socioeconomic pressures and cultural heritage degradation, evidence from Elunda, Crete Island.
Hi to everybody. I'm George Alexandrakis. I'm from the Foundation of Research and Technology Hellas. I'm from the Coastal Research Laboratory of Forth, and I'm going to present you some work that we have done, which is not cultural heritage related, which is environmental related. We tried to do an integrated coastal zone management plant in a closed bay in Greece, in Crete. But we found some interesting things that are cultural heritage related. We know that apart their cultural value, cultural heritage areas are also sensitive and also produce revenues for the tourist industry. But also they have stressors that come from climate change and man-made activities. In our work, we try to make an integrated coastal zone management plan for the Bay of Elunda, which is in northeast Crete, which is a closed bay which had cultural heritage sites through the Minoan era until today. What we did, the first things that we try to do is analyze the coastal zone. To do this, we split the whole bay in 5 areas. One is the Elunda, the Spinaloga Island here, and the other 2 are in the west part of the coastal zone. The other area, the peninsula, the Kolokitha Peninsula, it's all protected by law as a cultural heritage site. What we tried to do is to analyze the coastal changes in this bay. So we took, the first thing we did is take satellite images and see how the coast was evolving. We also we used topographic maps and other regulative frameworks and legislative works in order to build a coastal imaging plan, integrated coastal zone plan. But what we found is that the coastal heritage area was also under tremendous pressures in this area. So we try to quantify the urban expansion using the aerial images and the satellite images. Also, we try to see how the coastal works in terms of protection or building marinas or seawalls or other things change the environment, and try to categorize the coastal zone in terms of loss when we have a natural erosion, gain when we have accretion, or artificial gain when we have man-made human constructions that aggregate the coastal area. The first thing that we try to do is see how the environment is in the area. So we do the geomorphological survey and see how is the coastal zone in order to interpret the changes, and also land uses. And we found that it's mainly agricultural and grasslands. It's highly touristic. It's one of the most expensive areas for tourism in Greece. It has 2 main settlements, the Plaka and the Elunda, which is under the land use maps are not connected, and there are some scattered houses all over the area. We don't have industries or forests. And about transport, we have only one road that connects the rest part of the south part with the north, and is the only road that supports all the villages that are in the north. And this work is actually built on the coastline. And also there is some small tourist ports and marinas that was built later. The first thing we did when we tried to analyze it from the aspects of marine scientists is that we see that there is a significant change in land uses the past 77 years. That starting during the 60s where tourism started in the area. And now the cultural heritage area in these sites are mostly covered with constructions here and in the green spot in the south. The only thing that remains protected is the Kolekitha Peninsula, which is under strict regulations. By breaking down the sites, the five areas, we see that for the Spilalonga Islet, which is also under protection, we have no further development of constructions. But for the other area, we have large changes in urban sprawl. This continues to further to the south in the area of Chifliki, where is the area 2, and we see now that the two parts of the two settlements that was on the land cover maps and the land use maps are now connected with continuous urban fabric. Also, we see that each of area has many changes in the coastal zone that also affect the underwater protected cultural heritage area. I forgot to say that the bay is not only protected inlands, but all the bay is characterized as underwater cultural heritage area, and in the middle of the bay there is a Roman road that connects two spots. In the south there is a Roman fortress. And this is the first settlement. We see that now that most of the part of the area is now covered with settlements and new constructions, mainly related to tourism. And the only part that still remains untouched is the area south, where the regulations are more strict. Another interesting part is that as the urban fabric grows, also land loss in the coastal zone increases. And also as tourism constructions, hotels and so on increases, also the need of more coastal works increases, and the more land loss occurs, which also threatens the cultural heritage area. Now, just conclusions, we see that the area has significant changes, and also coastal constructions and facilities inland introduce additional pressure to the cultural heritage landscape. It completely changed most of the aesthetic of the area, and also limits its space. This limiting in space also creates another problem, which is it cuts off the sediment growth to the coastal zone. It also affects the underwater part. So it's a chain of events that needs to be addressed. We see under the integrated coastal zone management that we have to make some intervention more to minimize some intervention, to have more restricted intervention in the whole area, not only the coastal zone. And now it's proposed to start building some nature-based solutions in order to tackle the whole erosion and cultural heritage system. The other thing that came up is that through the degradation of the environment and the degradation of the cultural heritage also comes degradation in the profits that the tourism makes in the area. And so there is a problem that creates chain events that has some results that can be severe in the future. And the most and another thing that we discovered is that now when during the 60s and the 90s, where the development started, the area was treated as a rural area. But now it's more or less, and especially in the summer, it's more or less under an urban environment. So pressures in the coastal, in the heritage sites change from the natural ones to more anthropogenic, and not in the long circle of time, but during a year. This is it for the first one.
Thank you. Is there any question?
Just out of curiosity, why in such active shorelines the local authorities allows for submerged structures? Because it is for sure that there is a risk, an environmental risk also for the structures.
The first thing is that for Crete, it's not so active. It's a protected bay with a limited wave energy. The wave height does not reach over 1 meter. So it's very, very, very low for the area of Crete. The other thing is that when the build-up of the area started during the 90s, 60s and the 90s, the regulation was not so strict. Everybody was building everywhere without any limitations. There are not so many submerged structures in the area, but are structures in the coastline where the water touches the land. And this creates a chain of events on the underwater part and the inland part. So now this, the last decade structures have all of them, since we monitor the area, they have some mitigation actions to protect the coastline and not have this phenomena. New hotels there are trying to build their permanent structures a few meters above the coastline, not touch the coastline. That was the perspective of past decades. So something's changing, but not so much.
Thank you. So we move to the next presentation, but with the same presenter. And the next presentation is analysis between cultural heritage, human settlements, and landscapes using earth preservation and archaeological data.
Okay. This work is part of a research, a national research program that we are involved, along with NTUA and several other partners that are present here. We're trying to see how the environment affects cultural heritage area in general. So our first thing is to try to build a large data set with all environmental, archaeological, societal data for the areas under investigation. And on this, those data in this also include some socioeconomic variables like land uses, economic activities, and so on. And we try to see how all of these affect each other and which influence what. For this presentation, we are going to show you some preliminary results in 4 small islands of the Lecanese island chain, Simi, Halki, Kassos, and Castellorizo, which all of them have significant archaeological sites. And they are constantly living space throughout the time, so there is many changes. The methodology is we are trying to add in a geographical information system every detail that we have in spatial form, or to create spatial form in some parts, and then use some indexes in order to link them together and categorize the whole thing and see how these factors interact with each other. I believe some similar work trying to be by the previous presentation by Mr. Dimou. It's a general philosophy, but in a smaller scale. After we take all the data necessary, we change geology and we create landform maps, slope maps, aspect maps, lithology, and drainage density, which is mainly the river network in its area. Also, to apply a natural factors forcing index, which includes structural stability. We took the geology and took some the geotechnical attributes of the formations and tried to categorize them. Vegetation cover. We tried to analyze from soil erosivity. We took some data for soil thicknesses when they were available. Some landslides, which is not so active in these areas, and land cover, and also some socioeconomic attributes like settlements expansion, transport network, land uses, cultural heritage areas, and economic activities. All of these attributes, we try to rank them, categorize them in a scale 1 to 5 that contribute to the most important from the less important to the most important. Each one was given by a certain value or categorized by, and this ranking was made for each factor based on bibliographical research. The same applied for all sub-indexes, and we use this formula to link everything together, which is the mean square arithmetic mean. This is the three indexes. In order to apply this, we apply it in a spatial way, where we build maps for each variable. This is 5 variables that I'm showing just to see how they look. And we see that all lines have a common factor, that density, settlements, and transport are very low, because they have they're not so expand. They don't have an expanded river network, or the settlements are small. And the aspect value and the slope value have similar distribution in all areas because of their terrain and elevation. We analyze each factor that was shown in the tables before, and we create a map for each area, meaning that there is 12 maps for each area, and then it was integrated with this mean. And we rank all the values from the 1 to 5 and have this kind of distribution. This is the percentage of coverage in terms of square kilometers for each area. Similar maps for each area. And then we calculate the 3 sub-indexes, and we present it for special locations that have cultural heritage importance. This is monasteries, some caves that are linked with religion, ancient ruins, and so on. And we did this ternary diagram, which shows which the area, which factor affects most of the specific site. We see that in these 4 small areas, the natural forcing and geological characteristics are dominating the overall results, and the socioeconomic variables are not so, do not have such influence due to their less human occupied. As a general result, we see that this approach can give us a base for initiative research on these areas. We're trying to apply this in larger areas, regions, or even larger. We see that in these 4 areas, the socioeconomic index has the least influence due to that are not so occupied and less developed. And the archaeological sites are threatened mainly by natural and geological factors. This also, to link with the previous panel discussion, this can be such analysis can drive the perspective of maintenance or restoration or some solutions in order to preserve the heritage areas. The slope factor in all areas was very high due to the mountains terrain. And we see also that even though in these 4 areas the socioeconomic index not so influential in the Rovelar case, we have to include it as well in order to have results. As I said, this is some preliminary method, and we try to correlate and improve the whole approach, and we're trying to apply the same methodology in more complicated and larger areas. Thanks a lot.
So, thank you. Are there any questions? Yes, please.
Hello. Yeah. I was wondering, like you said, the socio-economic factor are the least indexed because they're like near the rocky area and there's no human settlement. Like there's so it's also like you mean like the connection with the community, the local community, and the archaeological sites that you mean. Okay, thank you.
So, thank you. And the last presentation, Determining Rockfall Hazard and Risk in Historical Sites by Olga Mavruli.
Now it's okay. Okay, good afternoon. I am Olga Mavruli from the University of West Attica, and the topic of my presentation is the determination of rockfall hazard and risk in historical sites. So just to begin, I would like to mention that rockfalls consist a significant fraction of landslides worldwide, affecting important historical monuments, historical sites and monuments such as Petra in Jordan or Machu Picchu in Peru. And although they act locally in comparison with earthquakes, they are ubiquitous, so their consequences remain often underestimated, as the results, the impacts are attributed to the triggers, earthquakes or extreme rainfalls usually, instead of the rockfalls themselves. There are different types of impacts of the rockfalls, extending from direct damage to monuments and historical structures, to risk for the visitors, or to blockage of road access to cultural heritage sites. And of course, all these have their subsequent indirect socio-economical loss. Here I provide a framework for the quantification of the rockfall risk assessment. So if we want to quantify, to present the risk in quantitative terms, we might present it in financial terms, as for example in euro per year, loss per year. And we use this type of equations here, okay? This type of equations here, I got it, where we have the risk expressed in euro per year as the sum for all the blocks of an expected magnitude detaching from the slope face, and all the blocks of a given kinetic energy reaching an exposed element, in this case a Romanic church in the Pyrenees in Spain, of the product of the probability of a rock block of a given magnitude detaching from the slope face, multiplied by the probability of this rock reaching the exposed element with a given kinetic energy which is sufficient enough to cause damage to the building, multiplied by the vulnerability of the building for this specific rock magnitude and energy and the resultant cost. So that could be a way to quantify the risk, but of course for monuments we all know that the risk extends far beyond economical losses due to their cultural value. So this type of expressions can be alternative used to reach other quantitative risk indicators, as for example the expected loss or fatalities within a touristic site within a given time frame. That would be 5 years, 10 years, 50 or hundreds of years. And such quantitative tools are important for us because they offer objective and comparable assessments that help us to prioritize intervention measures and to assess in an objective manner their efficiency. And of course, they help us to evaluate the risk, and specifically the residual, because there is always a residual risk after the application of protection measures, and to check whether this residual risk is unacceptable or acceptable or tolerable in the in-between. So I will move now to the case study. I think there was a presentation as well in the morning. The well-known archaeological site of Delphi, which hosts the most famous oracle of ancient Greece. It was regarded to be the cultural and religious center of the world in the antiquity. And here we see A, B, C, G, D, E, some of the most important archaeological monuments within the archaeological site. And the problem of rockfalls was known in the area since ancient times. Actually, in 480 before Christ, Herodotus mentioned that during the Persian invasion in Greece, rockfalls crushed the Persians, leaving the monuments intact, which also provides us an indication about the magnitude of the event at that time. Here I have included indicatively 3 more events of rockfalls, either earthquake-induced or rainfall-induced, the last one in the 20th century. And the last indicative event would be, it cannot be seen here, it's from September 2009, when after a heavy rainfall, a rock was detached from the Phedriades slope here, and after fragmenting in 2 blocks, it landed without causing any damage to the monuments. The rock was of the size of a human head. There have been some studies in the area on the topic of rockfalls. Marinos and Rodoianni, they studied in detail the geological forms in the area and more geological phenomena in the area. And actually, besides rockfall, there are other types of ground movements as well. And later on, in 2010, Christaras and Vouvalidis, they analyzed the expected energy, kinetic energy, of blocks of 20 tons along 3 critical sections in the left part, in the west part of the archaeological site. And as far as I know, there are several ongoing studies and works, protection works, for the installation of protection measures managed by administration authorities. So the objectives of this work have been to present a methodology for assessing the expected rock block kinematics for events of which the source, we do not know exactly the source of detachment of the rock block on the cliff, around the entire historical site, not only on the west or east part, but around the entire historical site, for different block sizes, as we do not know the volume that we can expect, and in the presence or absence of protection measures. And to this purpose, we used the software Rocky4 3D, developed by Doren and Berset, which performs a 2.5-dimensional geographical information system-based analysis using as an input a digital elevation model with 2.5 coordinates X, Y, and Z coordinates. And using this digital elevation model, we calculate the block energy at every cell of the raster based on energy balance assumptions, considering different types of movements like free fall or rolling or bouncing of the blocks, and also the energy dissipation is calculated at each cell, considering obstacles or the capacity of soil to dissipate energy. And going back, obstacles that are considered might be big rock blocks or tree stems that decelerate the falling rocks. The input data have been a digital elevation model. The potential rockfall sources can be seen here with red lines. We considered 2 different altitudes, and then we also consider, I don't know if we can take this off, we considered 2 groups of volume. Volumes 1 are the smaller volumes. We considered a range for the probabilistic analysis, and they correspond to the volume of the events like the one of September 2009, which have a return period of a few years or few tenths of years. And the second block size has been larger with a return period of hundreds or even thousands years. And here we see the results. I'll go back, I'm sorry. Okay, back. Here we see the results for the smaller blocks. Most of the monuments are not reached, but for the bigger blocks there is a probability of reaching them, which is reduced with the protection of the monuments. Yeah, we suggest steel fences with a green line. So concluding, we consider 4 steps for the protection of monuments from rockfalls, assessing the susceptibility. And to do that, we have digital elevation models that help us to calculate the volumes. Monitoring, it's important to coordinate efforts for assessing and registering the frequency and magnitude of events for the risk assessment, so as to study also the response to rainfalls, the quantitative risk assessment, and using this method we can also evaluate the efficiency of sustainable measures like embankments or ditches. That's it. Thank you very much for your attention.
Thank you. We have time for one short question. Okay. So we are... Is there? Oh.
Thank you for your presentation. I was wondering, is your current, I don't know, like systematic mapping of risk of landslides in combination with Greek archaeological sites? Like, has there been systematic mapping or research?
Oh, if this is my research line, you mean?
Yeah, or like in general, like in your research field.
I work on landslides, landslide risk, and specifically rockfall risk, but also generally landslides risk, not only for cultural heritage, but for other elements at risk as well. So cultural heritage is just a part of it. No, we work on landslides generally. Yeah, thank you very much.
So we thank you all the speakers and the audience. We are arrived at the end of this session. So
nothing to say more. So thank you to everyone. Perfect in time, as you request. Perfect in time.
This panel discussion, which is for the resilience of cultural heritage, mitigating climate change, natural hazards, and pandemic risks, and ensuring biosafety. we will have a small change in the program, so I kindly ask Professor Phoebe Kuduri to start with her presentation, and I will also ask the audience if there are questions to Mrs. Kuduri, because she has to leave earlier, to be asked just after her presentation. After that presentation, we will have all presentations and an open discussion at the end of the session in order to save time. So, Mrs. Kuduri.
Thank you so much. This is not my presentation, so if anybody is listening, they can find the one that says Kunduri and click on it. Thank you very much, and thank you for giving me...
Βρείτε τη κυρία Κunduri, τελευταία, βάλτε την πρώτη.
Γράφει κουντούρι, άρα αν πατήσετε το κουντούρι θα είναι αυτή. Thank you very much for having me here. It's always a pleasure to be part of this event, and I'm really sorry that I didn't realize that the session was moved. And I have to leave early, unfortunately. So very quickly, I want to tell you what we are doing at the Alliance of Excellence for Research and Innovation that I lead. This is an alliance of various universities, research centers, and accelerators working on the sustainability transition, working with a very interdisciplinary team of 200 people on various projects on identifying transition pathways for reaching the 17th Sustainable Development Goal. Our motto is that we want to move away from the current multi-crisis, the pandemic that is still on, the economic recession and inflationary pressures, the climate crisis, the biodiversity collapse, the geopolitical crisis, and move towards the implementation of the Sustainable Development Goals. As I told you before, we try to do this in the cluster of research institutions, 5 different research institutions, 5 different accelerators of innovation, technological innovation, social innovation, and financial innovation, and at the same time working with international and multilateral institutions where we have a leading position. At the moment, as I said before, we are 200 researchers working on at least 100 competitively funded projects from ERC, Horizon Europe, Interreg, and other World Bank, OECD, and other multilateral organization projects. Our focus areas are climate change mitigation and adaptation, sustainable ocean management, ocean and seas, sustainable management of water, food, energy nexus, and biodiversity, innovation acceleration and incubation acceleration towards the market so that we can achieve massive deployment of sustainability solutions in order to actually reach a stage that we can say that we are implementing the SDGs, and of course financial solutions for supporting ESG implementation. In all areas that we work, cultural heritage is very important. Cultural heritage is affected by climate change. Cultural heritage can be found in the seas and needs to be preserved and protected. Cultural heritage is affected by the sustainability of the water, food, and nexus. Cultural heritage needs innovation, technological and financial innovation in order to be able to sustain itself, and of course it's part of the SDG framework. The important thing is to measure, is to be able to quantify.
We need to quantify where we are in terms of the 17 goals, the 169 targets within the goals, and we do that every year as the Sustainable Development Solutions Network, both across all countries of the world, but also in a very detailed report in Europe that I co-author. We measure with 250 KPIs the achievement of each 169 targets within the SDGs per country. This is important because we quantify where we are and we can measure the gap towards where we want to go. And I will go fast and say explicitly that cultural heritage is not really dealt in a specific SDG, but it is touched upon in 3 SDGs, the SDG on education, and in particular target 4.7, when it refers to the need of education to appreciate cultural diversity. In SDG 11, that is focused on sustainable cities and communities, we have target 11.4, where explicitly we have a statement on the need to strengthen effort to protect and safeguard world's cultural and natural heritage. And then in SDG 12, which is about the responsible consumption production, and SDG 8, which is about decent work and economic growth, we have reference to cultural heritage as a robust background for touristic development. What we try to do, as I told you before, in our very interdisciplinary team, in my very interdisciplinary team, is to try to understand cultural heritage in terms of how much people are willing to appreciate it, how much they value it, how much they are willing to pay to preserve, conserve it, and protect it from various hazards. And one hazard that we work a lot on is climate change. And to the question, to the possible question, why should I measure the risk? Why should I monetize the risk and benefits of climate change on natural heritage? Because in any project, public or private, or public-private partnerships, you need to go through a cost-benefit analysis and prove the priority of the project. So if you really want to invest public and private money in preserving and conserving cultural heritage, because it is important, because people care about it, because people value it, you need to first quantify the benefits and compare them against the cost of the conservation or preservation activities. And in economics, we say that there are different components in value, and these components become explicit in terms of the capital and the scarcity of the capital we use in order to produce different goods and services. And we all know the capital, the man-made capital that we use for production. We call it produce capital. We know the natural capital from nature given as an endowment for us. We know the human capital that we develop through education, upskilling, and reskilling, but there is also the social capital and the cultural capital. And we need to explicitly monetize the value of these different versions of capital and use them in the production function of the various goods and services that we produce and consume. In order to allocate optimally this different capital, we need to value them. And in order to value them, we have to identify the different components. For example, cultural heritage includes tangible cultural heritage divided into movable and immovable heritage, and also intangible cultural heritage. And we have developed over the last 50 years various techniques, I will not go into that, which are a combination of economics, statistics, econometrics, and cognitive psychology in order to retrieve, to extract, to reveal these hidden values from people's preferences. And once we do that, we are able to monetize these values and include them in cost-benefit analysis in order to support intervention projects for the conservation of cultural heritage. We did such an analysis for the whole of Europe, different cultural heritage sites across Europe. We are now involved in a project that tries to do that around the globe, and the idea is to do meta-analysis of various different individual studies that work with methodologies that allow you, these interdisciplinary methodologies that I showed before, that allows you to retrieve and I'm finishing, to retrieve the individual values for cultural heritage monuments across the world. And I just show you just a glimpse of some results which allow us to estimate the willingness to pay for cultural services in Europe, this difference between the different monuments and between the different countries, but on average there is an explicit willingness to pay of more than 46 euros per person per year, per person in Europe per year. So you have to multiply by the millions that live in Europe in terms of conserving and preserving cultural heritage. And of course, there is a difference in intensity in the willingness to pay for aesthetic values, of the authenticity values, existence, social and symbolic values, but this is just a sketch just to convey the message that this very important culturally heritage can also be translated into monetized values and explicitly enter a cost-benefit analysis over time and space. And when we are dealing with time, there are also issues of discount rates and how long-run discount rates need to be a declining function of time if you are dealing with projects that have long-run characteristics. And I will just close by saying that the report will come out jointly with the Academy of Athens, and it tries to capture these values of climate change effects on cultural heritage across the globe. And it is also under the auspices of the Sustainable Development Solutions Network Global Climate Hub that I chair, which is trying to develop climate neutrality and climate resilience pathways for the different nations across the world. And in this development, cultural heritage is one of the variables we take into account. I close with the 9 different units of the Global Climate Hub. I will not go into them. I will just say that in order to do holistic, in order to develop holistic, dynamic decarbonization and climate resilience pathways, you really need to bring all the disciplines together. The data information technology scientists, the atmospheric physics, climate and energy, climate and land use, climate and health, innovation, acceleration, financial economic issues, transformative living labs in order to co-design with the stakeholders. And of course, you have to reskill and upskill and educate with all the elements of this very challenging transition effort. Thank you very much for your patience.
Thank you, Ms. Koudouri. Are there questions that the audience would like? Yes, Professor Marinos Ioannidis.
Congratulations for your presentation. If I may ask you, do you take into account in your estimations tourism, the cultural tourism?
Cultural tourism is one of the easy parts of this valuation because it has an explicit market. So if you have an explicit market, you have prices, or at least you have the time and the cost of the travel of different people. So the studies that take that into account are mostly travel cost studies, and they try to capture the value people assign to different cultural heritage sites using the information on the cost spent and the time spent from these travels. However, there are other aspects of natural heritage where the demand is more implicit, which becomes more challenging to retrieve. But this is one big element of the work.
But in your calculations, you don't take into account the impact of the cultural tourism to the sites.
We do take that into account. We do. I'm just saying that this is one of the easy parts to take into account because there is a full market around this concept. Thank you.
Thank you.
Are there other questions? There is one question.
And how do you quantify the implicit parts? For example, like the spiritual values or like...
Yeah, for that you need to go either through questionnaires or choice cards. So you show the sample of, you choose a representative sample of the population you want to deal with, and then you face this sample, these agents, these people, with a simulated reality of the possible changes. Nowadays, we don't do questionnaires anymore, we don't show photos anymore, we bring the people in the lab and do virtual reality of possible changes, and we try to extract their responses to these possible changes in order to retrieve their preference map and translate that into willingness to pay for the changes, to avoid the changes or to produce the changes. If it's a negative change, you want the willingness to pay to avoid the change. If it's a positive one, the willingness to pay to produce the change, to conserve, for example, to preserve. And it's a very fast-growing area of economics. This one is called experimental behavioral economic. Is one of the fields that my work focuses. Thank you so much.
Thank you, Mrs. Koudouri.
Thank you so much. I really apologize.
No, it's okay. Now we are back to the program as it was scheduled. So I would like once more to thank all. I'm Betty Haralabopoulou. I'm the CEO to Geosystems Hellas, and now I will act as a moderator with Professor Ioannidis at this session. As add-on to, we need the presentation. We need the first presentation if it's possible. As add-on to my position in Geosystems Hellas, I am the exploitation manager of the Triketra project, which is a project that was inspired because of the climate change and the effects of the climate change on cultural heritage monuments. It's a project that NTUA is coordinating, and a lot of partners in Europe are participating at this project. So I think that next slide, please. I don't know if it runs automatically. Okay, done. So a lot of partners in Europe are participating in the project. The partners are from different academia in Greece, in Cyprus, in Italy. We are happy having with us several of them, like the Eratosthenes Center, the University of Thessaloniki, AUTH, as add-on to the National Technical University of Athens. We do have a Sapienza University, which at the moment is online. We do have DLR as a major institute working on remote sensing and preservation of cultural heritage. But also we have partners from Switzerland and from Germany, from the archaeological side. We do have also the Deutsche Archaeological Institute, the Greek Ministry of Culture and Sports. We do have a partner from the Ministry of Culture in the Bavaria region. Also the Ministry of Culture in Poland under a preservation non-profit organization, and of course we do have the same entity from Switzerland, CSEM, as add-on to a bunch of commercial and technological companies that gave to this project a grade under Horizon Europe 15 to 15, which is a great honor for all the team involved. I would like to say that the, let's say, vision came under this specific goal that has to do with the wish of Europe of contributing in the monitoring and the preservation of cultural heritage and using methods against the impact of climate change to several monuments. That the monuments can be on in the land or underwater or in lakes. So in all 6 entities under cultural heritage ministries have defined their priorities. Most of the sites are UNESCO sites, and just to give a view on that, because in the next session there will be detailed, very detailed presentations. So what I want to say in 3 words is that what is needed is to measure the effect of the climate change, to find sustainable ways to protect the monuments, and to raise awareness of the public, of the citizens, with active involvement in order to have results that are sustainable also to the next generations. And as you have also heard from Fivi Kuduri, this is part of the sustainable goals, but also is part of the new European Bauhaus, because the new European Bauhaus focuses in cities, in European cities, which most of the city center are cultural heritage centers, and very close to the urban environment there is a cultural heritage monument. The Triquetra project, as a nutshell, as the word of Triquetra approach is saying, is a framework of risk assessment and risk mitigation, and tackles in the 3 risks that it is defined as risk identification, and risk mitigation. So with this Triquetra, we will try to use any kind of methodologies that are technological methodologies, remote sensing, in situ sensing, and digital twin, in order to move forward. This is a table of the pilot sites and the risks. I'm not going to go through them because more detailed presentations will come. And as you see here, the contribution of the technologies that will be applied in all sites is extremely at the point, are all at the state of the art. And like that, in the Triquetra approach, the task is to move in a DSS that will facilitate all authorities involved, because we have 6 authorities, 6 cultural heritage authorities from 6 different European countries. Thank you, and I give the floor to Professor Ioannidis, who is the project manager of the Triquetra project. I would like also to say that a bunch of very, let's say, sophisticated and powerful advisory board is helping. Professor Moropoulou is part of the team, and we also are grateful to have her with us. Professor Ioannidis.
Okay, thank you. Hello, everybody. My name is Charalambos Ioannidis, and I'm professor of photogrammetry at the National Technical University of Athens, the School of Rural Surveying and Geoinformatics Engineering. First of all, I want to congratulate the organizer of this event, Professor Moropoulou, who has successfully managed to invite and bring together a large number of international and local experts to share their experience and give us information about the recent activity in the field. And the subject of this panel discussion is closely related to the theme of the Triquetra project, a Horizon funded project which I coordinate. And let me introduce very briefly the Triquetra project to you. Please, the next presentation, please. Yes, I think this one, yes. Okay, thank you. And if you want to... thank you. Okay, it's okay, thank you. Well, our mandate, the goal of this project is to create a toolbox for assessing and mitigating climate change risks and natural hazard threatening cultural heritage. The duration is 36 months. The projects have started at the beginning of this year, and the end of the project will be at the end of 2025 with 21 partners from 7 European countries. Further, yes, Triquetra project aims at creating an evidence-based assessment platform that allows precise risk stratification and a database of available mitigation measures and strategies, altogether acting as a decision support tool towards efficient risk mitigation and site remediation. And it is based on 3 major pillars: identification, quantification, and mitigation of the risks coming from climate change and natural hazards. Actually, this approach has defined the name of the project as well, Triquetra. Let me briefly explain to you the suggested subject of the decision support system and the knowledge-based platform, which will enable stakeholders and decision makers to make the most appropriate choices concerning risk mitigation and remediation of cultural heritage sites. The first pillar is the risk identification. To identify the risks of each cultural heritage site, we need to create a cultural knowledge base which will contain all specific geospatial data about particular cultural heritage sites, data relevant to the climate and geology, and also on-site survey data, and data derived both by in situ and remote sensing methods. Once we identify the risks, we proceed with the quantification of the severity of these risks. This second phase of the project includes an assessment of the site type specifics, such as materials, age, and so on, and the local geological and climate conditions that will enable us to conduct a multi-impact analysis. The third pillar is the suggestion of the mitigation measures to proceed with an assessment, optimization, prioritization, and finally suggestion of the decision about the most appropriate mitigation measures for each cultural heritage site. We may derive information from the knowledge base about past experience in applied mitigation measures, as well as information about innovative approaches. By monitoring and measuring the results of the applied measures, there will be a continuous feedback to the knowledge base that will increase the value of the tool. Now, a few words about the key research activities of the project. These activities include the assessment of the precision of flash LiDAR technology for 3D mapping of underwater cultural heritage sites and the validation of its applicability for erosion monitoring, the development of a novel spectroscopic sensor for water quality monitoring, the improvement of the accuracy of climate models and correlation to cultural heritage risks, the development of models on risk quantification stemming from water, ice, extreme events, models for calculating geohazard risks based on in situ data for archaeological sites, models on structural damage risks, for example, earthquakes on archaeological sites, the assessment of chemical and biological hazards on cultural heritage sites based on in situ assessing, the assessment of chemical and biological hazards on cultural heritage sites based on in situ assessing, the provision of novel techniques for application of remote sensing on archaeological sites, and of course, finally, the development of the platform that allows multi-hazard impact assessment. The research includes pilot applications for 8 different cultural heritage sites across Europe, 1 in Germany, 3 in Greece, 1 in Poland, 1 in Switzerland, 1 in Cyprus, and 1 in Poland. Here you can see some basic information about these pilot sites. The sites located either mainland, like this one in Kalapodi area in central Greece, or in the coastal zone, like this one in island of Ventotene in Italy, or some of them underwater, like this one in Epidaurus area in Greece, or this one in Germany, and this one in Switzerland. All these sites face a variety of hazards, like biological, chemical, or atmospheric hazards, or wave erosion or also floods, sea level rise, and so on. You can see here also the technologies that will be used for each one of these pilot applications in order to produce a digital twin using Earth observation methods, photogrammetry, and so on. And if I have 2 more minutes, no?
Yes,
in
but
order to
it's better to
describe
conclude because the work packages, I think it's too technical.
Yes, it's too technical. I want also to say that there are 8 work packages: the project management, the cultural heritage site risk identification, and the production of knowledge base. The third work package is about the development of novel sensing and mitigation schemes. The fourth about the cultural heritage site risk assessment and quantification and the production of models. The fifth about the development of the decision support system. The sixth about the pilot applications. The seventh about the communication, dissemination, training, and exploitation of the results. And of course, the final package is about the ethics requirements. And that's all. Thank you.
Thank you, Professor Ioannidis. I would suggest that if there are questions, etc., to be discussed at the end. So I give the floor to Mr. Alexandrakis from Fourth.
Hello. Hello, I'm George Alexandrakis from the Foundation of Research and Technology, ELAS. I'm a member of the Coastal and Marine Research Laboratory there. And since I had 2 presentations in the previous session, I did not prepare the one for the panel. But in general, firstly, I would like to congratulate the Truquerta Consortium for getting this grant, because from what I saw, since I follow the project from its beginning as an observer, I saw that it's very interesting. It has a very novel approach. What I would like to say is that what indicated in my 2 previous presentations, that not only the cultural heritage risks and man-made, human-made threats or all this, now we have the technologies to build the digital twins in order to have a more accurate predictions and to see a more holistic approach in all those things. But we have to consider all the changes and all the factors and how these changes, not only through the large period of times, but even in smaller periods of times, meaning inside the same year. In one of my presentations earlier, I showed that we have a bay in Crete that has different influences during the winter, which is not visited by people, and has a very different behavior during the summertime, where the human pressure is larger. And also about the underwater heritage sites, they was, until recently, they were more or less protected from the human factor in terms of they were not visitable. Now archaeological tourism and diving tourism is growing, so this will add more pressures in underwater sites. So we have also to consider how to measure these pressures, not only inland, but also underwater now. So this is something that the Truquerta project, I saw that has something in its mind to do. That's for me from this as a starting point, more on the discussion. Thank you a lot.
Thank you, Mr. Alexandrakis. And next, I would like to ask Mr. Alexopoulos, General Alexopoulos, to give us his input.
And I would like to develop a technocratical point of view about this subject, according to my specialization to building strong national resilience building systems, both in NATO and EU. The character and severity of impacts from climate extremes depend not only on the extremes themselves, but also on explosion and vulnerability. More often, we remark disasters with widespread damage and severe effects in the normal functioning of our communities. Weather and climate extremes, exposure and vulnerability are influenced by a wide range of factors, including anthropogenic climate change, natural climate variability, and socioeconomic development. What it needs is a disaster risk management and adaptation to climate change, focus on reducing exposure, vulnerability, and increasing resilience to the potential and risk impacts of climate extremes. Where vulnerability is high and adaptive capacity low, changes in climate extremes enforce transformational changes. Transformations will provoke alteration of fundamental attributes of civil emergency systems and will be facilitated with adaptive management, innovative technology, efficient governance, value systems, and building strong resilient systems. Building strong resilient systems will facilitate basic with 5 main principles. First of all is build the resilience foundation with rapid and inclusive development. A resilient strategy could be successful if financial, technical, and institutional resources cover the 3 resilience capacities: resistance, recovery, and adaptation. Second, to inform, prepare, and train people. To revise urban and land use plans and protection of critical infrastructure. States must protect public investments, assets, services, communications, power, water, energy installations, communication, transport, infrastructure, and protection of critical infrastructure. Help people and firms recover faster and better with organization of effective decision-making mechanism, early warning, situation awareness, crisis management mechanism, train civil military assistance humanitarian units that are able to give solutions and recover faster and better. And the last one is to manage impacts at the macro level, civil emergency planning according to our needs, and first of all, with existing available resources and capabilities. Biosafety is the principles and technologies and practices applied to prevent accidental exposure to pathogens and toxins. Biosecurity is a protection against malicious use of biological agents or critical relevant information to prevent unauthorized access, loss, theft, abuse, diversion, or deliberate release. The cyber biosecurity is key part of national security strategy, and its main purpose is to investigate the ever-increasing interdependence of cyberspace with biosecurity. It requires a new kind of resilient system building with the following: secure use of cyberspace as a source of information, effective implement of biosafety policies, and protection of digital governmental medical data. Introduction of innovative cyber technologies and warning reporting system, such as artificial intelligence, to predict biological risks and rapid response to the economic, political, and social pressures of a health crisis. Lesson learned from COVID-19 pandemic promote the digitalization of economic, social, and political activities, but also enforce the groundwork for new approaches and practices in biosecurity as part of national security. Climate change will likely increase frequency and strength of extreme events such as floods, droughts, wildfires, and storms. It will affect in any occasion health budgets, disruption of social care and physical, mental and community health. Climate-CH affect deaths, injury, air quality, extreme weather events, water quality, drought, food safety, and nutrition. Our work, actions, infrastructure planning, and long-term roles will need to integrate climate-CH science, new technology, and new planning. About the resilience ability to deal with mass casualties from climate-CH, a strategy is needed which will incorporate improved urban planning, update building codes, reduction of greenhouse gas emissions, increased funding for public health emergency systems, educating trained communities on the risk of climate-CH to health and ways to stay safe and secure with early warning system for disaster events, cross-sector collaboration, resilient healthcare, and public health system. About the health sector resilience, it will be robust with the following: capture community and health system vulnerabilities and long adaptation gaps, enhance the resilience of health system and communities to climate change effects, build on existing networks and plans to develop a national plan to cover all relevant emergency and rapid response services, and the environmental protection enforced with a coordinated federal health system, greenhouse gas accounting and reduction target to decrease carbon footprint. Partnership with private health sector will develop an action plan for reduction via technical assistance, policy guidance, research, toolkits, training, and use of regulatory authorities as needed. Closing. Social, economic, and environmental sustainability can be enhanced by disaster risk management, adaptation, and building resilience approaches. A serious target is to build strong national resilience, which requires central planning coordination, risk assessment model, and a broad participation, a comprehensive approach with all the civil military actors. Actions are framed by trade-offs between competing prioritizing values and objectives and different visions of development that can change over time. Therefore, all ministries, public agencies, security agencies, and crucial private actors must coordinate their actions to develop interoperability, sustainability, flexibility, and mainstream the resilience strategy in all their decisions. Generally, it includes planning of alternative ways of providing critical government social services, plans, training exercises, and registration of critical infrastructure that will develop flexible methods to protect them. All the above should be coordinated by a single national authority, and the fragmentation and duplication of effort by bodies working in parallel on their own or related responsibilities should in any cases avoided. Thank you.
Thank you, Mr. Alexopoulos. And now I'm asking Mrs. Anastasia Hasapi from CERT, who is a bioinformatics expert.
I'll explain both. Okay. Good afternoon from me as well. As I was introduced, my name is Anastasia Hasapi, and I am a research scientist at CERT in Thessaloniki, but I am also a vice president for research at the newly developed biotech company called DNA-CH. And I am here with this role, actually, today. So in previous talks, we heard, especially previously when we had all these research projects presented, we heard a lot about biodeterioration of works of art. Just before, biosafety was also mentioned, and I am here to marry those two and talk about our work in identifying the microbiome of art objects and monuments. So DNA-CH has the mission to implement DNA technologies in business operations. Our solutions are complete, modular, and personalized. We start from taking samples to analyzing and interpreting the results. We use for that state-of-art technologies in biotechnology, bioinformatics, and AI. And the core of this operation is strongly scientific. We really encourage interdisciplinary collaborations in order to provide solutions to complex problems. So the main technique behind this effort is called metagenomics, and it's a quite new technique, actually, a quite new technology that has been blooming those past few years. Now, metagenomics is a field of research in most research centers in developed countries. There are companies in US, in Europe, in Asia, and we are proud to say that for now, we are still the first end-to-end company in Europe working with metagenomics. Here is an image of the scientific team behind this effort. And we were established in 2019. Our base is in Thessaloniki, contrary to most companies that are around here in Athens. We are so our analysis in Thessaloniki, but we are building a data center here in Athens as well. The company has participated in a lot of clusters, initiatives. We have all the ISOs that secure the quality of our services, of our provided services, and have already obtained a patent and submitted some more. And our presence in the press is quite prominent. Here I'm just showing you a few examples. We were featured in the Washington Times, in Jerusalem Post, and a lot of national news as well for different projects we uptake. And we were also very proud to be awarded by the Hellenic Development Bank as well as the Life Sciences Review Journal as Company of the Year. And now let's get to the chase, which is our field of research. So our field of applications is quite wide, but today I'm going to focus on art and monuments. The problem with art, as you have heard before as well, in the history of art documentation and preservation, the detection of microbial flora and biodiversity, not just focused detection of some microorganisms, but really the biodiversity of art, has been a completely unknown factor. However, biodegradation in cultural objects is really a big issue, and complex communities of microorganisms, including fungi and bacteria, are responsible for that. So our goal is to apply our techniques to really identify the microbial footprint of art objects and exposed monuments in order to help identify potential dangers and help in the restoration procedure afterwards. And if we take that one step further, it's also to monitor not only the objects themselves, but the surrounding environment as well, for the protection both of the objects but of the visitors as well. So in very few words, our solution, basically we can take samples from any type of sample, from surfaces, from air, from liquids. In our case, what is most relevant is the air and the surfaces. The procedure is non-destructive, so it can be applied in works of art, in monuments and other very delicate surfaces. With one test, we can identify all microorganisms that are present in that sample, so it only requires one test to give you the complete footprint of what is there, without knowing what you're looking for. This is the power of bioinformatics. So, where do we do that? As I mentioned before, this can be performed on works of art to see whether there are biodegradation agents present, in exposed monuments to see whether climate change has burdened them with agents that are deteriorating their state right now. In exposed works of art, we can correlate the presence of microbes with artificial lighting and other environmental conditions of the way they are exposed. And as well, we can monitor the spaces, the museum spaces, gallery spaces, both for the security of the visitors, the workers, and the works of art as well. And here I'm going to show you a few examples of work we have done on the field. The first one is in collaboration with Mrs. Moropoulou here, where we had the honor to be able to explore the microbial footprint of the Holy Sepulchre. And a paper has been published on this work. The second one was the biodeterioration agent detection of the tunnel of Eupalinos. There, it's a very interesting story. So this is I don't know if, I guess most of you know that tunnel, but it was one of the great achievements of Ancienti, because they started a tunnel from two sides and they managed to find in the middle and create the whole tunnel. And it was in perfect condition until it started being visitable from people. And then they started seeing those colorful formations here and there on the tunnel, and they didn't know exactly what that was, and that's why we were called there. And what was found was that actually this artificial lighting that was put in the tunnel in order for visitors to be able to visit it has caused dormant microbes to now flourish and form biofilms. Yes, I'm finishing. So 2 more examples. Okay, one was with the National Gallery of Athens with the microbiome of a painting. And the last one within the archaeological site of the Sphina. Again, there we were exploring some plants and some microbiomes, microbes in the area. And now, in progress, we have a research project with Dr. Papacosta in Egypt, in the excavation site there, where they have opened again a new area they have found, and we are collecting samples to see what we find, to play the CSI of the excavation site. And with that, I leave you, and thank you very much.
Thank you, Ms. Hasapi. Now I give the floor to Professor Salvatore Martino from Sapienza University, who is a partner at the Triquetra project. Salvatore is online, so I assume...
Yes. I go to share my video for the presentation. Please let me know if you see it correctly. Is it okay?
Yes, yes.
Okay, thank you, Betty, and good afternoon to everybody. I'm speaking in the framework of the Triquetra project, and I speak for the Italian team of the project, which includes the Sapienza University and the Italian Ministry of Culture. In this presentation, I want to focus on our experience on natural field laboratories and how we will go to transfer this experience in the demonstrative case of Ventotene Island in the framework of the Triquetra project. In our experience, the natural field lab are natural sites, where we go to measure and to detect effects of natural environmental stressors on processes like, for example, rock falls. Here you can see the main natural lab of the University of Rome Sapienza, the Acuto Field Lab for the study of rock falls. Some instruments are installed on the rock wall, just like stensimeters, seismometers, thermometers, and also instruments for measuring weather conditions. Also, forced experiments are produced on the rock walls, for example, by heating the rock and going to test what happens over the day and in the experiment event. All over here, the sites go through very different thermal conditions, and so it can experience a very high thermal stressor, which is possible to be monitored by high resolution and high technology thermographical techniques, which are able to restitute a 24 hours view, 3D view of the thermal image of the rock. Also, the numerical modeling of the experiments allow us to simulate what it happens in the rock, and especially the propagation of the earth fronts inside the rock, and so the generation of the thermal active layer. All over the years and all over the seasons, we can observe how the strains, so the deformations of the rock, respond to the thermal stress produced by the seasonal and the daily thermal variation. And this allows us also to go toward the provision of rock falls, accumulating everyday displacements because of these thermal stressors. This is the case of some winter storm which caused a very fast drawdown of the temperature, followed by an increasing temperature. After these events, we can monitor and observe rock falls from the wall, and we had the possibility to check what it happens in the rock wall itself. Here you can see the microseismicity that we recorded during the heating phase after the storm occurrence, and how you can see 10 days after this microseismicity crisis, we had the rockfall event itself. Now, we are going to transfer this experience in one of the demonstrating sites of the Triquetra project, which is the island of Ventotene in the archipelago of the Ventotene and Santo Stefano Islands in front of the Gaeta Gulf in the Tyrrhenian Sea. It is a volcanic island where volcanic rocks widely outcrop. The site is very important as it hosts an ancient Roman palace, which was the prison, the golden prison for very famous women, among which the son of August, Julia, but also the daughter of Emperor Caligula, Agrippina, and also the wife of Nero, Octavia. All these women were prisoners here because of political features. So we have a very huge area which includes the Emperor Palace and the zone where are conserved the tanks, the water tanks, which were used by the inhabitants of the palace. Now, the remnants of this palace are very threatened by the vicinity, the proximity to the sea, and in particular due to the wind, due to the sea storms, and due to the high temperature change over the here, they are going to collapse and to be very strongly damaged. Here you can see the effect of the collapse of one of the arch of the entrance of the palace, which occurred after the 1997. And here you can see how the walls, which also host some paintings, original paintings in Pompeian style, are very stressed by the environmental actions and are going towards damaging, very strong damaging. In this slide, I want to show you what happened just last week in 10 March 2023 because of a wind storm, which you can follow on the left of this plot. You can see the wind entering from the Sardinia toward the Italy and hits the island of Ventotene with a speed of 60
Salvatore,
kilometers per
sorry,
hour.
3 more minutes, but
Yeah.
you have a full-time presentation in the next session also.
Yeah, no, I'm going to close. I just want to show you the strongness of the winds, which is something like this. And you can also see in this graph the very fastly increase of the wind velocity, which reached 100 kilometers per hour in a very, very short time. So, going to closing, these effects of sea storming cause very relevant rockfalls and landslides along the coastline, which threat the archaeological sites. And our idea is, thanks to the Triqueta project, to go to improve monitoring systems along this rock wall and to use our expertise and our experience just for providing a strategy for climate monitoring and modeling in view of defending these very precious areas. So thank you for your attention.
Thank you very much, and we move to Daniele Sere from DLR, the German Aerospace Center. So Daniele, you can share your screen.
So, hello everyone, I hope you can hear me.
Yes, we can hear you.
So I will try to share my screen.
Just also to say that this is a fast presentation, and in the next session you can have 10 minutes in order to have the full presentation of the sites, the lake sites that are as case studies in the Triquetra project.
Yes, I will be fast. So this is a presentation about one of the sites which was briefly introduced before, the Les Argiliers, which is a submerged heritage site. I hear my own voice, so sorry if I sometimes I'll stop because it feels a bit strange. I feel a return. So this is the site that's been already mentioned, so I will not add additional information here. Important thing is that there is this Swiss site which belongs to the World Heritage Site of the prehistoric pile dwellings around the Alps, and it's submerged 2 to 3 meters depth, and it is right now there is the concern of the spreading of an invasive species of mussels. These are the quagga mussels, and they've been observed across the lake bed of Neuchâtel for the first time in 2014. For the moment, they haven't reached the site, but there is the concern that this invasive species is spreading across the bed lake. And even though it's not clear what is the impact of such species on submerged archaeological sites, there are concerns because mussels can stick to soft materials such as wood, and they can remove archaeological material once they're removed. Probably, maybe if they are eaten by a bird or whatever, if they are in shallow waters. And furthermore, they can alter the surrounding water characteristics and the lake ecosystems. So there are other 2 reference pile dwellings in Switzerland for which underwater photographs were available, and also they allow seeing how this phenomenon changed around the years. So these are already invaded by mussels, and I'm briefly showing a couple of pictures. So this is Versoix, and you can see the actual observations, so that they completely cover the whole site, and also this. They also stick to the surfaces that they find coming out of the water. And this is Anier, and another completely invaded site. And in Neuchâtel, this spread has been observed by our colleagues in Switzerland. So it's been recent, so in 2017 was not present, but now like the mussels have been spreading and they almost reached the Argilier site, which is here in red, while in 2019 they were mostly concentrated in the southern western portion of the lake. So these are some pictures taken underwater before and after. So in 2017 they were completely absent. This is not L'Argilier but Concis, another site on the Neuchâtel lake, and you can see how the situation changed after 2 years and a half, and even a more recent picture in which the mussels are completely covering these parts of the lake bed. So what we would like to do with Triquetra, we would like to check if it's possible to observe and monitor the spread of mussels in shallow waters using spaceborne sensors. And in our first attempt, so the project just started, so it's really more a proof of concept. We've been observing some Sentinel-2 scenes. This is a multispectral sensor which acquires information in the visible light and then the infrared across 16 bands at different spatial resolution. Some bands in the visible and one in the near infrared have 10 meters spatial resolution. This is what we use to start with. And the revision time is usually below 1 week, so this could be easily used if we find a way to exploit them at best to monitor the changes due to this phenomenon. It's important to remark that mussels are easier to spot the shallower the water is. So what you see here in these three curves, these are spectral reflectances. It means this is how different materials reflect the solar radiation in different spectral bands. And according to their shape, let's say, we can understand if what we are observing is mussels, macrophytes, or sand. And you can see that as the water depth changes from 1 to 5 meters, we have here the spectral signature of mussels, with which we can identify them thanks to their shape, and then the sand in black, and then mixtures in between. And we are able, if the water is shallow, to differentiate between these two and to resolve a mixture of these different components. But if we go at 5 meters depth, already like a pixel which will be fully covered by mussels already looks much different, and it becomes with the reduced solar radiation that we have available, because we are going deeper and deeper into the water, they become more difficult to spot. So we have to see up to which depth this could work. For the moment, we have some first reference observation for which we have some information of in situ measurements of where the mussels were. So we wanted to see if it was possible to spot them in satellite images. And this was done for the Unterultigen site in Lake Constance, which is also one of the small dwelling sites. And there, quagga mussels have been spreading since 2019, and in situ measurements have been carried out less than a year ago. So we just started a couple of observations. I'm almost done. So here you see a high resolution satellite image of Unterultigen, and the area which contains the mussel spread is inside these polygons in red. You see that in this image we don't see a lot of differences, so the brightness of the water doesn't seem to be too much correlated to the mussel, except maybe a dark spot here in the middle. If we look at the Sentinel-2 composite from 2018, so you see here the change of resolution, because here we are at 10 meters. You still see here some dark spots, but the rest of this area does not correlate well to the presence of mussels. So this hints that at the time, like the mussels phenomenon was not yet present, or at least not yet widespread. But if we go to the same period which we obtained this information about the polygons which were measured on site, you see that the situation is different, because in this large area, and also like in the small one, and here along these parts, which in general that the water appears darker.
Daniele, please conclude, because you have a second presentation in 30 minutes, so you will present in full in the next session. So you did it already.
I think I misunderstood that, but I finished.
Okay.
So that's our first attempt on this. I must say that I don't have an additional material, because maybe I got something wrong, but I can present maybe a bit better the slides in the next panel.
Get on the conclusions, and maybe because it was a big presentation, maybe we can skip the next presentation, because might be the same. So Daniele, please go to the conclusion.
Sorry, then I will give the conclusion. The invasive quagga mussel can pose a threat to submerged cultural heritage site, and we can use remote sensing to monitor this phenomenon in shallow waters, and we can track its extent and its dynamics over time. Further studies are required, though, to verify the spectral separability of mussels with other water constituents, and also to understand if we need different sources of data, maybe with a richer spectral resolution, in order to resolve the analysis of mussels and the detection. And further studies are finally needed to assess the impact of quagga mussels on cultural heritage sites, because this is also under observation at the moment. This is a new phenomenon, so it needs further studies. So that's all from me.
Thank you, Daniele. I would like to ask a few words from Kyriakos Themistokleous, not a presentation, because the presentation will be done in the next session. So just a few words for the Chirokitia site, which is the Cypriot case study. Kyriakos Themistokleous is the Technical Director in the Eratosthenes Center of Excellence in Cyprus.
Okay, thank you, Betty. First, I would like to congratulate Professor Moropoulou for the excellent organization of this conference, and also thank you for her hospitality, and we always enjoy to be here and present. As Betty said, my name is Kyriakos Themistokleous. I'm coming from the Eratosthenes Center of Excellence. It's a Center of Excellence that is created by the Cyprus University of Technology in Cyprus. We are now about 40 people, and we're growing. But in the next couple of years, we'll be becoming 100 researchers in the subject of Earth observation and remote sensing. As we have said, and we saw the last couple of days, and we talk about cultural heritage management and the processes of identifying, preserving, and managing cultural heritage resources. And we saw what kind of activities all this is involved. It involves activities of documentation, mapping, assessing the cultural heritage conditions, assessing the risk, developing management plans to protect and promote, and also involving stakeholders and communities in the preservation and management. One of the recent challenges that we face is climate change and the effect of climate change to the cultural heritage monuments. And this includes geohazards, and recently we have seen a lot of, especially with earthquakes, landslides, floods, fires, erosion, and we have a lot of challenges that they're coming out of these geohazards and natural hazards that they have to do also with the security of the visitors. And not only that, but as we can see, the cultural heritage does not only play a critical role in maintaining of the cultural identity and preserving history, but as well as contributed to the tourist and economic development. There are hundreds of thousands of visitors visiting these sites every year, and these we have to ensure the safety of these visitors. And not only that, but we have to monitor the well-being of the cultural heritage sites. This involves the cooperation and involvement of stakeholders, government agencies, community groups, cultural heritage professionals and researchers. And there are a lot of now new technologies that we include into the monitoring. Here is one of the sites in Cyprus. This is Chirokitia. Chirokitia is actually a Neolithic settlement, and it's one of the settlements that when people started living from the nomadic living, they started grouping together and forming communities. And this is one of the first examples that we see in the region where, these, structured communities were there. So we see a settlement with round houses that they're built together. I'm going to present it later on, so I'm not going to go on. I'm the last presenter. So stay here, and I'm going to close the conference by presenting this Hirokitia site. I have another presentation which is more, so I don't have all the slides here. There are a lot of risks that we monitor, and I'm taking you now, and for this site, we start introducing space technologies. We're introducing a way to monitor this cultural heritage from sites, and I want to stay in this slide here that you can see that we using radar technologies, INSAR technologies from space, that we're trying to monitor any changes using persistent scattering techniques, that we can see any changes in vertical and horizontal in terms of millimeters, so we can see if the site has any potential of changing from this, from climate change or any other, from earthquakes, from landslides and so on. But also we can, whenever we identify these, we also have to monitor, we have to go to the site and use techniques like, as we presented a lot of methodologies in this conference, using photogrammetry, laser scanners, GPSs, and so on. So all these techniques in combination and the integration of these techniques are really essential. You can see from these slides, here we have a satellite corner reflector. It's a digital satellite corner reflector that we monitor every point in the site from the satellite, and we can see any movement in terms of millimeters and how this is going on. So I'm stopping. This is the last slide, so you don't have to worry about this. What we trying to see and how we got this exercise here and this pilot project is to see if through these changes, through this climate change changes that we have in the site, if we can secure the security of the visitors. And in this site is kind of interesting because whenever you get to the site, you have to go all the way around to the site in order to visit the archaeological site. And by walking through there are a lot of rocks, a lot of big stones that by, and we started testing the rock falls and simulating, what might happen in case of, for example, earthquake, landslide, and so on. So we're trying to see how we can go there, what kind of methodologies we can use in order to secure those stones and secure also the entrance of the visitors to the site. That's it, and I would like to thank you, and stay at the end of the conference so I can present the whole.
Thank you, Kyriakos. And now I am passing the floor to Professor George Deodatis from the Columbia University. He's a professor of civil engineer and professor of earth and environmental engineering. I don't know if you can share the screen or if it's an oral.
Can you see my screen?
Yes, Professor Deodatis.
Okay, ladies and gentlemen, good evening. First of all, I would like to thank Professor Moropoulou for her kind invitation, and I would like to touch upon a few issues related to the combined effects of sea level rise and coastal storms on the coastal infrastructure. And then I would like to emphasize optimal adaptation strategies. I'm showing you here a few photos from the 2012 Hurricane Sandy that hit the New York City metropolitan area. On the left, you see a town in New Jersey. On the right, the Rockaway Peninsula in New York City with not only major flooding but also fire. On On the left, this is the tunnel connecting Manhattan to Brooklyn, completely flooded to the ceiling. On the right, you see a typical street in Manhattan, 14th Street. And this might not have even been the highest point of the storm surge. The metro system, known as the subway system in New York City, was flooded in a major way. You see here photographs from one of the stations at the ground level. And this was also followed by a major power outage. On the left, you see the lower part of Manhattan that has lost power. This single hurricane incurred $65 billion of damage in the US. Of these, $19 billion of damage were in New York City. Unfortunately, there was major loss of life, 233 fatalities, and there were over 5 million people without power in the northeastern part of the United States. This list shows the costliest hurricanes in US history, and these values are adjusted for inflation. And you see that out of the top 6, 4 have occurred very, very recently. Now, we know that in the future, the anticipated sea level rise is going to make coastal flooding much more severe. From what you see here, this is sea level rise in New York City. The left part is measurement from 1900 until today, and the right part is anticipated sea level rise, and you see a high estimate, a low estimate, and a median estimate. This is not a problem only for New York City. These are the global sea level values that were provided by NASA from the 1990s until today. There is a big, of course, question. How are the occurrences and the intensity of storms going to change in time because of climate change? We know that in general, they are expected to increase, but we don't know exactly by how much. And this is going to have a significant detrimental effect on coastal flooding. So the combined effects of sea level rise and coastal storms on the coastal populations and infrastructure are expected to become dramatically more catastrophic as we approach the end of the century. Keep in mind that 10% of the world's population lives in places along the coastlines that have low elevations, in general below 10 meters. And I'm showing here 2 lists. The countries with the most people in low-lying coastal areas and a list of countries with the largest percentage of their populations living in low elevation areas. And we have to consider that a significant part of the world's cultural heritage is located in low-lying coastal areas and consequently is at high risk. So our objective was to establish a general methodology to determine the optimal adaptation strategies to to protect the population and the infrastructure in coastal areas from sea level rise and storm-induced flooding, given a prescribed budget. And this optimality is defined as maximum reduction in losses compared to the case of doing nothing. And in order to accomplish this, we are considering the full range of different storm surges and timings of the tidal cycle over a selected time horizon, and this can only be done probabilistically. And of course, we also consider future sea level rise, again, probabilistically. Now, the optimal strategy would involve, in general, not a single measure, but a series of different protective and adaptation measures with spatial and temporal distribution. And of course, we have to account for stakeholder feedback, equity, social justice, social acceptability, and account for environmental and ecological concerns. See here just a few of the many different protective measures that have to be considered. Nature-based, technology-based, including also strategic retreat. This is a very broad diagram flow chart of the methodology that we have developed. I'm not going to go into any detail. I only want to mention that different available budgets will lead, of course, to different optimal protective strategies. And I would like to conclude, because I know we're out of time, that this increasing threat to low-lying coastal areas from the combination of sea level rise and storm-induced flooding is not a problem in New York City or the United States. It's a global problem. As I showed you the list of countries that are expected to be most affected. And the world has to start thinking now about how to protect the population and the infrastructure of coastal areas. I have to mention that strategic retreat to areas of higher elevation in some cases might be the only option. And of course, related to the topic of this conference, a significant part of the world's cultural heritage is located in such low-lying coastal areas and is expected to be affected in a major way. Thank you very much.
Thank you, Professor Deodatis. Just to conclude by saying that it's true that the climate change and the effect to the coastal areas, to the areas that are in the mainland, but the effect of the water in the mainland and the severe rainfalls and severe also snow affects the monuments everywhere, not only Europe, but worldwide. The sea rise level is a major issue as add-on to the geological events that can happen, like the Ventotene Island that the University of Sapienza have showed, and also the change, the biochange because of the climate change in the lakes, like Daniele Serra from DLR have shown to us, I think give us a path in order to make a correct knowledge base, to quantify and to find mitigation solutions that can go to decisions, but also to monetize all those decisions not only for our generation, but also for the next generation, since cultural heritage is something that we have been born with, we have to protect, but we have to protect it also for the next generations. So thank you all for being at this session. Mrs. Moropoulou, you have to close the session, so that's why I left you
Thank you very
in
much,
order
Betty.
to conclude at the end.
Thank you very much, Betty. It was a very interesting presentation of various aspects of climate change, but from the dramatic data I saw from my friend Professor George Theodatis, I understand that more of the prospections are already being overcome. This is a landscape which should modify the way we intervene and the way we perceive the threatening of cultural heritage, of infrastructures, of population from climate change. Up to now, we were saying that the interface between environment and historic materials and structures, the architectural heritage, cultural heritage, was the critical area where the interaction between the environment and the heritage was taking place. But here, the occurrence and the intensity of all the environmental stresses and natural hazards, like floods, like fires, like, I'm not speaking of earthquakes because they are a natural hazard and a threatening of humanity anyway, and this is a permanent risk. But I'm speaking of all the others. To mitigate environmental stresses was a strategy some 20 years ago because the level of these stresses was controllable and the occurrence was stable. Now we are to face a wave of attack, of intensified factors, and of a high frequency of occurrences. That means to mitigate or to adaptate anyway have limited options. To mitigate is obvious why. To adaptate, to develop adaptation strategies means that we are going to develop new infrastructures and new management schemes that will change the face of the world. 20 years ago, speaking of resilience, we were speaking of cities, infrastructures, structures, materials that would be capable to get the burden of these environmental stresses and behave in a way to assimilate it. Today, when we are speaking of climate change, it cannot be assimilated. Should that be adapted in order to develop another approach to our built environment and to our democracy? I don't think this is acceptable. Of course, to monitor what is happening, for instance, from monitoring phenomena on the Earth from the space, is a tool. What I've heard by now are tools, and tools are useful in order to know where we are and to document what is happening. But we should go a step further. All the analysis we have from world experts are showing to us that if we don't go to decarbonation, we won't have the perspective to overcome climate change. So it seems that at the time we will monitor and we will study what is affecting the Earth systems and the social structure and infrastructure, we will be able in the same time to consider adaptation measures not to develop new towers, but to develop new decarbonation processes of industry, of urban life, and of functions of local and region development that will neutralize and that will combat the climate change. So I think it seems we have to go beyond what is cultural heritage, to go to change the actual contemporary life in order to develop a future for the future generations. And in this way, to safeguard as well the past. Thank you very much.
Thank you, Professor Moropoulou. I think this session is a live session. It's a living lab, I could say. So maybe we can continue during the coffee breaks and during and we can continue the discussion during the coffee breaks, but of course we have to give the floor to the next session. And thank you for inviting us all here, and once more congratulations for the effort for this great symposium.
Thank you all very much.
So this is the last but not least session of this day, resilience to climate change, natural hazards and pandemic risks, biosafety. It's almost the same title with the previous one, but that it was at 3 o'clock. But now we don't have, I think, the first speaker, Charalambos Zafiropoulos. Is it here? Is he? No. So we can pass directly to the second presentation from Kyriakos Lambropoulos. He will refer to the other authors. Assessment and soil pollutions and contamination at the historic former Hellenikon airport in Athens through correlation and analytical measurements and metagenomics analysis. Kyriakos, the floor is yours.
Thank you, President. I'm going to present loosely the following slides because I want you to grasp the concept of actually correlating three basic issues: analytical techniques, metagenomics, and how to actually address the challenge of looking at a very large area, which could be a cultural heritage site. At the beginning, you may be wondering what does an airport has to do with this conference, but you will realize that if, for example, we want to assess a huge cultural heritage site, like an archaeological site, we cannot have so many resources in actually doing so many measurements, so this approach is useful in actually addressing this challenge. This was part of a project that was for the rehabilitation, for the reuse of Hellenikon Airport, which is now being in progress and becoming into a residential and business area. So we were asked as a university and DNA Sequence and other colleagues to actually look at the problem of pollution and contamination in this area. So we utilized the methodology to minimize the sampling of the soil to check at the problem there. We developed, we have presented this work earlier. This is part of a methodology that in order to look at these large areas, you need to look at the geomorphology, and you need to know the development of this area so that you take this into account and find the areas of potential hazards. That will give you a first idea about the potential environmental impact and pollution model, so that you can focus in certain areas that might be of interest or not. For example, you may be looking at part of this huge area. In our case, we're looking at three distinct sub-sites of this huge airport, but we want to know how was the impact from the whole area, both of the surroundings and the airport inside. So going through quickly, this is the provincial environmental impact and pollution model, which give us a first idea how the pollution might be traveling or might be diffusing throughout this huge airport. So we have identified four potential hazard areas. Mostly it's underground fuel tanks and chemical tanks that, to our surprise, and looking at the geomorphology and the history of the development of this project, gave us a clue that, for example, looking at the investigation site C down in the former American College, which is the Civil Aviation Authority, and there is an archaeological site there. That's why we were interested in this area. Although it would be like 1.5 kilometers away from these potential hazards, because of the development of the runways and the whole infrastructure, you can see the yellow arrow going down on this area, coming from the mountain from the east, going to the west towards the sea, because all the pollution kind of diffuses towards the sea. And of course, you have on the left, which is actually the north side of the airport, you have the maintenance hangars. That was another area of interest. So having this in mind, we have designed certain areas where we applied non-destructive testing. In particular, we did at first electrical resistivity tomography, so that we, in these distinct areas that we were looking at, we did selected scans. And from these scans, we managed to identify through this ERT technique points that were of interest that could actually correlate with some potential solutions. From these points, we did drillings. We selected certain samples, soil samples, that we did analytical techniques, and certain other samples from these drills, and we did metagenomics analysis. And we continue on with a correlation. We were looking actually, sorry, I forgot to say that, we were looking for heavy metals, we were looking for total petroleum hydrocarbons, polycyclic aromatic hydrocarbons, volatile organic compound, and semi-volatile organic compounds. And of course, we were looking at contamination in the soil. From the results, which is kind of interesting, we saw that based on the maximum acceptable limits, the heavy metals copper, lead, zinc, arsenic, and mercury did not exceed the acceptable limits for these cases, because we have to remember that this area is going to be redeveloped into a residential, and part of it will become a business center. Cadmium was in one or two locations out of the limits, but we had some concerns about chrome and nickel. So what we are going to look at here is this is the area of the former American College Civil Aviation Authority. You can see the archaeological site, which is one archaeological wall. I'm pinpointing two of the points of interest. These two points, the drilling points, the samples were out of limits, which is kind of weird because out of the 20 or 60 samples, these were out of limit, and we are trying to think, why is that? For example, don't forget, and I'm going to say that in the next slide, that the Greek soils are heavy in chrome. However, this doesn't justify the spatial distribution. So the remaining samples around this area were within limits. So what happened in these specific samples, both for chrome and for nickel, were out of limits? That's an indication of a probably local pollution. And if you can look closely, this is a photo, a Google Earth image from years ago. You can see a storage hangar. That means that probably they have some chemicals there, because this was Civil Aviation Authority, so probably there was some leakage of chemical localized. And what we did is, indeed, that we suspect that this was the source of pollution. The indication is high because if you see from going for 401, 402, 502, the concentration of both heavy metals is decreasing. So that means that the source is coming from the east, close to the hangar, and moving away, diminishing towards the sea. The next step, we were looking also at another site. You may see where it is roughly it is next to the runway. And again, nobody would expect a source of pollution there. We have to remember that this airport was closed for 20 years, so there is no aircraft traffic. So what happened is most probably it's earlier pollution, slowly diffused, slowly diluted with all the water movement. And again, I'm not going to go into details, but this area, if you can see on the upper image, there are two ancient streams. This area was developed into an airport, which was very important for Greek Air Force and civil aviation. But so they pretty much demolished the whole area, and they have the hydrology of the area is very interesting. In this particular part of the airport, on the southern part, and you can see the stream there. So that is correlated to. I'm going to move quickly to another area which is also problematic. And again, just to finish up with the metagenomics and go to the conclusions, we did also metagenomics analysis. We took some samples from these soils. The first step was taxonomic classification for each sample per investigation area. Then a DNA sequence prepared the thermal maps for the examination areas, and we can see the correlations between the points of collection and the actual phyla that they measured. And then we try to find correlation between soil pollution and contamination. And in some of the sites, there was high correlation. For example, from this correlation, we realized that there is no widespread pollution and contamination throughout the airport, so that leads us to believe that this is either localized or transferable from other areas. For example, in area B1, it's mostly localized due to a hangar. In area C, as we said before, it's localized because of this storage area. And again, this is from the runway because of the diffusion from uphill. To finalize, and this is what I want you to remember, is that now we have availability of using three basic tools. Analytical techniques, we have metagenomics, but in order to understand what is happening, we need to have an idea first. So that's where the potential environmental impact and pollution model comes into question, because It will give us a big picture to try to focus on sub-areas that we can do focused and specialized and make our resources more effective. That's the whole idea of this presentation, that we have the tools now. And I forgot to say that metagenomics, behind helping us to understand what is happening, it's providing us some indices for monitoring the biological microbial load of the soil, so that it gives us another tool. For example, if they want to continue monitoring this area, that we have some indices both from pollution and microbial load. I think I was okay in time? Yes, 10 minutes.
Okay, thank you, Kyriakos. Are there any questions? Just one question. Is anyone? No. Yes.
Thank you. Maybe I did not hear the full presentation, but could you explain like how is the pollution with the soil like pose a threat to the cultural heritage itself, like the archaeological site itself?
This airport is very historic, as I probably mentioned very quickly. Although it's a civil aviation airport, this was the creation of the Greek Air Force. So the whole evolution of the airport goes in parallel with the whole evolution of aviation in Greece. So for us, for Greek Air Force and for civil aviation, it's very historic. It has, if I remember, two or three historic buildings that have kept that. Although the whole area is being redeveloped into business and residential, there are some buildings that, because of their architectural value, they keep them. There's a hangar and there's the West Terminal, if I remember well. Sarachen building, correct. But the whole idea of presenting this in this section is that, and as I said initially, you have to look at the big picture. This is a challenging case because it's a huge area. How do you apply your limited resources, either human resources, financial resources, because to make thousands of measurements, it's difficult. And even so, you may not be able to understand what's happening. So you have to have an idea first, focus in certain areas, and move on and get a better idea instead of going randomly.
And also, like what do you think are the challenges of using metagenomics? Because as I know, like they could provide you with like a huge variety of microorganism data, and how do you interpret it?
The challenge is that you need to make correlation. So that's why I mentioned that you have to do typical analytical measurements. If you just look at the microbial load in these soils, you may not get the whole idea of what's happening in this area. But if you actually correlate the results with typical analytical techniques, if you actually correlate that with non-destructive techniques, you have a better idea of what's happening. So I think it's a bright future in this combination. Thank you.
So the next presentation will be presented by Vasiliki Pougakioti from Elliniki Eteria Society for the Environment and Cultural Heritage, and the title is Climate Change vs. Cultural Heritage, an adaptation strategy for the archaeological site of Essen Messini.
Good evening. So, should I change myself the slides, right? Excuse me, this is it? No. You? This one? No. All right, yes. Thank you. So climate change, as we already said, is one of the most critical challenges humanity faces nowadays. In order to formulate a mitigation and adaptation policy, we use representative concentration pathways, which are climate scenarios adopted by the IPCC and describe different climate futures depending on the volume of greenhouse gases emitted in the years to come. The RCP 2.6 is a strict scenario, significant mitigation, and seeks to keep global warming below 2 degrees, while the 8.5 is the high emission scenario. Now, the impacts of climate change on heritage values, tangible or intangible, are likely to be dynamic and complex, while the intensity varies in the same way as the various climate parameters that cause them. Extreme events such as an excessive rainfall, wildfires and storms pose significant threats that are both severe and apparent. Indirect, but real and certain, is the danger that the cultural heritage element is expected to face because of the small changes it goes through due to a constantly changing environment. Thus, a vulnerability assessment analysis can answer these whole requirements. Our case study, the archaeological site of ancient Messene, is located in the Peloponnese, southwest of hills of Ithome and Eva. It's a prime example of a southern Greek archaeological site, including ancient monuments of significance, and also it is highly popular with a large number of yearly visitors. Our objective is to formulate at the end an adaptation strategy to climate change for this archaeological site and use the general axis for archaeological sites with similar characteristics. Some things about ancient Messene. It is protected since 1991, while the protection zones A and B have not yet been established for the site. About the materials, most of the stones of the site are the most part sedimentary, notably limestones and sandstones. Also observe mosaic flooring and clay bricks. About the vegetation, the area is covered by shallow vegetation, mainly with trees, some of them also cultivated plant species and secondarily bushes. Outside the site, the native vegetation consists primarily of a mixture of native plants, olive groves, and evergreen bushes. One really important thing is the fire the archaeological site of ancient Messene has experienced in 2014, and the last flora presently covers these regions is the result of the regeneration of the species after the fire. About the infrastructure, the archaeological site and the village of Mavromati, which is anyway, the neighboring settlement, use standard absorption cesspools that cover the sewage drainage needs. The entry facilities are equipped with portable fire extinguishers to safeguard the archaeological site from fire. And so far, neither fire protection study or a firefighting system has been done. Road access and informal parking area are located in the central north area, and most of the roads are rural, narrow, and without appropriate signals. I can point, yes, I can point. Okay, so Mavromati is up there, and the entrance, the entrance is above the theater. Now, to assess potential climate changes and consequent extreme events, a large number of climate variables indicators were analyzed corresponding to those IPCC is analyzing in the relative assessment reports. The analysis was based on comparing the values of these variables for 3 climate scenarios. I told you in the first slide, a severe mitigation, an intermediate, an extremely high greenhouse gas scenario, and for 3 periods. 1971-2000 was our reference period, and the 2 future periods were 2031 to 2060, and as a distant future, 2071-2100. Based on the study findings, it was determined that fire, desertification, soil erosion, which consequently increase the risk of flooding, are the primary threats for which the vulnerability of the site should be assessed. We used the general formula of IPCC, and you see the parameters of exposure, sensitivity, and adaptive capacity. Exposure is a parameter that was determined as the degree to which ancient Messene will be adversely impacted by the risks of fire, desertification, and flooding. the great threats I told you in the first analysis of the climate parameters. Sensitivity was assessed as the extent to which the materials of restored monuments and excavated finds, as well as native and cultivated vegetation, would be affected either directly or indirectly. And the adaptive capacity criterion was determined as the adequacy of the electromechanical infrastructure, the suitability of road infrastructure and the level of safety they provide, the management practices of the archaeological site, and the adequacy of the existing legislative framework for the protection of the site. Based on this, we developed an integrated adaptation strategy. Now, the following chart summarizes the results of the analysis and the three parameters I explained you. The degree of risk is estimated according to the three emission scenarios and each climate projection period. The qualitative scale ranges from 1 to 4, where 1 represents a low risk and 4 is a high risk of an event. As can be seen, the location of the site in an environment that is expected to become drier with high chances of fire, desertification and soil erosion makes it particularly vulnerable to climate change. The inadequacy of crucial infrastructure such as roads, which does not ensure functional and safe access or evacuation from the site, is another crucial factor affecting its vulnerability. The absence of a well-designed firefighting system is also crucial. The materials of the monument are indirectly affected by daily climate variations and directly impacted by extreme weather events. The vegetation within and around the site is resistant to change. However, a reoccurrence of extreme events, especially fire, could significantly limit the possibility of natural regeneration. Finally, the non-completion of the procedures for the designation of the protection zones A and B is considered to negatively affect the sensitivity of the site, while, on the contrary, its resilience increases with the regular care, maintenance, and restoration of each monument. Based on the above analysis, we developed an integrated adaptation strategy, and the plan is we organized it around 5 primary axes as shown in the chart. The first axis is a spatial monitoring system to better understand the relative impacts of climate change on the materials and structures of monuments and to monitor the effectiveness of any measures taken. Some of the measures are the installation of recording sensors, to establishment of regular non-destructive monitoring of historical monument deterioration and strength, and the creation of a database. The second axis is adaptation measures. The most important are the improvement of the road infrastructure outside the site, as well as the movements within the site, the conduction of a fire protection study and implementation of the necessary measures and works, flood and erosion protections with appropriate infrastructure, and the regular restoration of the monuments, which is something that is being done. Now, the third axis concerns institutional tools, and the most important tool is the establishment of the protection zones A and B, while the fourth axis is an emergency actions preparedness action plan, taking into account the number of the visitors and the limitation of private automobiles and organizing parking areas. The fifth and final axis is information, education, and awareness measures for the public, for students, youth, and those who work in the site. Now, to conclude, during the conduction of this study, it is clear that it's absolutely necessary to develop a detailed management plan that, when implemented, will protect the cultural heritage site from all types of pressures and risk. Equally important is the transition to a new system of monument management, which will necessitate cooperation between competent bodies, services, and institutions. protecting cultural resources, taking care of their natural environment, making infrastructure work better and safer, maintaining and restoring monuments should all be done simultaneously and with the help of the right people. Some other critical issues that become apparent are the difficulty of collecting data relating to the existing situation and other possible pressures such as visitors, traffic loads, etc., and many others, and consequently, continuous monitoring and recording in a database is absolutely critical to form an adaptation strategy plan. The other critical issue is the difficulty of differentiating between threats linked to climate change and those that may exist for a certain cultural site. This study is a work from an interdisciplinary team and is part of a wider study and program Ελληνική εταιρεία is involved, Life IP, Adapting GR, boosting implementation of adaptation policy in Greece. Thank you.
Is there any question? Just one. There are two. Okay. Take the microphone.
Right, so the question is this plan implemented or is it going to be implemented soon? So
okay.
What's the status?
This plan was formulated in order to be proposed for the NSET machine. Also, in order to formulate a greater plan for archaeological sites in Greece with same characteristics, or a guide actually to see the difficulties and the crucial issues we have identified and formulate the basic axis an engineer, an architect should, an archaeologist should consider. Also, the program and our work is going to be proposed for the national adaptation strategy of Greece and the sector of cultural heritage.
Okay. Thank you, Vasiliki.
Thank you very much.
Next presentation from Ekaterini Delegu, and it is about the metagenomics approaches for the integration of the diagnostic study and the conservation of porous stone elements, the Catholicon of Varnakova Monastery.
Thank you. This work that I'm going to present you today is part of a larger project, a national funded project that it is named VIOFOS, and it actually aims is to apply metagenomics and bioinformatics for the qualitative and quantitative identification of the microorganisms and enzymes which induce decay or they could be beneficial for the protection of stone elements, just like the microbial-induced calcium carbonate participation. The second aim of the project is to design and develop nanostructure and biofunctional conservation materials, that is, nanobiomaterials, through the enhancement of suitable microorganisms which are autochthonous, that is, that they inhabit the investigated stone surfaces. Within this framework, I'm going to present some first results about the Catholicon of the monastery of Varnakova Monastery, and these results are the decay diagnosis, the diagnostic study of the porous stone elements of this particular monument. What it is, the innovation that we try to achieve is to have an integrated diagnostic study that won't only include physicochemical, physico-mechanical, and aesthetical parameters of the building materials, but also biological parameters. This is Varnakova. It's an important religious complex with high historical significance. The second construction phase is the one back to 1831, and this reconstruction was made on the remains of the 11th century church. It has been recently affected by strong earthquakes, so it has many stability problems, and that's why nowadays we're having a major reconstruction and rehabilitation project that it is still on. Our investigation site is indoor surfaces, masonries of porous stones in the upper part of the monument, as you can see, this diagnostic campaign took place just 8 months after repointing. The restoration mortars that were applied are market restoration mortars that they are lime and metakaolin based. These are the areas in particular. You can see macroscopically we have distinguished two types of porous stones, and of course we were right, as all the measurements indicate. From the petrographic and mineralogical characterization, we have the porous stone type S, which is a porous fossiliferous limestone, and its cement is made of sporite crystals, while the second type of porous stone, the type O, is a porous recrystallized limestone, which is a rather heterogeneous material with areas of microsporite and areas of coarser calcite grains. The aesthetical parameters were measured by colorimetry and based on the particular EN standard. We saw for both types of stones that the lightness, the luminosity or the brightness values are high. A and B parameters are positive, so we have both of our stones have the tendency, they're tending to red and yellow color respectively, and these of course LAB values will going to be used as reference ones when conservation interventions are going to be applied in the future. Another slightly destructive, slightly invasive technique that was applied on the masonries under examination is a drilling resistance measuring system, DRMS. DRMS provides continuous reading of the force applied to penetrate a particular depth of the test area. So we're having this kind of plots where a drilling force is plotted against the depth profile. And as you can see, the O porous stone presents higher values compared to the S porous stone. We anticipate that the uniaxial compressive strength of this particular porous stone will be higher than the other, and that's why there is a linear relation between drilling resistance and uniaxial compressive strength for a majority, for many types of stones. Total soluble salts were also determined, and as you can see, all the values are lower of the threshold value of 3%, meaning that our surfaces, our porous elements, do not include high salt concentrations. So that's a good thing for us. High Greek and microcultural parameters were measured based on the EN 1581. And as you can see, both stones, type of stones, actually have a variety of high Greek and microstructural values, but as porostone presents higher values of capillary water absorption coefficient, of water absorption capacity via capillary rise, as well as porosity accessible to water via capillary rise. The same, more or less, stands when the Rilem recommendation about determining the parameters of total open porosity by immersion, water absorption capacity via immersion, and apparent density were measured. Again, as porostone presents higher values of high Greek and microstructural parameters. And finally, the biological parameters that we are in progress of determining and using metagenomics, because if we try to use the traditional cultivation experimental techniques in the laboratory, then we will have detect only a small percentage of the microorganisms. But this difficulty, this disadvantage can be bypassed when metagenomics are applied, where the total kind of microbiota can be actually detected. What's another thing? One more thing that is very, very important for the cultural heritage theme is that the sampling method is a totally non-invasive method. Cotton swabs are just used, and you can perceive DNA and RNA sealed. Okay, so we're having a non-invasive sampling process, DNA extraction from samples, amplicon DNA sequencing, sequencing quality screening, and finally, detection and correlation of the detected genera. So the first result is that the monument is that beta diversity analysis of the bacteria communities for our porous elements, and the monument samples were grouped according to their type with a very high statistical difference, and that's really good. Here we have the bar chart with showing the relative abundance of the detected genera in each sample, and what's important to see is that some genera like the Pseudodonocardia, Pseudomonas, Bethylobacterium, Acinetobacter, and group 6714 consist almost 50% of the relative abundance of the samples genera in the examined samples. No, I'll finish. You didn't interrupt the previous speakers, though, even though they had also exceeded the time, I have to say. Some of the detected genera include species that are carbonatogenic. That means that they can produce calcium carbonate, and these kind ones can be Acinetobacter johnsoni and Sporosarcina pasteuri, which actually can have a great impact in inducing calcium carbonate precipitation on decayed stone surfaces. And this is the heat maps, and here you can see that there is a clustering. We can group our samples according to their location. It seems that stone elements that they are close to each other, having many common genera, something that it is rather logical. And in parallel with all this, we're performing in lab biomineralization experiments, which are in progress, and based on our sequencing results, and these experiments involve Bacillus species, Micrococcus species, Sporosarcina species, and Pseudomonas. And so, in conclusion, we'll try to correlate all this data all together because our ultimate goal is to create, through BioFOS project, nanobiomaterials which could actually bioconsolidate the under examination pore stone. Thank you.
Thank you, Mrs. Delegu. Is there any question? No. Okay. We can pass in the next presentation by Stavroula Thravalu, or Thravalu. Climate responsive opportunities and challenges in urban vernacular heritage.
Όχι, enable content. Υπάρχει μια μπαρίτσα που λέει enable content. Συγγνώμη. Θα μου μεγαλώσετε λίγο την περιοχή. Ωραία. So, good afternoon. I'm Stavroula Thravalu, and I will present some results that are mainly based on my PhD thesis entitled Climate Responsive Opportunities and Challenges in Urban Vernacular Heritage. As an introduction, I would like to point out the research context and motivation of this research that is based on the benefits of natural ventilation as an affordable and environmentally friendly cooling strategy that is compatible with heritage buildings. Urban morphology is among the key parameters to define the effectiveness of natural ventilation, apart, of course, from climate and building form. The question that arises and has been investigated in this research is the degree in which we can rely on natural ventilation as a cooling strategy in heavyweight vernacular buildings located in dense urban contexts. This question derives from the fact that airflow in the canyons of organically developed historic urban centers can be a far lower fraction of the free stream wind speed, which in turn impedes comfort ventilation. Further to this challenge, the literature review reveals many studies focusing on idealized geometries that neglect the local asymmetry and the complexity of an organically developed historic urban center. In response to the identified research gap, a multi-scale approach is adopted in this research through the consideration of the airflow field in building, street canyon, and neighborhood levels under real field conditions. The district level of study corresponds to the wider area of the historic center as a whole, where analytical tools are employed. Respectively, environmental field monitoring is conducted in the selected neighborhoods, street canyons, and buildings. The focus is on heavyweight buildings with tripartite arrangement, trimericteria, featuring two elements which both play a very important role in natural ventilation. The first you can see here is the pass-through space portico that connects the street and the interior courtyard. And the second is the timber projecting volume Sachnisi, which offers multiple window operation possibilities. One of the main research objectives and innovation of this research is to address building ventilation as a function of an in-street and rooftop ventilation, as well as to decipher the role of urban geometry in determining any possible variation in indoor and urban ventilation. In this aim, environmental measurements were conducted at the reference height, which is 2.5 times the mean building height in the neighborhoods. Finally, the effect of various window operation patterns on indoor thermal comfort is assessed considering not only the parameter of temperature, but also the parameter of relative humidity and air velocity. An additional objective of this research is to assess the impact of urban geometry on the insulation and ventilation capacity of the porticos and the sachnices. Moving on to the adapted methodological tools, the district level of study corresponds to the walled city of Nicosia in Cyprus. Historical and in situ analysis supported the selection of 2 neighborhoods, 3 street canyons, as well as 3 heavyweight buildings with porticos. The selection was based on a set of morphometric characteristics. The 2 selected neighborhoods differ in terms of building height, street pattern, and density. Area 1 in the west is mainly comprised of 2-story buildings, whereas Area 2 on the east is covered mainly by ground floor residences with large courtyards and settled in a more organic and irregular street pattern. 2 narrow street canyons with aspect ratio 2 and 1 square cavity canyon with the same orientation were selected. The 3 buildings are located on the selected street canyons and they are made by adobe mud bricks resting on stone foundations. Various window operation patterns were examined, namely all-day ventilation, nighttime, or no ventilation. Different percentages of opening were also examined, as well as combinations, for example, cross-ventilation or single ventilation mode. The results of this analysis revealed the gradual depreciation of the climatic criteria for south orientation due to increased housing demand. The urban canopy has both environmental virtues and limitations. For example, narrow street canyons provide shading during the summer, yet they suffer from reduced potential for long-wave radiation during summer nights. The climatic adaptability of vernacular forms is achieved through a series of elements, for example, the courtyards, semi-open spaces, the cross-arrangement of the windows, and the sachnici volumes that provide multiple window operation possibilities to the occupants. The mapping process on the district level indicates that approximately 40% of vernacular buildings in the walled city of Nicosia incorporate portico spaces in semi-open or closed forms. The majority of these porticos correspond to the central part of the 3-bay arrangement, and they are elongated spaces. The mapping process also identified a total of 246 sachnicis projection that they were documented for the first time. The vast majority of the recorded cases are timber frame constructions, while stone-built sachnicis are very limited. Also, the vast majority of the buildings with timber sachnicis are located in narrow canyons, which results in limited direct light penetration, especially in the ground floor porticos. The first floor porticos and the sachnici spaces are sunlit throughout the year. For this reason, they diachronically hosted household activities requiring high lighting levels. Looking into the orientation of the main facade of the sachnicis, no correlation was found between the number of sachnicis windows and the orientation, while only 1/3 of the buildings benefit from direct solar gains. This fact indicates that the porticos and the sachnicis morphology were not associated with were more associated with functional and structural aspects rather than climatic ones. However, roughly half of the cases of the buildings orientate the portico's axis according to the prevailing wind, which is at the east-west direction, So in this way, they enable cross-ventilation. In the rest of the sample, the lateral openings of the Sahni-C are very important in capturing wind along the street canyon. According to outdoor environmental measurements, air temperature in the canyons are systematically higher than those occurring at the reference point, and this difference may be up to 1.5 degrees. Air velocity levels in the street canyon is approximately 1/3 of the reference wind speed, while indoor air velocity remains at minimum level, reaching up to 1/5 of the wind speed in the canyon. This indicates the importance of considering the environmental conditions in the urban canyons rather than the reference point, because they better describe the boundary conditions of the building ventilation. The first floor portico of the building with Sahni-C recorded the highest indoor air velocity, which demonstrates actually the wind capture potential of this morphological element. Finally, the ventilation experiments indicated the importance of night ventilation in reducing the peak temperature of the following day. Yet, in order to avoid overcooling and elevated relative humidity levels, which is especially important in humid regions of the Mediterranean, such as coastal areas, so for this reason, a moderate percentage of opening is recommended, and specifically, the recommended window-to-floor ratio on the ground floor is 9%, and on the first floor is 13%. This is so open windows with shutters on. Concluding this presentation, an innovative multi-scale methodology was applied, addressing the challenges and opportunities of dense historic urban centers and heavyweight buildings in the Mediterranean. The results indicate best practices for enhancing the cooling effect of natural ventilation, highlighting the role of occupant behavior and nighttime ventilation. Finally, given the social, cultural, and financial assets of the free cooling potential of natural ventilation, urban policies should facilitate this practice in historic centers by lowering noise pollution, inspiring safety through means of governance, and finally raising awareness amongst residents regarding efficient window opening behaviors in heavyweight buildings. That's all for me. Thank you.
I also thank you, Ms. Travaglou. I don't know if there is any question, but we don't have time. It's better to proceed. And I think there is not the lady from Albania is here. No. So I will present, and I promise that I will be less than 10 minutes, because the lady that came in told me that we have to finish by 8 o'clock because they need the place. So the sunken city of Epidavros, me and my son is in the head and the bottom, and then in the middle is the second in F48 of underwater antiquities, Dimitrios Rodostamos Kourkoumelis. You know the targets of the Triquerta, you have seen it before, so I will run this slide and I will show you that the ancient Epidavros is not the classical site of Epidavros with the theater and all the monuments that are, but is nearby, and there was a pathway from up down to the ancient Epidavros who was sunken, some of it in the sea. So there are the ancient malls, that was the harbor, the ancient harbor, and you see the north part of this peninsula, while we will see in the next slide the south part. The target is to make all this quantitative and qualitative assessment of the changes taking place to cultural heritage sites. This is the Triquerta target. I think yes. Well, the Epidavros is there where it's written exactly under the A, the middle A, And you see where is concerning the Attiki, and there is another place. So this is the south part of the peninsula, where is on which is Acropolis, and the theater is in the west of Acropolis. And then there in the place where is written Nisi, there is a second villa, a Roman villa, while there where is the written Epavli is a mansion, a Roman mansion that you can see its drawing, no, not drawing, it's the original orthophoto. So we want to study is one of the three major studies in Greece that will be studied in the frame of Three-Quarter project. The other two are in Kalapodi, you have seen it in the previous panel, and the third one is Aegina Colonna, is a place in the west part of Aegina. So we will combine aerial and close-range photogrammetry, terrestrial laser scanning, aerial lidar to have the DTM and the terrestrial model, and then we will use multi-beam sonar survey for the underwater findings and underwater photogrammetry for the underwater also part of the site. So we have in our laboratory around 6 or 5 divers which are used to do such works, and all these will be referenced in a common reference network. This is for surveyors most. It's not very interesting for you. I just will give you a short story of the archaeological research. In 1970, aerial photography of the submerged remains under the supervision of archaeologist Krizas. In 2017 to 19, there was a collaborative research between the Ephorate of Underwater Antiquities, the Italian Archaeological School of Athens, and the Istituto Superiore per la Conservazione ed il Restauro of Rome. In 2021, launch of the project Autonomous Guided and Narrated Tour over the sunken city of Ephidaurus with the acronym PERIPLUS by the Ephorate of Underwater Antiquities, the Institute of Language and Speech Processing Athena, and the Marine Services for the promotion of the sunken city of Acropolis. Here in the red block is the sunken villa, and there is a plan of this and this is the Roman mansion. Yes? Okay, so there are some findings there in this excavation, and this is original photos of the site. You can visit the site. This is the geological trends that have been changed for both the two first photos. We have now the other two, so some of the findings are underwater now, and the depth is very narrow. It's from 1 to 2 meters up to 5 meters. So everybody can fly over with a mask and see, but don't walk on, because then you disturb the findings. These are some of the instruments that we will use: a laser scanner, the lidar, and the camera. And this is our boat, and this in the middle is a unit that with ultrasonic can, there is a tablet also next to it, and can measure and locate the target that is on the findings, and then we photograph. And in the last, in the right, is a multi-beam sonar that we have in our laboratory. So these are the works that we are planning to do, and this will be done next year in 2024. And here are some examples that from the multi-beam sonar. This is a shipwreck that is in Skopelus Island. And also there is a difficult place that we have to go and survey, because during the summer there are a lot of tourists and boats there, so it's very difficult to work on this site. Thank you very much. How much time it was? Yes, I know. So I don't know if we will give any time to Salvatore Martino. Salvatore, do you hear us?
Actually, it's gonna be me. Do you hear me?
Yes.
Guglielmo Grechi. Yeah. Okay. Can I share my screen?
Yes, but you have to be very short. 5 minutes.
5 minutes only.
Yes, because we have to deliver the room. Okay, thank you.
Okay, I will try. Thank you.
Okay.
Okay, so I'll be very short. This presentation is just intended to introduce the planned research activities framed in the Triquetra project to analyze the monitoring strategies for the preservation of assets of high historical and archaeological value, specifically the ancient Roman villa of Giulia on the island of Ventotene and the Panopticon of Santo Stefano and the Temple of Apollo in Egina Colonna. So I'll just probably skip about like Ventotene because Professor Martino already said everything. And Egina Colonna, I think everybody knows about the site. So it's located in the Saronic Gulf, and it's of particular interest, archaeological and historical interest because of the Temple of Apollo, which is found in the northwestern part of the island. And here in particular, considering the geological and geomorphological setting of this area, the main natural threats to the conservation of these sites can be primarily related to the effects of climate change driven sea level rise and sea storms that are actively impacting the stability of the outcropping rock cliffs. So, in order to establish an enhanced knowledge base for assessing the main natural hazards and how their combined effects can endanger these heritage sites, a multidisciplinary approach was taken into consideration. And for this reason, the integration of ground-based and remote sensing monitoring approaches encompassing geotechnical, geophysical, and satellite techniques were considered to be paramount for better understanding and constraining the natural hazards threatening the durability of these exposed tangible cultural heritage sites. So in terms of ground-based monitoring approaches, we will bring deep expertise that comes from several years of management of the Acuto Field Laboratory. And so for both case studies, we're planning on the designing of semi-permanent monitoring systems that on one hand will provide us with data useful for the quantification of both the intensity of the active stresses, like through for example, rock mass thermometers, moisture sensors, fully equipped weather stations, and wave buoys. And on the other hand, that will also allow us to investigate the response of specific target elements deemed as potentially unstable or like more sensitive to the action of preparatory and triggering forces. Then, along with geotechnical monitoring, we're planning also on establishing seismic monitoring networks at both sites, or at least surveys, recurrent surveys, that will provide us with valuable information for the assessment and quantification of, in particular, the actual structural health conditions of the rock sea cliffs and the evolution rate and style of evident or growing slope and ground instabilities, as well as the intensity of environmental stressors, like, for example, through the reconstruction of sea waves data. And for this reason, we are planning on investigating the conditions, like the stability conditions of the two sites, and to monitor the evolution of their structural health conditions over time and their response to the most active and environmental factors in the areas. For what concerns remote sensing monitoring approaches, we believe that they will perfectly integrate to ground-based solutions due to several advantages, such as the wider coverage area that can enhance the detection of changes or patterns that may be not apparent through ground-based monitoring solutions, and also their cost effectiveness and data consistencies that could provide us with consistent and regular data over time and space, also in areas that could be dangerous or too difficult to access. For this reason, at both sites, we're planning on performing 3D modeling through digital photogrammetry for generating digital twins of both sites that will find use for both change detection analyses and numerical modeling purposes. And also to support, in particular, the geological and geomechanical characterization of both these sea cliffs. 2D and 3D infrared thermography surveys will be performed daily and seasonally. This is because mainly infrared thermography will allow us to identify structural elements of interest like rock mass joints or partially detached rock blocks and rock sheets, and it will also allow us to characterize the links between daily and seasonal thermal changes and rock mass deformations. Moreover, hyperspectral and multispectral UAV and satellite-based remote sensing will be supporting ground-based monitoring approaches by providing multiple informative layers. And the main outcomes that we expect to obtain from satellite and aerial remote sensing will be the high-resolution reconstruction of the bathymetry for the two pilot sites, the possibility to perform change detection analyses over time and for wider coverage areas than the one guaranteed by the on-site monitoring solutions, and the mapping of vegetation cover and the quantification of its variation over time and space, and the assessment of the extent of damaged or burned areas after wildfire episodes.
Okay, you
so,
can conclude.
So the only thing that the final aim of all these activities will be to create a database of informative layers and information that will guide us through also like the combination and cascade of modeling approaches and aiming at analyzing future projections on the stability conditions, taking into account for different risk conditions under the expected changes in the climate for both areas. Thank you for your attention.
Yes. Daniel, are you with us also? Yes. Daniel, you hearing us? Okay. So, yes, probably he's not hear us. No response. So, Kyriakos, Themistokleos, you are the last one. You have all the time.
I'm between, I have all the time, I have less time.
Because they gave us an extension.
Okay. No time. I made a brief introduction in the previous session, so I'm gonna go fast, so we can leave. I'm between this session and dinner, I guess. So this is a case study that we do through the Triguerta project that we presented the last session. And this is about monitoring cultural heritage sites using Earth observation. And we're using here satellite methods in order to see any potential risk from natural hazards. This is about the case studies on Hyrokidia, Cyprus. Just not to, in order to avoid my introduction, I hope that all of the visitors that will visit Cyprus and go to the site, that would be, so they can see the site. And it's a Neolithic settlement, is occupied between the 7th and 5th millennium BC. So it's one of the first actually cases whenever people started living from the nomadic style of living, started going and living, into communities. And this is kind of important because when I was young and I started doing my bachelor's, the first year when I was doing my bachelor studies, and I had a history of architecture course, the first slide that my professor showed, it was Hirokitia, Cyprus. And I got really excited because I was in the United States, and it was the first thing that I saw. Everything was about Cyprus. So what the study is all about, the Antiquities Department in Cyprus started worrying about the stability of the site, and especially with people visiting the site, and there are thousands of people visiting this site every year. And on the way to the site, there were some rocks, and you can see them here, that by walking and going to the site is, the Antiquities Department, they were worrying that they might be through the climate change and the stability that and the movement of the site might create any problems and cause dangers to the visitors of the site. The site consists of round houses. This is a replica of the houses, how the houses used to be, and this is located on the site also. And you can see from here, how the people back thousands of years, they use a very sophisticated architectural system, how they use their entrances to go into the village, how the village had a sewer system, they had roads, they had buildings that they used to live together. So it's really interesting to see that thousands of years ago, whenever we had to live all together and create communities, they had a really sophisticated and interesting system of working together, living together, and you can see some of the modeling here, the artifacts that they found on the site. And Cyprus is located in an earthquake zone, so there's a lot of problems with earthquakes, and this is something that we monitor archaeological sites. We try to manage the site and also trying to see, not only what dangers might cause into the archaeological site, but also to the safety of the visitors visiting these sites every year. So what we're doing with this case study, we're using INSAR technology. It's radar satellites that they're passing over the Earth. And from there, we are using a system called persistent scattering. We're using points that we monitor these points from the satellites. And from there, we can see through a series of satellites that they're passing continuously over the Earth. We can see any movements and we can determine any movement that it might cause through these points in a matter of millimeters. Of course, whenever we see this and we monitor this, we always visit the sites. We're trying to use methods and tools like laser scanning, photogrammetry, and so on, in order to see what these movements are, what are the problems that they're causing into the sites. So we're using GNSS stations, reflectors, corner reflectors, different type of tools that we use traditionally using satellite observations. Here you can see some of the tools, some of the GNSS and digital corner reflectors that we installed on the site. You can see here some of the modeling and digital elevation model that we created through UAVs, and we're passing through UAVs all the time in order to compare these models together and see and do a change detection, trying to see what kind of changes these made to the site. Here's some photos, some of the data that we are producing through modeling, and we're trying to see what it might, through the kinetic energy that is is, is causing, through the rocks that are located on the side of the site. We do rock fault simulation, and we're trying to see any mitigation measures that we can take in order to stabilize these rocks and not fall over the visitors that they are visiting the site. I think that would be all for me. Thank you very much, and sooner or later we'll have the results of the project, and maybe next year we can show what we have done with the site.
Thank you, Kyriakos. You were on time. Wait, just maybe there is a question. Is there any question? No. You can ask also other questions from the others.
I was trying to be fast.
Okay, thank you very much. So thank you for being here. Have a good night, and tomorrow morning, 9 o'clock, we start again.